Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email Ratnesh721Kumar721, that is here. And then I will send you that detailed info that how my students they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down um, the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab. Hello everyone, thanks for joining, subscribing my YouTube channel. Today we are going to understand about Cisco SD-WAN, more precisely Cisco SD-WAN troubleshooting and Cisco SD-WAN interview questions. So if you are looking for interview, if you are looking to do the troubleshooting, if you are looking for scenario-based SD-WAN questions, this particular session is going to be very, very important and interesting for you. Further, what I have done that this particular section, again, two parts are there for this particular section. In section 1, you will find the troubleshooting and scenario-based questions. So what I have done that you will find 5 to 6 hours related to troubleshooting, related to different scenarios, and how to overcome if issues are there, if such type of issues are there, how you can go and correct it. Now, once you are very good with the troubleshooting stuffs, then you can go and check the interview related questions as well. So I have put interview related top SD-WAN questions that will help you to crack your SD-WAN related interview. Now, suppose if you're watching this video and you're new to the SD-WAN world and you have less knowledge related to SD-WAN, then what you can do that you can check the link on the top. I have given the link, even you can check the link in the description as well below. You can go and watch those videos. I have different type of SD-WAN courses uploaded in this channel. Some videos are 22 hours, like 5-day course, 4 hour each, like that. So those courses are available. Even if you're looking for CCNP SD-WAN full-fledged course, that is also available in my channel. So if you're new to the SD-WAN, first of all, go and learn the basics of SD-WAN. Now, if you are good in SD-WAN, if you know that SD-WAN, how it is working, how different features in SD-WAN working, then you can go and watch this recording for, I think, 5 plus 3 for 8 to 9 hours. And then you will become very good in SD-WAN use cases, troubleshooting scenarios, and even the interviews question as well. So please continue this video, watch for next 7 to 8 hours. And what I can say, wish you all the best. Please complete this video. Hi everyone, welcome to Cisco SD-WAN Viptela T-Shoot course. In this course, we'll learn in detail how we can fix the control plane, data plane, various transport VPN, say service VPNs also. Apart from that, this troubleshooting and break fix, we have to complete certain tasks related to fix that issues as well. So we'll see some of the configuration, some of the preference options. Again, we have a nice example related to BGP and route preference, TLOC preference, how we can do the baseline troubleshooting from the vManage dashboard. So those things also covered in this particular course. And finally, we'll see that how we can do the troubleshooting, say with respect to zero touch provisioning, ZTP and VRRP issues. So I hope this particular course will be very interesting and informative to you, and see you in the course. We'll see that how we can do the control plane bring up debug. What does it mean? That say I'm going to bring up my control plane. So here you can see that I have my vManage, my vBond, my vSmart. These are the controllers actually. They are connected with a gold, for example, internet. Now these devices, they have their gateway. We'll see that they have their default routes pointing towards the gateway. And we'll see what is the baseline configuration. So suppose if you want to bring up your control plane, what are the things or what are the steps that you have to follow? First of all the software's controller should be installed over KVM or ESXi. So this will be pre-configured for us, means all the devices are up and running. So the VM instances are running. Okay. Now what we have to do, first of all, we have to do some sort of baseline configuration that is termed as a minimum configuration for vManage, vBond and vSmart. So what will be the minimum configuration? Say if you see any of the Viptela device configuration, the configuration basically divided into three portions. You have to do system-wide configuration, you have to do VPN-wide configuration, and then finally you have some global or local policy. So maybe policy related to any type of data policy, centralized policy, security policy, etc. But majorly we have three segments. Now system-wide configuration, we are giving host name, system IP, site ID, vBond IP and organization name. So host name, say system IP, site ID, say vBond or the DNS IP, and then finally we have the org name. In VPN, obviously it should be the transport. So here you can see all these interfaces should be part of VPN 0 because they are going towards the transport. And again, it is a control plane device. So control plane devices, we don't have service VPN. Why we need service VPN for control plane devices? So in VPN, we have VPN starting say from 0 to VPN 512, where 0 is used as a transport, 512 is used as a management, and in between 1 to 511 VPNs we can use as a service VPN. At the moment I'm not using this because we are going to deploy and check the debugs related to control plane. Okay, so that means I have to go and configure VPN 0 and VPN 512 interface. So part 1, part 2, and finally we have some security policies so we can provide, otherwise we'll leave this as a default. So let us check the checklist. We have our checklist. Okay, these three steps are already there. Then we have to do minimum configuration. Okay, we'll see that. I'll show you those minimum configuration. Then we need a route. So we have some static default route, say pointing towards the gateway. Say 227.1 for vManage, 6.1, that is 226.1 for vBond, and finally 225.1 for vSmart. Like that we have the infrastructure. Once we have intercontroller connectivity, then we can go on and install the certificates. Okay, so in this case, say I will go and log into vManage dashboard, and before that I have done certain steps. So what we can do, let me quickly revise and then we'll do that. So what generally we are doing, that I have a CA server, that is my root server, and then suppose for example I'll take only one controller for the sake of simplicity. I have vManage. So the root key, or generally we are telling a public, so public key of this particular root CA server I will install here first. Apart from that, I have already generated CSR, that is certificate signing request. Now it has the public key. Then what I will do, with the help of these CSR, I will upload the CSR to the root CA, and root CA will generate .pem, that is the permanent file. Once I have this permanent file, I will install those permanent file inside the vManage dashboard. So this is step number, for example, 4. This last step, whatever step this is, I'm going to show you, because once we install this particular certificate that root CA has generated, that should be .pem permanent file, then if everything is okay, my control plane will come up and running. That's the overall goal. So what I will do, before installing that certificate, I will go and enable the debug. Okay, because that's the goal here, to check the values. If you want to see the debug in detail, you can go to this particular URL, and I'm going to use the debug, that is debug vdaemon all. So what it will do, you can see that daemon all control the debugging of all the vdaemon process functions. So this actually I want to see. So let me go ahead and install the certificates, and before that let me go and enable the debug. So I have my vManage here, and I will go here. I can enable the debug. So what we can do say monitor start, and first of all let's just enable the debug. So we can do debug vdaemon all. I want to see this, because again we'll copy these debugs into Notepad to further analyze that. So I'll do one thing, I will do monitor start, and then I will give the path. So var, and then log, and then say temp log, and then finally we debug. The moment I press enter, you'll see some syslog type of messages will come, but these are the debug messages that I can see over the terminal. That's the overall goal here. So let me go and install the certificates. I have already installed the certificate for the vManage dashboard. Let me go and install the certificate for vBond and vSmart. I logged into my device. I'll go to configuration and certificate, controllers, and here I will select say vBond. Before doing that, let me show you this, that for vManage I have already installed. How I have done, I select vManage. On the top we have install certificate, click there and then give the path. So for example, I'm going to show you for vBond. Go there, install certificate, select a file, say vBond, my certificate. It is scheduled here in the job scheduler, so no problem, we can wait. And parallelly, let me go back to the vManage. Oh, you can see. So now we are getting so many messages, and what messages we have so far. Let us quickly copy paste and see this, all these daemon messages. So let me copy this here, because its font is very small, so maybe you are not able to see this. So what it is telling, and here you can see that they have a split in the line, so I need to go and show you the proper lines. Say I am installing the certificate for vBond, correct? And we are getting information or logs here in the vManage. So here it is even worse. This we can even read. Alright, so here you can see that okay, you have enabled the debug, and we can see that we have vtela script, get info script call, user bin vconf script, get script info.sh, certificate is string certificate, the serial number, the hash values, the org name, who has given these certificates. So all those things we are getting here. Let me highlight so it will be visible. vScript successful generated at this point. So we are getting certificate related information plus public key algorithm. What is the key for that? After that, DNS resolve. DNS resolve. See, DNS means my vBond. My vBond IP is 2262. DNS send. Self-signed certificate, no need to panic. So we are getting all those messages. Then again, see, control connection, stage, change, severity level, new state up, vconf trap, processing. So we are getting the certificate installation related messages, and you can pause and you can make a note. Even let me quickly open this and let me quickly scroll this so you can check this message. Long message, correct? Alright, let us go back and see there what we have inside vBond. So if I go inside vBond, because I install the certificate for vBond, if I check so certificate installed, this is the certificate that we have installed. That is one thing. If I check show control connection history, the moment it is not showing any history, so no problem. Show control connections, no control connection. We'll wait. I'll come here. I'll check show control connection. And if I go here and if I check history, because you can see the history that to whom it is trying to connect, and try to connect with the IP00, the system IP00 with the protocol DTLS. The device is vBond, the personality is vBond. But here you can see dconf fail. Now this dconf fail, if you go up here, if you see dconf fail means DTLS connection failure. So it is telling that it has some DTLS connection failure, and it is trying to resolve the DNS, that is the vBond IP 2262. Never mind, we'll go back and install the vSmart certificate. Here you are getting message that okay, it is successfully installed, no new update, no problem, and they have the list. We'll see, we'll verify these list as well. What is this list? vSmart list for vBond. We'll verify. Let me go back to the certificates. Controllers will come here to this point. If you go press here, you can see for vmanage everything is green. For vBond everything is green, means add device, generate CSR, upload certificate. Finally I'll go here and install the certificate for vSmart. Select it. I have vSmart permanent certificate generated from my root CA. Click here. This is scheduled. We'll wait, and parallelly I will go back to the here. You can see again we have so much message. So again it is telling that okay, script is running and we have new element in the certificate, and let me mark this place, that is user bin vconf. So let me go to, so for example vSmart, here we haven't enabled debug, correct? I can go to vshell, that is v as a vector, vshell, and then we can go to say cd, and what path we have, say user and bin. So let me go to user bin ls minus la. What I'll do, I will grep say today's month, say okay. So you can see that April we have these for folders or files. So before going further, what I want to do here, let me quickly stop the monitor. So monitor, stop, and then the path var log temp log, and then the vdebug. Okay, so we can read this. All right, so scroll up because we want to read now the informations related to vSmart when we try to install the vSmart certificate, and from where we are getting from this point. So we have the log. Where is that log? You can see user bin vconf script. So can I check this in the vSmart also? Suppose if I have this folder, otherwise I'll check inside the vmanage. Permission denied. Okay, and if I'll check this later on. So what it is telling, that certificate request date validity, certificate request date validity, the full path, the public key, the number, everything. Okay, means my vmanage and actually vBond both are validating now the vSmart certificate because they have to do mutual authentication. Okay, and if they are not able to verify, say, the serial number, then the installation, means although it looks that everything is okay, but you'll find that control plane will not come up. So here we have Viptela V Edge System Manager notification, system logging change severity level. If you read all these messages, then you'll come to know that what are the things happening behind the scene. Okay, so all the certification process and everything. All right, we are not panicking. And finally, after those panic message, what message we have? Validating device certificate serial number 1020 with the org name, because we have to verify the org name of the vBond. This is the system IP of the vBond. We can see that what is the system IP of the vBonds, so no problem. We'll check the configuration as well. Personality is vmanage. The peer type is vSmart. Peer system is 06. So we'll see that what is the system IP for different devices. Maybe 06 is for vSmart. Let us see quickly the configuration. Exit, show run system. Yeah, 06 is system IP of vSmart. No worries. Then we'll move further. We manage name, user admin, VIP, domain, etc. Now, if we go here and check show control connection, now control connection is showing that I have one control with vSmart and I have one control with vBond as well. Rest all you are seeing that the system IPs are 0, means they try to establish the connection with the 00 system IP. That's not actually correct IP. So that's why it got failed, or those are the initial connection tries that are still showing here, and after some point of time it will be age out. So after some point of time you will find only two connection, one with vSmart, one with vBond, obviously over the internet because we have only one transport. Okay, so I hope that you understand that how you can check the debug message. That was the overall idea of this particular recording. So let me quickly go back to the dashboard, and if everything is successful, you find this is 1, this is 1. Okay, so let's stop here. Next we have data plane debug. Data plane debug basically mean that I'm going to do the transport debug. So here if you see my topology, let me tell you that what I'm going to do here, what target we have to achieve. So for the moment we know that okay, that we have VPN0 interfaces, and I'll show you the configuration. Last section I haven't shown you that configuration for vBond, vManage, and say for example vSmart as well. So what is the baseline configuration that we had for these controllers? Then here you can see that inside VPN0 for this particular vEdge, I have two interfaces. One is gig01 going towards gold. One is gig E0/2 going towards MPLS. So what stage we are so far? In my vManage dashboard, already the chassis number and the token is there. So what does it mean? That means I got one file from Cisco that okay, you can use cloud-based devices. For those cloud-based devices, you get one valid list of chassis number and token. Now this token is nothing but one-time password OTP. Once they satisfy, means once the vEdge will authenticate with this chassis number and token number, then they will install the serial number. We'll see that how we can verify that as well. All right, so you are at this point and we want to do the debug transport. Why? Because I want to debug the VPN0 because VPN0 is the transport. All right, so let me first go to my vManage dashboard and I'll show you that I have tokens. Here you can see that I have list of the chassis number and I have the token number. And what's the state of this token? Here you can see that the state is token generated. Have you seen that? Token generated. So this state should be certified. So whatever chassis number and token I'm going to use, it should get satisfied. So where I am, let me go and do that. I have my device here. Maybe here, let me log in. This is my vSmart. Yeah. So I have my device here. Now what I will do, everything is set. Let me show you a little quick the system configuration, the VPN0 configuration. So VPN0, you can see that I have interfaces gig 00, see gig 00, that is nothing there in gig 00, but in gig 01 I have this IPsec, color gold and rest of the configuration. Gig 02, that is going towards MPLS, encapsulation IPsec, and then we have gateway for these VPN zeros. Apart from that, I have other configuration as well. So I have VPN 512, here you can see, and then I don't have other things. So if I go and check show run, say policy, show run security, I have default security policy. And if I do show run OMP, I have default OMP policy. So that's it. These are the configuration I have here. Now what I want to do here, I want to do the request for vEdge Cloud activate, and I want to give chassis ID. What's the chassis ID? So I have in the notepad the chassis ID and the serial number. But before I activate this, let me do debug transport and events. Okay, and then I want to do the monitor start, and then where is that location, var log temp, and then vdebug. Correct. Now I will do this command, that is request vEdge Cloud. So let's do in proper manner, activate chassis number, paste it, then token number. This is my token number here. Let me quickly copy and let me paste. Enter. Now what I will do quickly that I will stop the monitor, otherwise we'll miss the debug. So monitor, stop, and then the location. Oh, I'm getting so many. Monitor, stop, say log, temp, and the v debug. Alright, so we have so much of log that we can check and analyze that in the transport what happens. And let me scroll it down till here. But by the end of this, you can see that successfully install the root certificate chain. In the bottom line, you can see. So first of all, let me copy this. And I have the notepad here. I can paste it. We'll see. Okay, so let me start the check the marker as well, so we can mark some of the points. If I scroll up here, and if I go up, okay. So here you can see that chassis number and token number I have given OTP initiated, say a one-time password, like in banking, we are getting OTP at the mobile phone. This token is actually OTP. Now what it is doing here, you can see here that the flag, device ID, VBond, etc., DNS, site ID, root cert, port, so all these flags. And let me do up to here. Okay. So now behind the scene our vdaemon, see, because vdaemon will be there, because this daemon file is doing, say, key pair certificate, then they are checking the T-logs, WAN interfaces, because we have two WAN interface, one is gig E0/1, one is gig E0/2, one is over internet, one is over MPLS. Key pair self certificate exist, yes, exist. Then let me scroll down. So here it is getting the information about T-log, transport locator, what is the color, system IP, encapsulation, what to do next. Now they have a T-log generated, now T-log deleted. Now key pair already exists. T-log key pair exists, certificate signing is happening, key pair exists, certificate signing is happening. By the end again we are getting this. Do not panic, we are installing the certificate, be patient, then DHCP and those information, and if I scroll down, vscript. So you can see that we have various things that is running behind the scenes. A vdaemon, vscript, generating CSR for the VH. One very important point here we have to understand in the Viptela fabric, that say we know that we have control plane devices and we have data plane devices. So data plane devices are always more than the control plane devices. Control plane devices will be less. So that's why we are doing some sort of manual certification, and we can do it. There is no problem. But for data plane devices, because they are huge in number, so we can't do manual certification. That is not suggested actually. So for that, mostly we have automated certification process. And that's why here you can see the CSR generated, the certificate generated, because all these devices, they are coming with root CA install inside this. So we don't need to go and push the root CA from the root CA server. They are already there. Only thing I have to do is to activate the chassis number and the token, and you will see once I activate the chassis number and the token, what is happening. So I am here to the vManage, if I do show control connection, vSmart, see, I have one vEdge here, correct? Now what I can do here, I can SSH to this particular, I have to go to vCell first, and I can SSH to this particular device. Yes, admin, and I'm inside this vEdge. Now for this particular vEdge, if we see show control local properties, here you can see that with all the information, what's the status of the chassis number, serial number, token number. So still it is using the token number, but some point of time you'll find that the token number is invalid and serial number is there. Okay, sometimes it's like this only, but we don't have any problem on this. And then I can check show control connection, say history, that how he forms the tunnel. So here again one very important point in the Viptela fabric, that we have one device called vBond. It is working as a what? It is working as a orchestrator. It's the orchestrator plane, correct? Now whenever any new device is coming inside the fabric, first of all it should authenticate with vBond. Now vBond will send, first of all it will authenticate and form as a temporary DTLS tunnel, and then once he is satisfied, once he is okay, then he will pass these information. These informations means the chassis number and the serial number to vManage and the vSmart, and these IP addresses he will pass to this particular VS device. Then this tunnel will be broken and we have permanent tunnel here with the vManage and the vSmart. So this will be the permanent tunnel, and this tunnel will be teared down. So if you go here and if you check show control connection, you will not found any tunnel with the orchestrator. So I can go here, I can do show control connection, and you can see here I have tunnel with vBond, but that is showing 000. vBond 000. vManage I have, and I should have connection with vSmart as well. At the moment it is showing that it don't have. Okay, so show interface description, if I go and check, the interfaces are up and running. No problem. We'll do one thing, we'll go back to the main dashboard where I have my vManage, and here we'll see. So now I can see here that all these devices are up and running, means my control plane is also up, data plane is also up, but here control is down. So what it is telling, control connection having some issue. No problem, we'll give them some time so it will fixed, means the transport will be fixed. But I hope that you understand that how you can check the communication and different type of channels in between the message happening between the control and the data plane. So let's just stop here. Now we have OMP debug. Now you can see that our topology is growing. We have implemented one of these device, that is VSDC1. Now we are going to implement VHDC2 maybe in other data center. So all the configuration is done. I'll show you the configuration. So let me show you the configuration of all the controllers and all the vEdges, then we'll move. But I haven't activated this. Before doing the activation of this particular vEdge, we will enable the debug and then we'll see what happens. Okay, even I'm going to explain how OMP works. So let's go back to the configuration. First of all, let me show you the configuration for DC1. Like in Cisco, we are doing show run. You can see it's a very straightforward configuration. Some of the things will be by default there, means those are the factory default, and those will be running there in the devices. Like OMP will be, overlay management protocol will be by default. You will get this with the box itself. Then your security configuration, so whatever security configuration you have, that will be also by default. This portion, this portion, this is default configuration. Obviously you want to change it, you can change it. AAA factory default is there. So what we have done here, we have changed only the system wide configuration, VPN 0 configuration, and VPN 512 configuration. You can see here just for reference. And if you want to check the description, you can check the description. Let me exit so I can show you the vManage configuration. All the controllers configuration are more straightforward than the service devices or the branch edge devices configuration. Let us see the vBond configuration. Inside vBond you will find this local keyword, and the rest of the configurations are very easy and straightforward. Finally, vSmart. This configuration also, you can see it's very straightforward and simple. So now we know the configuration of all the devices. Let us go back to our DC2. Let me show you the configuration for DC2 as well. Let me do show run so you can see this configuration as well. It's very straightforward, correct? The same type of configuration, only the IPs has been changed. So what I want to do here, I want to start the debug OMP. Okay, and before doing that, let me quickly revise your theory. So what is happening in the Viptela fabric, that I have control plane and then I have data plane, correct? So suppose this is V edge 1, just for example, or let me do that what we are doing here, that I have control plane devices, my vSmart, vManage, and the vBond. Actually, vSmart is the control plane device technically. vManage is the management plane and vBond is the orchestrator plane. So I have DC1, DC2. Now what is happening, that you have two tunnels. One is the DTLS tunnel, that is from your control plane to your data plane. Now this particular DTLS tunnel is carrying, or it can carry, say OMP or netconf, SNMP. All these things will happening inside this DTLS or maybe TLS tunnel. Okay, because this is there for control plus some of the management traffic. But the actual movement of data will happen between one edge device to other edge device, or branch device to other branch device inside IPsec tunnel. Okay, so this IPsec tunnel we'll see in the upcoming troubleshooting section, so we'll leave it. But here, suppose if you have two transports, say MPLS and internet, over MPLS and internet over VPN 0 interfaces, you have the control connection, correct? Now these control connections, the overlay protocol for these control connection is, yes, is OMP, overlay management protocol. So here you can see the attributes of DTLS, OMP, netconf, SNMP, but here we are going to see the overlay management protocol and its debug. So let's start the debug for OMP. How I can do that? Debug OMP, and I can do, say, packets and events. So I'll do packets and events, then we'll do a start, our monitoring start. So monitor start, and then our location where Even I can go to the bash shell and I can check this location as well. So both the options we have, log and temp log, vdebug. All right. So let me activate this VeloCloud, activate, and then I have to give the chassis number and the serial number. So I have this chassis and serial number copied here. This is the chassis, paste, and then the token number. So let me go back here and copy and paste. Now before pressing enter here, let me go back to the dashboard where I have the vManage. Here it is. If I go to configuration and devices, the difference I want to show you here is, see, DC1 is red. Certificate install failed. We have red mark, so that's why it is not forming the control plane. Okay, so we have failure here, and that is actually good. Now you can see here that token generated, and this time we are going to activate the key. So the main reason behind this failure is that key activation is not successful. Now I will go here to the new device that we have somewhere. So many devices we have, correct? Let me go to the correct one. Okay, and we'll press enter. The moment I press enter, error certificate verification fail. We are again getting certificate error verification failure. And now we can see control connection, because now we are debugging for OMP, and OMP has its own attribute obviously, but let me stop this little quick. So I can do monitor stop, and so we are getting this error. It is telling that your certificate is failing, and now you can see that with help of log also you can get this message. Verification error, unable to get local issuer certificate. So it has the issue with the certificate. And why it has issue with the certificate? Because I'll tell you why we have this issue. Generally all these boxes, they are coming with pre-installed certificate. Okay. In lab section, suppose if it is not coming with a pre-installed certificate, I need to add the public key of the root CA. Okay, and for the lab purpose I haven't added it, just to show you that now if you go here and see the, let me refresh this, and we'll go back to the certificate. Even I can't see the VHDC2, correct? And we have complete failure for the certificate. So now what I will do, behind the scene, I will go and add the public key, and then I will try to activate one more time. Again we'll see that what type of logs it will generate. Okay, and before that, doing that, let's quickly check this log as well. So let me scroll up, callback. Let me scroll up from where it has the error message. Say OMP daemon, because we have debugged, I started debug for OMP. So that daemon is running. Let me go up. from here. Yeah, yes. So from here, you can see the chassis number and the token number we have given. Token is OTP type of password. So what I will do next time, I'll give different OTP or token. So we have uh, 12 different serial number and the token, so we can use others as well. Let me scroll down. So you can see now the daemon OTP installed, root installed. Try to installing the root certificates. It has issue, activation issue, self-signed issue. Now you can come to know, suppose if your data plane is not connecting with the control plane, you can check these logs. You can enable, say, a debug related to OMP, events, and daemon. And by default, daemon is running there, and you can check that why it is failing. The other option we have to check in shortcut without enabling any type of debugs, we can check show control connections history, and here it is telling that CRT were fail. So on the top we can go here and we can highlight, say, fail to verify peer certificate. Okay, so that's what that's the issue actually, that it is not happening. So let me quickly add the public key behind the scene. All right, so you can see that the public key installed, and then I will activate the chassis number and the token. So this time I'm going to use the different chassis number and the token. Let's do it. And before doing that, we need to enable the debug as well. Otherwise we can't see this here in the screen. Otherwise it will be stored, and where it will be stored, it will be stored at this location. So I will show you that how you can go to this location as well. And this is the temp log, and we debug. So we'll start the debug. OMP events debug OMP packets. All right, so let's do that chassis command that we have. Yeah, here it is. Let us give the new chassis number and the token number, and let's see. Copy, paste it, then the token, copy and paste, enter. Error certificate fail. New route IPv6 protocol. No problem. Still it is telling that you have some issue related to certificate, and if I go to my dashboard here, now you can see that one V edge is up, one is down, and we'll give this some time to do the authentication negotiation. No problem on that. And if I go to the configuration and devices, you'll see here. So now you can see both the device certificate got failed. That's why they are red. Okay, all right. So I should use the correct certificate, and the everything is okay, but I should use the correct certificate. So in the next section or lab onwards, I will install all the correct certificate, and I will make this particular lab running and functional, and then we will check how we can debug IPsec, how we can again debug, say, OMP, how we can do troubleshooting with different test cases or use cases. So at the moment we are good. Let's stop here, and before stopping here, let's finally go back to our CLI, that is the device itself, and let me quickly scroll up so you can see the error message. After adding the public key also I have some error messages that is popping up here. VDaemon DTLS verify, proc challenge, VDaemon certificate error fail, it's fail, etc. Okay, so let's stop here with the failure, and next recording will come up with the success. Transport VPN and OMP failure. Now everything is up and running in our topology or in our Viptela fabric. All the certificates and everything is properly installed. And this is the topology that we are going to do the troubleshooting with respect to, say, VPN. That is again the transport VPN and the OMP. So what we are getting, that inside the vManage dashboard, we are getting alerts. We have so many alerts related to transport and OMP failure. Now we have to go to all the devices one by one and correct all these alerts. So here you can see that we have alerts related to, say, site down, BFT down, major control T-lock down, BFD down, related to different edge devices. So let me first go to the vManage dashboard, and I will show you that how you can check the alerts. Here I am inside the vManage dashboard. On the top you can see that out of 4, one of the V edge is down. So if you go and click, it will show you that okay, your V edge branch 1 is completely down. That means my control plane device is not able to reach to this particular data plane device. Okay, then later what we'll do, we'll go and check the alarms. So let us go here. If I go here in the alarm, you can see that we have major, critical, minor alarms. You can click here to just see all these alarms one by one. And if you want to see detail, say for example for .10, the OMP, and what's the name for .10, you can verify, that is the branch DC1. So it is telling that OMP is down. You can go to the more, see the alarm details, and here we have the details about that. Problem, cause, what is the cause? OMP was shut down, admin shutdown. Okay, so someone has done shutdown for the OMP, and that's why it is showing OMP session and node down. This is a critical alarm we have. Okay, so what's the target now we have? We'll go and verify the OMP related and transport VPN related all the alerts and the alarms. Now one very important thing here we have to understand, that see, whenever we are talking about, say, devices managed via vManage, so ideally what's the case we have in vManage infrastructure or in Viptela Fabric infrastructure, that we are assuming that all the devices that we have in the fabric are managed via single dashboard, and that dashboard is vManage. Means you have template, we can tell that device template to configure all the devices, vSmart, say vEdge, vBond, all the devices. Then we have policies to do all the policy things. Okay, so for the moment we are focusing on the templates, device templates. Now if I go inside the configuration and template, you can see here that few of the devices are not attached. Means these devices are not managed via vManage. That means if someone can go detach this and then he can do local changes, the best option to do troubleshooting for these cases is that already you have template. That template no one has changed, assuming. So that template again you can attach. If after attaching the template it is coming up, it is showing everything, then it's very good. So that is one approach. That suppose if you don't know troubleshooting and you are like a system admin and you find that okay, this is the case, you can simply attach with the recent template and it will work. For network engineers, always what we used to do, we go and log to the device. So here I can see my vManage. Now if I go to my vManage and if I type show control connection, say how many VH I have, VH 1, 2, 3 VH. So I don't have one of the VH here. And suppose if I don't know what is the out of band management IP, even I can't log into that VH. Okay. So here if I go to vshell and if I do SSH to any of the device, and for the sake of simplicity, we have IP addresses, system IP addresses like .10, 11, 12 and 30 for all the VHs. So say I have 11 here, I have 10 here, I have 13 here. That means I don't have .12 IP. So suppose if I try to SSH to .12 from my vManage, I'm not able to do, because this particular system IP is unreachable. That means without having the out of band management IP, I can't even log into that device for troubleshooting. So next option I have, that I have to call to the local engineer at that site. He will console, he'll share the WebEx, and then I can do the troubleshooting over WebEx. Okay. Alright, so we are here somewhere. We are going to log into the device, that is say VHDC2. So interface description, if I check, so it has IP, say the management IP I'm checking, 207 to 11, and we know that what system IPs we have. So we have system IP say .1. So we have system IP say 10, .10, 11, 12 and 13. So if I try to guess, say okay, I want to guess this DHCP IP, for example. So I can exit from here. I can go to say 12. 12 is no longer available, so I can go to say 13, admin, show interface description. So I can't guess, even it is in the range of /24. It's very difficult to guess that what VH IP it has, but sometimes if you want to guess, you can do broadcast ping. So you can do ping to 0, VPN say 512, and whatever IPs it is responding, you can check that IP. Sometimes we are using this method just to know that which are the IP addresses who are up. Anyways, so for that we don't have any other option rather to do the WebEx, and someone will do the console, and the issue will get fixed. What I'll do, rest of the devices will fix. So I'll go to say I'm already logged in to VE branch 2. First, let us see what's the issue. We know that issue is related to OMP. I'll check the OMP. OMP is up and running, and then I'll check say show interface. Let me do show interface description. It is showing the gig E03 is down, so that is inside VPN 0 interface gig E0/3. Let us see that is this interface is down. Even I can check show run VPN 0 configuration. Gig E0/1, no shutdown, 0/2, no shutdown. So interface description. Let us do show run little quick. So 02, even I don't have 0/3 interface. Okay, so maybe that interface that we are not using, and for this obviously we can refer our topology diagram. So if you see our topology diagram, you'll find that okay, one interface is going towards say MPLS and one is going towards say internet. And the good way to verify this, we can do show control connection, and we should have 3 control connection, 2 with vSmart and 1 with vManage. So VE branch 2, whose system IP is dot, let us see what system IP is, .13, we don't have any issue. So VE branch 2 is good. We don't have any issue with this. So I'll go back to one step back. 12 is not available. I'll go to 10. Okay. Now we'll check the same thing. What is the OMP status? See, it is shut down. Then I'll check show interface description. What is the VPN status? Even the VPN 00 is also down. So what I'm going to do, first of all, I'll enable the debug, say OMP and packets and events, obviously. Then we will start the monitor, and the path, we know that path is log temp log and then the vdebug. Great. So I'll go here. I'll go to OMP and I will do no shutdown. Commit. So we can see the OMP related logs as well, and quit. This device has been managed via vManage. You can't do anything. So as per network engineer perspective from CLI, we have seen these things. Now I have to go inside the vManage dashboard and fix this vEdge DC2. So I'll go back to my main dashboard and I'll go to the template. What I will do here, that vEdge DC2, it is attached. I will open the edit for this particular configuration. I will check where is the OMP. So here is the OMP. I will do no shutdown to the OMP, correct? And then no shutdown to this also. I will update, but I want to see the debugs as well, correct? To this particular system IP, that is 0.11. So for that I will go to the SSH, because from vManage also we can do the SSH. I'll go here to 11. We'll wait. Once we'll get the login. Alright, so now we can do monitor start and the path and vdebug. Alright. Then as I am here, let me go to OMP, no shutdown, and VPN 0 interface gig E0/0, no shutdown, commit and quit. Aborted. System vmanage. This device is being managed by vmanage to the CLI not permitted. So you can see that here also the CLI is not permitted. So finally we have to go inside the template, and from template we have to check that. So we'll go here, we'll go to edit. I'll go down, and we will change the parameters. No. No. Update. And while it is updating, I'll take that opportunity to go here to see those things. So now we can see all those logs, correct? And we are waiting for these logs actually. So we want to read out. Let me end this, and then I will do monitor, stop, like we used to do, temp, and we debug. Now it is a stop, so it will not come again, and we can analyze that what is happening, what happened initially to this particular device. Now you may think that okay, we know that what's the issue and then we are doing the debug, correct? So is there any way that all these debugs will be stored? That we can verify actually. So suppose if debug is enabled, then by default they are storing somewhere. We don't actually, it's not the standard process that you are enabling debug on the console and you are checking. Rather than you can do vshell and you can go to that location. I'll show you that after reading out this debug. So this OMP related debug, receive update, VPN instances, receive update, all those things, peer, VPN, current status is down, transition operational period is up, path, okay, great. So let me quickly complete this because we can get so many good important information from here for our troubleshooting tools that we can add for our practical purposes. So what it is telling that OMP state change severity level. So this is the alert that it is generating in the dashboard. Multicast protocol kernel. There are other things also coming up. Then see the interface. So I have done this interface 00 no shut as well. So for that alert is also coming because that is related to transport VPN. Now we can see that okay, it is coming up. What is the default gateway? Now the default gateway for VPN 0 is available. It is initiating the connection. The RIB is being initiated. Processing trap, Viptela, OMP peer state change. Inside that, the trap is initiating. It is generating one severe majority alarm. And then again, we are getting vdaemon, do not panic. And if I scroll down, you can see the T-lock. Now they have the T-lock. How the T-lock, private and public T-lock will come into the picture, how the underlay and the overlay work. Here you can see this important information that new event send handshake to this particular IP. This IP that is 0.6. Let us verify that it is related to which controller. Okay, show run system. So this is the vSmart controller. So now it is validating itself with the vSmart controllers and the multi-protocol address families. So OMP debug packet that we started, it is doing the initiation for the OMP. Capabilities is going to be started. Then actually these are the things related to IPsec. So Now they have the local TLOC. Once they will get the remote TLOC, once they will get the security, then they will start forming the IPsec tunnel. So behind the scene, these devices will form the IPsec tunnel, and for encryption and length, we are getting all those information. Say our BFD was also down. So you can see now that BFD is also coming up. BFD is telling that what is the local, what is the remote session and all. So if I go here, if I type show BFD session, this type of information that we are getting on the top. So IPsec has formed. Say first of all OMP has formed. So what is the sequence? What happens here? We know that once you bring up the data and control plane, control and data plane to more precise, then your IPsec tunnel BFD will automatically form, correct? So what is happening here? So suppose I have two branch 1 and branch 2. Sorry for this, let me clean this stuff. So suppose I have two branch 1 and branch 2, and say I have control plane. Obviously here inside DTLS they will use OMP protocol to exchange the information. So this guy has a local TLOC. A TLOC is an attribute carrying a system IP, encapsulation and color. Okay, this guy also has his system IP, encapsulation and color attributes along with other attributes as well. Now they are sending their keys, but before that, what will be the step 1? So step 1 here, that they will establish the control connection. So over DTLS or TLS, they have established the control connection. Then what is the step 2? Step 2, that once they have a control connection, with help of OMP, they will start sending their information. So they will send their route updates. They can send their local TLOC plus key value. So for site 1, this guy, he will send the local TLOC plus the key value, that is say for site 2, this is site 1. Now it's the duty of VSmart that will exchange the TLOC information and key information. So now he has the remote TLOC, he has the remote TLOC, now he has the key, and then the stage number. So suppose this is step number 2, then the stage number 3, they will form the IPsec connection. So point to point type of IPsec connection. From here, obviously over the transport and over the VPN 0 as well, they will form the IPsec connection, and once they form the IPsec connection, this tunnel will be tracked with BFD. So IPsec is step 3 and BFD is 4. You can think 3 and 4 is going on and on parallelly. Okay, so this was the thing. Now if we verify this, because this is up obviously in the dashboard also, it will show you clean and up. Even in the dashboard, we go and check the control down. Still one control is down because one device is completely out. Okay, so this is the way that parallelly I can go and fix those devices, those I have access via vManage. Those devices which is completely out, for that obviously I need local TS help, otherwise I can't get the access. So now we can see here that BFD is 4 because it has 4 tunnel, OMP is 1, control connection, that is the DTLS connection. So here you can see we have different things. Okay, so control connection, 2 with VSmart, 1 with vManage, 2 with VSmart, 1 with vManage. It is showing everything. Now interesting thing here that for VSDC1, BFD is also 0, OMP is also 0, everything is 0. So although we fixed everything, but still we can see that one of the system IP carrying this VSDC1 is still not good. Okay, so let me go to this particular device and let me fix this. So first of all, let us check that this is managed, this DC1 is managed via template or it's a standalone via CLI. I can go here, I can see that DC1 is a standalone. It is not managed via template, so that's good. I can go directly to my say vmanage and I can reverse telnet to 10. This is the easy way that we can reach to the device. I can check show run OMP is turned down. So OMP, no, shutdown. Then do show interface description, we'll see. Yes. Show interface description. Here everything is up. So what I will do quickly, I will do transport debug. We'll start the debug. So we'll do debug transport, say transport events. Now I am not monitoring it over here, and in the meanwhile I'll do one more thing. So again I will make this OMP shut down, so it will generate all those events and debug, and then I'll commit it. We'll wait. So in the meanwhile it will generate all those debugs. Now I'll do no shutdown, commit and quit. Why? Because I want to show you the place where you can see all those things. So I can go to cat, say var log and temp log, and then finally we have vdebug. See, everything is getting stored here. So if you are not using that monitor command, so you can go here and then you can read all these transport related events. Obviously you need to enable the debug, then only you can go and see all these things. So final few messages we have that BFD status change, it is up, this is vEdge or vHub, this is up, handshake up, OSPF daemon is working, etc., etc. So we have all these messages. Now I can check show control connection. I should have 3 control connection. I can check show IPsec inbound connection, and same number of actually things we have, or same number of connection will find for the BFD session as well, because we know that the number of IPsec section or sessions are equivalent to number of BFD sessions. So I can do show BFD sessions, and here it is. Here also you have 4, here also you have 4. If you want to check the key, yeah, then you can do show IPsec outbound connection. You can see SHA-1, HMAC, etc. Now quickly go to the dashboard. I'm going to the dashboard just to see that what's the status now. I'll go here. I'll go click and we'll see that what status we have now, because initially now you can see BFD has 8, 3, 4, 4, 4. So for one of the branch has 8 BFD. That means it has 8 tunnels. The other branches, they have 4 tunnels. OMP is 1, control connection is 1. Later we'll see that how we can not increase, but how we can decrease the number of IPsec connections that we don't need. Okay, still we can see that one of the control is down. That is, if I go and click here, let's see which control is down. It is down for one of the branch. Okay, so I'll fix this particular branch, and then we'll see next troubleshooting sections in the upcoming recordings. Now customers are telling that we have to restrict the number of VPN connection. Now if you see that this particular topology diagram, we know that how this VPN works, correct? We know that, okay, once your control and data plane is up and running, As per our diagram, whatever we have, so in our diagram, we have 4 devices, say 1, 2, 3, 4, and we have 2 transports, say MPLS and gold. Now, how many IPsec tunnels they will form? So we know that by default it will form full mesh type of topology. So that means it has IPsec tunnel from, say, let me draw it properly, otherwise it will be confusing. So from, say, one device to other device, say I have 4 devices, one IPsec connection, other IPsec connection, other IPsec connection. Okay, so like that, if you see here, total number of IPsec connection for one device, it will be 3. Other device, it will be 3. So 3 into 4, 12. But maybe you will find here that some of the links are common. So you have to remove that common link as well. Okay, but what is the criteria here? That my customer, they don't want IPsec tunnels. If for example, initiating from gold and it will go to MPLS and it will go here. What they want connection like gold to gold, MPLS to MPLS. That is the term restriction. So let me show you first that what I try to convey here, what I try to make you understand here. So suppose if I go to any of the device, any of the VH device, and if I go and type show IPsec inbound connection, you can say how many tunnels we have. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And why it is? Because it is telling that 6 tunnels you have over MPLS and 6 tunnels you have over internet gold. Now again, let me filter this so we'll understand this more. If I do say include only one system IP, say for example, my local IP is 12 and remote is 13. So how many tunnel I have, for example, from one site to other site? So this will give you clear idea that yeah, I have say one device here and I have one device here, 2 connection means 2 ISP. So ideally how many I should have? This system IP is .12, this system IP is .13. So ideally I should have say 1, 2. So one is over gold, one is over MPLS. So one is over gold, one is over MPLS. But here you are finding 4. How? So it is telling, okay, not only we have gold to gold, but we have MPLS to MPLS. That is the restrict, means internet over internet, MPLS to MPLS. But here we have mix, gold to MPLS, MPLS to gold. So that's why the number of tunnels is just twice, and that the customer don't want. So what he want, that he want only restricted tunnels. Now in this particular lab, what I have done, that all the devices are control plane and data planes are working properly for all the devices. And here we can see it's still loading, but you'll find that our dashboard is clean. That means we have all the edge devices that is running. And just to make this simple, what I have done, that all the devices are in CLI mode. Okay, so let us go and do this requirement. How we can do? So here I can go to one of the branch. First of all, I need to see that VPN 0. So you can see color. The answer of this is that color I have to use with a keyword called restrict. Okay, even I can go and write a script, because for all the devices we have same configuration. Tunnel interface color is, it is using gold, and then use restrict. Likewise, interface gig 0/2, the tunnel interface Encapsulation we need only color. So tunnel interface color is MPLS restrict. Correct? Commit. Oh, you can see that if you give wrong name, then it will throw an error. Name should be correct. So let me go back. Tunnel, first of all, I'll go to the correct interface, say VPN 0, interface gig E0 / 1 and 2, correct? Alright, so for this we have color gold and restrict, yes, and then we can go to interface gig E0 / 2, and for this we have color MPLS and restrict. Now we can commit and quit, exit. The same thing I'm going to do for the rest of the devices. So even I can take some, I can copy it in Notepad and I can do it so it can do fastly. But anyways, we should check that for all the interfaces, say VPN 0 interfaces, those are gig E01 and gig E02. Okay, so we should check that first. Show interface description. So here you can see that 01 and 02, and if I do show run VPN 0, we can figure out this. So I can go to conf_t and even I can copy paste also. Color MPLS, restrict. Then I can say exit. I can copy paste up to here. Color is restrict. Validate. Show configuration what we are validating. If I exit, even we can use top as well. So if you do top, and then if you check show configuration, what new configuration you want to commit, it will show you, correct? And this we can use as a script, so we can use for other devices as well. Now I can exit from here. I can go to say 10 and 11 as well, because 10 and 11 are DC1 and DC2, and I should check show interface description, what is the VPN 0. So here also gig E01 and 02, and now I can copy and paste, validate and commit and quit. Now the final, that will be .11. Yes, give the password, paste here, commit and quit. This is, maybe here we have different interfaces, so that's why it's very important to check. But anyways, we are very good up to here. You can see here we have 01 and 00 and 01, so that's the thing. Anyways, so what we'll do here, if I go and check show IPsec, say inbound and outbound connection, now I can see here the number of tunnels are very less. Okay, and this is what? This is .11. So .11 has one tunnel with 12, one with 13, one with 12, one with 13. We don't have tunnel with .10. So that also we need to check that why you don't have tunnel with .10. Okay, so we can always refer the topology. Let me go back to the topology diagram. So suppose we are in DC2. DC2 has tunnel with 12 and 13. Why you don't have tunnel with .10? Let's see. So if I go here to the topology diagram, we are at the DC2. Say we are here. So it should have one tunnel with this and one tunnel with this, but it is showing now. No, it is not showing that tunnel, correct? So before moving further, let us go and check any of the other device, say for example 12, and we'll check show IPsec inbound connection. Now here you can see that it has tunnel. So I am who? I am 12. So 12 has tunnel with 10, 11, 13. So it don't have tunnel with 12. 12 obviously don't have with 12 itself. So it should have tunnel with 10, 11, 13, 10. This is correct actually. You can see this is correct. So what was our target? That we are looking for 6 tunnels only. Now we have MPLS to MPLS. You can see MPLS to MPLS, MPLS to MPLS. We have gold to gold. So like that. So now it's actually correct. So what it is telling now that you have 4 devices and say device 1, 2, 3, 4 and 2 ISP. So you have tunnel 1, 2, 3 and then you have tunnel say for example with MPLS 1, 2, 3. That is total 6. Now let us quickly go and check the other as well. Then we'll come back and troubleshoot the DC tunnels, why it is not showing that. So here also if you do show IPsec inbound connection, here also 6. This is also correct. I'll go back to 10 also. Admin show IPsec inbound connection. So 10 also has 2 and this is DC1 and what was the DC2? So let us quickly check 10 and 11 are DC1 and DC2 and show IPsec inbound connection. So here you can see that 10 and 11 they have only 2. We can easily understand that where to where I don't have tunnel. So 10 don't have tunnel with 12, 12 don't have tunnel with 10 over any transport. And what's the reason for that? So we'll see here. Show interface description if you go and check. So here you can see that the VPN 0 interfaces are gig 00 and gig 01. That means if I do show run VPN 0, so we have gig 00, what is color? I'm not using restrict. I'm not using restrict. So 0001. Now before moving further, what I want to do, I will go to say 10 as well. And let us quickly see show run VPN 0. What's the VPN 0 configuration? So it is restrict. So one side is restrict, other side is not restrict. Other side you may think that's the loose and they are not forming the tunnel because rest of all the sides are restrict, correct? So let's quickly check our topology first before doing anything. So here you can see that all the interfaces are gig 01, gig 02, gig 01, gig 02 here, but MPLS is 00 and internet is 01. So no problem. I'll make this restrict, and while doing so, what I will do that I will enable the debug as well in any of the site. So we will do monitor and who is not, so this is restrict. So here I'll start the monitor start and then we know var log. We have our nice temp log and then we can do vdebug. We can start debug transport and what option events I can check. Label I can check say high. Alright, so now I will go here and I want to log into new so I can see this as well parallelly. Okay, so we'll try to fix 2 monitor in a single Oh, let me reconnect. Admin, and let me stretch this so we can see the logs as well parallelly. Okay, all right. Okay, so I can go to, first of all, vManage, because from vManage I want to log into any of the device. Wow, my vBond is showing that no control connection. Anyways, I can vshell SSH to admin 0.5. Alright, so let me do one thing. Let me quickly log to DC. So yeah, let me quickly log one other DC, that is DC2. Okay, let me stop the recording for the moment. Alright, so I am inside vManage. One other vManage I have started. I'll check show control connection. Even I know the IP. So this is show run system 10. I'm going to SSH 11. Okay, admin, and then the IP say 172.27.0.11. That is the DC2. We are inside DC2. Show run VPN 0 because I want to change the color. Restrict. Great. And then color is restrict. Now commit and quit. Oof. We have done commit and quit, and we have started the debug as well. It should show me the transport debug, and if I see show IPsec inbound connection, okay, show run VPN 0. So here the color is restrict, the color is restrict, and what's the status here? Show run VPN 0. Here also the color is restrict, color is restrict. So it should form the tunnel between 10 and 11. So they are not forming the tunnel between 10 and 11. Let's stop here and we'll continue this in the upcoming recording. Let us continue where we left off. So we have seen that between data center 1 and data center 2, we are not able to form the IPsec connection. Okay, so let us verify that why it is so. I'll go back to our CLIs where I have debug already enabled, and then we'll see. So first of all, let us check that what security information we have. So it is telling, okay, security info authentication type is AH SHA HMAC, rekey information, rekey window, the encryption supported AES GCM and AES GCM 256 CBC for multicast, FIPS mode enable. Okay, great. Here also we'll see what's the security info it has. The same. So it should work, correct? Now if I go and check what is the IPsec local SA, so it is telling, okay, I have this local info, and what is the source, what is the source port, what is the key hash, like that. If I go here and if I check what is the IPsec local SA. By the way, if you want to check all these things, what you can do here, that you can go and check show IPsec and then question mark, you'll get all those options like IKE, inbound connection, local SA, outbound connection, etc. So these are the options we have related to verification of IPsec. Now here I can see that two MPLS connection and two gold connections. So what's the configuration we have for the VPN 0? Show run VPN 0. It is in restrict. It is in restrict. And inside DC1, show run VPN 0. This is also restrict. This is also restrict. So far everything is good and okay. So what are the things that we are missing here? So it is not forming the IPsec connection. Actually, they are even not trying to establish the IPsec connection in the first place, correct? So let us check the configuration one by one. If I go and check show run system, here you can see that system IP is okay, site is 10, here site is 10, both the sites is 10, same site, devices will not form IPsec connection because they are in the same site, correct? So what I will do here, let's quickly check the control connection and check the other sites as well. So VS Smart has site 1000, 1000, 1002 has vManage. So what I will do for this particular device, I will give some other site ID. For that, to verify that, actually, I want to know that which devices belongs to which site. So here you can see that here you can see DC1 site 10, DC2 site 10. That's for the reason they are not forming the IPsec connection. And then we can count the number of BFD, OMP and control connections. So what I'll do, I'll give this DC2 as a site ID of 40. So let's go. DC2, there is DC2. Or maybe DC1 as a site 40, so no problem. I'll go here, system site ID, say for example 4040. Commit. Oh, now you can see we are getting some messages. vTracker, vConfDemon, subscription, receive. OMP is also successfully set on. Operational status is down. Viptela VSGC1 OMP error. Operational status is down. It is still showing that some OMP issue is there. Let's see. What is that? My God, we are getting so much of messages. So let me do one thing that I need to stop that monitor. Let me stop that first of all, and then new state is down. So we are getting down messages. Okay, stop var log and then vdebug, correct? Yes. Great. So let's see that what's the status now. If I go here and check show IPsec inbound connection, do I have connection with the site? Here we'll see that 10, 10, 10. Still we don't have. Oh, we have actually. So let me scroll up, and here I can see that I have tunnel over MPLS to MPLS. So 10 to 11, now I have one. 10 to 11, now I have one more. So now it is working. So what was all these log messages? Let's see. Okay, so let me scroll up, and we don't have much of the log, so we can easily manipulate, or we can easily read all these debug logs. So let me copy this. I will copy to the notepad. Almost done. Yeah, almost done. All right. Notepad. Okay, and let me scroll up. So what messages we are getting, because these messages are also very important to understand. Delete route, IPv4 protocol, delete route. Obviously they are setting the TLOC. So we know that I have local TLOC, I need remote TLOC and key. So sending the TLOC is sending the TLOC to the VSmart, no problem. VDMN, no problem, it is sending the TLOCs. SSL self-sign key generated, no problem, generate it. VSDaemon info, commit completed. So yeah, we have done the commit, no problem on that. Then let's move further. Then we have the VDaemon callbacks, internal checking for the implementation that we are doing. Then new route, see, new route it is getting, this is the VSmart, correct? It is getting the new route. Interesting. Okay, then OMP notification, messages, OMP, we are getting OMP updates. It's not using multicast, so we'll leave that multicast. At the moment it is getting new route. This .5, so we can verify one is the, let's see, .5 and .6. So one is the vManage, .5 is vManage and .6 is actually vBond. .6 is vSmart, .4 is vBond. So 5 and 6, vManage, vSmart. Wow. The diagram itself is incorrect. So it should be vBond and it should be vSmart, correct? So we are working with the wrong topology, and sometimes it happens that you will not get the correct topology that you are doing the troubleshooting with. Okay, so what we'll do here, because we have the device access, we'll verify. Okay, so simply we can do show control connection and we'll come to know that which is what. vSmart is 6, vManage is 5. Okay, that diagram is not correct. So anyways, let's move back. Let's go back to the notepad where we have the notepad. Here it is. Okay, 6. So the vbond bad file, remove route, because the vsmart, sorry, this .6 is vsmart, because the vsmart is actually doing all the routing manipulation, security manipulation, key exchange, etc. With help of DTLS. Inside DTLS it is using OMP, correct? Okay, so they are sending the TLOC information, and this information you can see this important information. Send TLOC info, send TLOC, and now here the peer vsmart, say peer vsmart is this. Obviously they will form that relationship with vsmart. OMP peer up successful, great, and then OMP info notification. Move down, they have added the route. So here it is simply telling that they have added the route. They're not telling anything about, say, key exchange, so what key and other keys. For that actually we need to enable some other debugs so we can see actually what keys are there. So let's do that. Here I am, and if we see here, say daemon info, personality, it's down, info, notification. Still actually these things are going on. But yeah, if you want to do that, you can debug, you can enable actually vdaemon. And vdaemon you can enable, say, all. If you do that, and then do one thing, that go to VPN 0, interface say gigi 0/1, shut, commit. Okay, and then we lose the connection. Wow. So we should have two communication channel. One is over 01, one is over 02. So let me restart this. Let me restart this session. It may got hanged. So let's do this thing. New session. I'm going to restart this session. Simply I resetted the terminal and then we'll do SSH -L admin and the IP. Okay, DC1. So why I have done in this way, because now we'll go to the var and where we have the log, temp log and vdebug. From here we'll see. And here you will get a lot of informations, lot more informations that you can easily track those information. Okay, so here you can see it is showing most of the things. Okay, all right, so I hope you understand. Now we have successfully formed the tunnel, and if you want to do the debug related to say key exchange and all that, so we need to enable the daemons, and for that vdaemon we can check the debugs. Even we can enable some other debugs as well. You can refer that debug document that I told you on the first debug section, and then you can figure out, okay, what exactly you want to debug. Just you want to see that, okay, how it is happening behind the scene. All right, then let's close here. How we can troubleshoot with extranet policy. Sometimes we are referring this as a route leak policy that we have in Cisco. So what's the condition here that say I have two V-edge devices, say this particular V-edge device, that is branch 1 V-edge 1 for example. It has one VPN, say for example VPN 10, where it has loopback address say called 10.10.10.10, and here in other branch I have say VPN 20 and its loopback address for example 20.20.20.20. Now we know that inside the Viptela fabric, if they are in the same service VPN, they can communicate. But if they are in different service VPN, they can't do it. So for that, I need to create one policy at the level of vsmart. So I need to create one policy here at the vsmart that will leak the route. So 10 it will tell okay 20 it will tell 10 okay this is the route. Like it will do the, you can think that it will leak the routes or some sort of a small type of say redistribution, 10 to 20, 20 to 10. Okay, so let me first show you that although the policy is there, but still some issue is there. Let's find out what's the issue we have and then we will fix it. So let us go back to our devices, and we have devices here. Now you can see here that inside say branch number 1, I have one loopback called loopback 10 inside VPN 10 whose IP address is this. Then here in the branch 2, I have loopback 20 inside VPN 20 whose IP is this. Now if I check show IP say route VPN 20, here you can see that 20, so VPN 20, inside VPN 20 we have these 10 routes, correct? So that's great. But if I go back to say here in branch 1, if I check show IP route, like in normal Cisco we are using it, say VPN 10, you can see I don't have 20 routes here. You got the problem? So you can see here that branch 2 is receiving the routes, but branch 1 is not receiving the branch 2 VPN 20 loopback 20 network or route. That's the problem. Means we may have one-way communication now that we have to fix here. Okay, so first of all, how we'll proceed that first of all we'll go to the VSmart, and over VSmart we'll check OMP routes. We are checking this OMP routes here, and before proceeding further, I'm going to give you a quick idea about how this is working. So let me draw here and explain you. It says this is one of my branch, this is my other branch. Here I have loopback 10 as 10 10 10 10. Here I have loopback 20 as 20 20 20. This is inside say VPN 10, this is inside say VPN 20. What is happening actually, this VSmart is intelligent device, it is working as a route reflector. So whatever route it has by default, it will reflect here. Whatever routes it has, it will reflect here. But condition is, but within the same VPN, within the same service VPN. If they are different VPNs, then we have to create one control policy, and that control policy will export the routes from 10 to 20 and then export the routes from 20 to 10. So now in this case, we can easily see that this particular device, that is branch 2, so suppose this is branch 1, this is branch 2. Branch 2 has the routes 20 and its local route is 10. So it has the subnet, say 10 10 10, that it is getting from here. That means VSmart, that means this device is sending to VSmart, and if you go here on the VSmart, you'll find all those routes because he is receiving. This is my centralized routing engine, so he knows. Now it is up to him that he has to redistribute or not. So he is getting those routes, and here it is exporting the route to this branch. So we need to check the condition in this direction. Do we have condition to export the route? Plus we need to check the apply policy is configured properly or not. So overall we have to check the policy. So from where we'll check the policy? Obviously VSmart. I'll go to VSmart, and if I check show run policy, here you can see the policy that okay, I have VPN 10 defined, I have VPN 20 defined, that is the VPN list. I have all branch where I'm applying this policy, that is defined. Then I have one policy, control policy named extranet policy. In the sequence number 10, I am matching the route, say for VPN 10, and then I am exporting to VPN 20, and then default action accept. But here I don't have any condition who is telling match the route for VPN 20 and export to 10. That means we need to fix it. So if I go here, easy way, we can copy paste. And by the way, these policy we can use templates as well. So I can go to policy easily. We can go to policy, then control policy. Sequence number, this time I will use say 20. Sequence 20, match route. What's the VPN this time? So VPN list is client VPN say 20, correct? Then I'll go back because I have to take action, accept. What options we have? Set and export to. Export to VPN list. That will be client VPN. What VPN I have to give? So now we are inside 20, we should give 10, and I can go to top just to see the configuration. Now you can see that sequence number 20, this is not the complete policy. This is the thing that we are going to commit. So this is the uncommitted policy. Sequence number 20, match 20, export to 10. Sequence number 10, say sequence number 10, what was the policy? Match 10, export to 20. So now it is actually very good. We can validate this, we can commit this, and then we can check the overall policy. So let's see. I can see here that extranet policy 10 to 20, 20 to 10 looks good to me. Okay, now if we go here to branch 1 and we press up arrow, oof, now you can see this. So these routes I am getting from OMP as a leaked route over MPLS over Gold, and obviously the encapsulation is IPsec. Okay, so this was the configuration, and what I will do now, that if I debug the okay, we'll see here on the screen, because in the actual debug there are so many things that we have to check. So I can monitor start and the same path. Let me type it little quick, and then I will remove the OMP and I will restart the OMP as well. So better that will go to OMP, shut down the OMP, and it is commit. We are doing just for testing purpose. You can see deleted. All the OMP routes, it is telling that you lose your OMP. Okay, and then I will do commit. We have already done. So now what I'll do, I will do no shutdown. You can see BGP. Have we enabled BGP? No, we haven't enabled BGP, but BGP scanning is happening behind the scene because this OMP is actually customized BGP. And commit. Okay, and what I will do now, so once it install the routes from the VSmart to its cache to its routing table, then what I will do is see performing BGP general scanning. They should change this name, correct? Okay, all right. So it's a OMP is actually the overlay protocol, but it's a customized BGP. Its code is like that. And if I go here and if I have to stop the monitor, let's stop it. Stop, and the same path, even I can copy paste those things so we can save the time. Temp log and then vdebug, done. Okay, done. So now we can check this log little quick and we can see that, okay, we have deleted the OMP, then it deleted all the OMP routes. OMP routes removed from the RIB, routing information base, 24 disconnected, number of VSmart now 0 because OMP is the one who is connecting with the VSmart, the BFD change, the operational down, these things is skipped, the MPLS down, it's a severity alarm, it raises say P1 alert, the local and remote colors, local remote colors, BFD colors, all these informations we are getting here. Okay, and once we have no shutdown, then it will start getting the update. You can see that VSmart peer changed to init process started, OMP peer change, they are doing the OMP handshake, OSPF daemon skipped. Okay, and now one by one we are getting the routes, means the routes are getting installed, and here you can see all these information. Okay, so I hope you understand that what was the problem and how we fix that issue, and everything is working perfectly. In this task we have certain things to do. First of all, this particular vEdge device is down in the vManage dashboard, so I need to bring up the control connection or control plane. Once the control connection will come up, then I have to prefer the control connection, means the control connection towards the vManage will prefer say gold or MPLS. In this case it should prefer gold. Finally, that device should be managed via vManage dashboard. So we know that, okay, to manage all those things we have to create say templates. So those device configuration template or device templates, either it will be a CLI template or it may be feature template. So those things we have to create and attach with the vManage dashboard, because the overall goal in SD-WAN that everything should be managed via vManage dashboard. Now here you can see the architecture is almost similar. The IP addresses are different because now we are using different lab for this. Naming, you can see VSDC1, VHDC1, 2, and then here you can see the branch 1, branch 2, etc. So what is the first goal? I have to go here and check that this device is in the dashboard or not. If it is not, I need to bring up the control plane connection. Then I have to fix the, then it will be preferred control connection with gold towards the vManage. And finally, we need to create a template attached to the dashboard. So let me go and log to our lab devices, because this is not managed via vManage dashboard at the moment. I need to do some local access to this. Maybe out of band management access will work. So this is my vManage dashboard, and you can see that this particular vManage dashboard that we have, one of the device is in down. Correct? What is that device? This is unreachable. The iOS version, that's okay, but this is unreachable. Now what I have to do here, let me go and fix this issue, this unreachable issue. So I will do the local console, means I have out of band management access. Let me go here, and this is my VSDC1. We'll see. Suppose for example you don't have access, then how you will fix the issue? Maybe some local engineer in some remote location, he has the access. Then in that case, what you can do, that you can give him suggestion what he has to do. So for that, you can go to configuration and devices. Once you are here in configuration devices, you can see here VHDC1. And if you go to the more option, you will find running configuration, local configuration. Because running configuration, I can't fetch, because it is not attached or vManage is not monitoring this, but I can go and see this configuration, and if I will find some issue here in this configuration, I can let the team know that, see, this is the problem, you have to fix this. But at the moment this configuration looks clean to me. But this is one of the way that we can tell, okay, this is the configuration, and you check your configuration as a local site and then try to fix it. Anyways, we are here, we'll check the running configuration. We'll see, okay, system wide IP, site ID, vBond IP reachability, that's correct. It has vBond IP, net admin, then, so system wide configuration looks okay. Then OMP. Overlay management protocol, maybe it is shut down, so the overlay will be shut down, but it is on. Then we'll check the VPN 0 configuration. Inside VPN 0, you can see I have two interface, gig E00 going towards gold, and one interface gig E01 going towards MPLS, but you can see no control connection, no control connection. So that may be one of the issue. What I will do, I'll go here and I will do control connection. So I will remove that no control connection, and this time what we can do, that we can debug the VDMN. So we have debug VDMN configuration as well, error, events, hello, miscellaneous packets. So I will do all. Now I am not monitoring here over the dashboard, but if we monitor, then also we'll get the same. So what I'll do, I'll go back, I'll check the logs in the vShell. So let's do this. VPN 0, and then interface gig 00, and what is the tunnel interface, and then we have to check the control connections. Okay, so what command was there? Let's see. It is configured as no control connection. So we'll give control connection, even control connection, and we can see that what options we have with control connection. Control connection deprecated, allow control connection deprecated. It's an old command, but no problem, still we have that. So we have this option. Okay, I have given this control connection. Likewise, I can go to interface gig E0/1 tunnel interface control connection. Let's validate this, commit this. Now if I go and check show control connection, we know what is the order. First of all, it will try to communicate with vBond, and once it is authenticated via vBond, then that temporary tunnel it will break down, and then it will form the permanent tunnel with the vSmart and vManage. So still that authentication process is happening, and we have that benefit that we can go to V, and then we can go and check the log, and finally we debug. So here the logs, the debug logs is coming. It's on, and we can see all those relevant logs. Even we have very nice information here. So who is doing the handshake, vSmart, OMP peer. See, add subscription, VPN 512, remote color, local color, the certificate on the device. So all the process behind the scene we can go and check. Alright, so once it is done, we can check the control connection, and if you see the control connection, the vManage, to reach to vManage, it is already using gold. And it is there in the task that it should prefer gold. Let me go back to the dashboard. Inside dashboard, see, now it is up and running. Okay, so the issue that we have fixed in my dashboard, I can see that it is up and running, but one thing that I have to do here, that it prefer gold, but it is already preferring gold. So let's see that configuration as well. If I go here to show run configuration VPN 0, you will see here that it should prefer gold. And do I have any configuration for that? So let me show you. So suppose I'll make this prefer MPLS. How I can do this? VPN 0 interface gig 0/1. This is the MPLS connection. Now what we can do, that we can go to tunnel interface, and then we can give, say, vManage. Say vManage preferred connection. By default it is 5. Okay, so if it is 5 somewhere and 4 somewhere, higher is better. So by default is 5. If I give, say, for example, 6, that means now it will prefer MPLS. So if I go here, if I type show control connection, you'll find now it is going via MPLS towards the vManage. So let's see. It's up, and yeah, MPLS. Okay. So these are the tasks that we have to done. I hope you understand that. Now what is the next task we have? That at the moment it is managed via vManage, and sorry, it is not managed via vManage, it's locally managed. Now I want to create a template and I want to attach. Okay, so I'll do this thing, paginet false, and then I will take the backup, change setting, login, and the backup is, say, I'll give the name as well, v edge dc1.txt, apply. So show run, it's like terminal length 0. If you do paginet off, and I will go to the desktop and I can copy paste. So the other option also I'll show you. Now what you can do, you can go to the device and template. So configuration and template. I want to create a template. Here you can see you will get option device template with help of CLI or feature template. Okay, so for example, we want this as a CLI template. We have to select one device. You can see long list of devices now supported because this is the V-Edge Cloud. So I will select the V-Edge Cloud. This is a V-Edge DC1. You can give any name. New template for DC1, something like that you can give them. Now here I can copy paste, or I have this option to select. I'll go to desktop and where I have the configuration, so I think it is there in putty itself. I need to go inside the empty putty and then I think I will get it. No problem, we'll search where is the putty. It is here in this program file or it is here in this program file. A putty I can see readme. So let me check that where that configuration has been saved. So we go here and you'll check the path. What's the path it is giving by default? It is in, okay, it is inside empty putty. So see program files empty putty. No problem. We'll go back and I can go empty putty. This is the template, correct? So paste it. Select the file and go here. DCV is VHDC1. Now you can see these things we don't need. So remove these things. System and the configuration, and here also if you want you can change the password. And I'll make this as a admin. Alright. So rest everything is okay. It's almost perfect. Remove these unnecessary things, otherwise it will throw an error. Add this template. Now it is added. What I have to do, I will go to the VHDC1 and let me attach the device. Okay, so what's the serial number that I am going to attach? If I don't know, then I have to go and figure out. So what's the serial number? How I can verify the serial number? That is, say VHDC1, although it's showing certified, but still we have to figure out that. No problem. We can see here D67. So I can again go here and this time VHDC1, attach the device. Okay, why is 67? Where is that 67? Oh, actually it was already resolved, so that's why I was wondering. So you can see here this thing also, that once this thing is there in the main dashboard in the device section, so here also it will be resolved. Otherwise obviously there is no option we can check the serial number and attach. So we are here at VHDC1, select, attach. If you want you can see the configuration. So now you can see that two devices are there and we know that it's at 67. If you want you can see the configuration difference, side by side difference also you can see. So say personality VH, chassis number in the new configuration, in the old configuration, the password. So whatever differences are there you can see here as well. Alright, so let us push that configuration. So now I try to push, it will go to the scheduler here and it is showing in progress here in the top. So once it is done, then failure, we have one failure, but still VHDC1 is going on, validating the configuration and all. And what's the log message? VHDC1 template DC1 success, verification or configuration may take 8 minutes. The vManage transaction ID, all those things we are getting. Now, if I go to the templates here, and if we see that VHDC1 is attached, and what is attached? So this is the chassis number, this is the host name, this is the things that have been attached, and we are almost done. Now suppose now if you want to commit anything, you can't do local changes because now this device is managed via vManage, so I can go and I can do shutdown, but if I commit, it's managed via vManage. So it's one layer of protection also we have. Alright, so now you can see that we have done the troubleshooting. We have provided the connection preference towards the vManage via MPLS, and finally we have attached the template, so this device will be managed via vManage dashboard. In this particular task, we have two tasks. First of all, branch 1 and branch 2. So here is branch 1 and here is branch 2. They are not installing their routes. So what are the routes they have? So for example, branch 1 has route 2.2.136. Branch 2 has route 2.2.120.3. So these routes, these service routes, they are not installing to each other. That is the one thing that we need to solve this issue, that why these VPNs, they are not installing the routes. So suppose this is in VPN 1 and this is also inside VPN 1. Now next what I have to do, that inside VPN 1 I will create loopback. Say loopback 33 with IP 33.33.33.33/32. Now this loopback, so once the issue number 1 will get fixed, this loopback address inside VPN 1 will advertise to branch number 1 via MPLS and via Gold. Now what I have to do, I have to prefer, so it will go only via say MPLS, or if you want it will go only via Gold. So stick with MPLS, it will go via MPLS. So that means if I go here in this particular device without this rule, without this policy, this particular VPN 1 will see 33, say 333 route or 33 route, so via MPLS, via internet. After applying this, it will learn only via MPLS. Okay, so how the route learning happens, we know this thing. Again, let me revise. So these devices, they are sending their routes inside OMP to the VSmart. Now VSmart, if it don't have any policy, it will simply work as a route reflector and it will reflect the routes to each other. But suppose if you apply some sort of policies, say for example, we'll apply one control policy, then in that case, we'll see that how things get advertised, because we have one selective approach, or we have one question that is selectively telling that use only one link to reach up to this point. Okay, so let us go to our lab section and we'll try to figure out issue 1, issue 2. Say I am here inside the lab and I have VE branch 1. If I check show IP route, say VPN 1, inside VPN 1 I can see that I have 136. Let me confirm what is the system IP I have. Show run system. So my system IP is 1.4. And what is the system IP of the other device? So let's go to the dashboard. See here that 1.4 Okay, so this is the old dashboard that it is showing here. Let me go and open the new. So now you can see that branch 1, branch 2, their system IP is 1.4 and 1.7. So branch 1, 1.4, branch 2, 1.7. Great. Let us go back. We are here. So 1.4. So do I have any route from 1.7? Here you can see that I don't have any route that is coming from 1.7. These 1.5 and 1.8 may be my DC1 and DC2 VH devices, but I'm not getting any routes from 1.7, that is VE2. So what's the reason? Reason is actually simple. If you see these branches over the dashboard, you'll find that both the site IDs are the same. Because the site IDs are the same, so they will not install the routes because they will think, oh, we are in the same site, we are same pair of routers. Something like that they will think, but they will not install the routes. Although they have routes from the data center. So what I will do now, that this particular branch, I will make this site ID, say for example, as 55. I'll go system site ID is say 55, commit. Now once I commit, now if I go and check, so do I am getting routes from 1.7 or not? Let us see that. So once this commit will confirm, then again we'll go and check that we are getting the routes from the other side or not. Let's see. So now you can see that we are receiving the route from 1.7, that is 2.2.120, 1.7, that is 33 as well. So if I go back to the system IP that refers 1.7, let's see what is configured there. I can go to my vManage, I can do cross SSH. So let me do that. Let us go to the DC, sorry, not DC, but VH2, branch VH2. So here if I check show interface description and what routes I have or what network I have over VPN 1, you can see. So I have this particular route on VPN 1 because these are the service routes and these are the same VPN service routes. So that's why they will go to the vSmart and vSmart will reflect to the other side devices, correct? But the thing here you can see that we are receiving these routes over MPLS and gold. MPLS and gold. That I don't want. So what I want here, I want these routes come only via MPLS. So I have to exclude this gold. So how I can do this filtering? So for that we need to create one of the policy. That policy I will create at the level of vSmart, and where I will apply? I can apply this going to obviously branch 1, and for that I need what is the branch 1 site ID that we have put. So that is 55, just now we have configured. Okay, so we'll go to vSmart 1. We'll go to policy. First of all, we create say site list branch 1. This site ID is 55. Then I'll create VPN list that name is say VPN 1 and that is VPN 1 because we are going to apply the policy over VPN 1. Okay. Alright, so we are very good at the moment and I want to filter routes as well. So I will create prefix list, say block 33, and then we'll give the prefix as a 33333333/32. Okay, let's see what we have done so far. So if I do show configuration, you'll find that yeah, I have VPN1, I have branch, and I have this prefix list. So we have list. We have three different lists. Now we'll go back to the policy because this time we want to create control policy. Say block, for example. Now I want to, okay, let's go to the sequence number. So sequence number 10, I want to match route. This route, I want to match route, and what we can do, see, we have all things. We have VPN list, so I will give VPN list, and this VPN list is a VPN1. Then I have prefix list, correct? This prefix list is a block. Then I have tlock. What I can do, instead of tlock, I can give color as well, because color I can give, say, what color we have. So we have color gold, I think. So let's see here quickly. If I do show run VPN 0, we have two color. One color is gold and one color is MPLS. So what I'll do here, because I'm going to block this gold, so let's see, take gold. Now if I do show configuration, so now you can see that I'm matching the route to this particular prefix, to the gold, to the VPN1. By default action is reject. So what it will do, that match the route for VPN1 with color gold, and this particular subnet, drop it. After that, what we can do here, we can give a default action as a accept. Let's validate this. Everything looks good. And then we check the configuration as a whole. So now we have VPN list 1, branch 1 with site ID 55. Then the blocker statement, this I want to block, but only related to gold color, not related to MPLS. So here it will be blocked, but in this statement, it will get advertised. So once we have policy, we can apply this policy. I want to apply this policy with the site list with the branch 1, and the control policy name is block, correct? And I want to apply to the outward direction. Commit. Wow. Now if I go to branch 1, let me quickly check this. Show IP route VPN 1, and where is 33? So now I am receiving this 33 with MPLS only. Okay, you got this point? So that was the task. Now suppose if I want to see this via gold as well, so let me quickly remove this policy. So far our task is completed. I'll go here, I'll do no policy, I'll do no apply policy site list, I'll commit, and poof. If we go back here, if I press up arrow, now we have 333 via both the color, both the transport. Okay, so this was the task we have successfully completed. Next task, we have established BGP. Now here you can see that we have to do many things. So as per our topology diagram, you can see that we need to establish BGP between this V edge 2 and router number 3. So we need to figure out that why BGP is not working in between them. Then we have some loopback addresses in router 3. We need to advertise these loopback addresses to my peer router, and here they are using eBGP. Now the other use case or test case we have here, that what we want, that all these BGP routes, because by default they will go everywhere inside VPN1, but here the test case is that all these BGP routes will prefer DC1 and DC2. So rather preferring direct branch 2 to branch 1, it will prefer DC1, DC2. Okay, so these are the cases that we need to figure out. So first of all, we need to establish BGP here, and then these BGP routes that my vEdge is learning, these data center will prefer these routes. Okay, so let's do it. So here we have devices. First of all, see what configuration we have for router number 3. This router number 3 is a virtual router. It's not vEdge, it's some other Cisco router. So let's see that what BGP configuration we have here. And we can see that, okay, we have BGP running 5000, router ID, the neighbor, and then the BGP statement. So we are advertising these loopbacks. So from this side, everything looks good. Okay. Now we'll go to the DC one, that is the branch. Okay, we'll go to the branch 2, and from branch 2 we'll check what is the peer address I want to give. So here inside VPN 1, you can see that this is the address to the peer. So what's the neighbor address? That's correct. Now I need to check that what IP address it has, because from this side I have to give this particular neighbor IP. So let's do it. We'll go to VPN 1, we'll go to router, BGP, and then make sure that we are giving the correct remote AS. Okay, so this is its local AS. Now then what options we have? We have address family. I can go to address family. Let's see what options we have in vEdge. Address family, like in Cisco, best path, distance, neighbor, router ID. Give the router ID as well, because that is there in the task. So 27.1.7 was the router ID we had. Then what options we have? We have address family and we have neighbor command as well. So we can give that. Oops, let me reconnect. Okay, we are back. So reconnection happened. Now what are the other things? So we have to give the address family, IPv4 unicast. Then we have options related to network, redistribute, etc. Leave that at the moment. And then we can go out, because I have to define what's the neighbor. So my neighbor is 221.20.1. What's the remote AS for that? So this remote AS should be correct. What other options we have? We have password. We have to give password as well here. I'll give the password. Other side also I have to fix the password. And let's see that what we have done so far. The vEdge BGP configuration. So router, BGP, router ID, address family, neighbor, no shutdown, remote AS, and this command. So we are very much good. We can do commit. And if we start debug BGP events for VPN 1 and packets for VPN 1, if we do monitor, our old monitor command, and then we debug. Let's see that how it will work. So BGP general scanning, table scanning, performing scanning, and here if we check show IP BGP summary, on the other hand, so it will not form BGP obviously, because password that we have given, it will not work. Apart from that, I just wanted to make sure that we have given correct BGP configuration. So if I go here, show run VPN1, this should be correct. And what logs we have here, you can see here that source, destination IP, protocol IPsec, we have some issue here, correct? So what is this? Deleted false reason timeout. You can see here the logs, the debug messages. It is trying to establish over both the MPLS and the gold with the source, obviously system IP, source IP, and it has some issue. So let's say that what issue it has, and then we'll try to fix it. So if I go to show run VPN1, BGP, I need to stop this, otherwise I can't fix this. Remote AS, no shutdown, neighbor, and IP address. So since the configuration is correct, I need to give the password here. So I'll go here, router BGP, and then my neighbor. So what neighbor I have? 120.3, and the password, let me give the password. Password is SD-WAN. Go out here, we'll see. Show IP BGP summary. Still it is in active state. So from this side, everything is correct. Now router 3 configuration for BGP is correct. We don't have any problem. If any issue I have to go and check the VH2. Okay. So we'll parallelly map this as well. So let's go back to our original configuration. And I will stop the monitoring. So let me do monitor, stop, and yeah, let me stop the monitoring. But we have enough log messages that we can see that what it tried to do here with the BGP debug. So let's see that what configuration we have given. So we have given that configuration, that is my BGP correct, router ID correct, address family is also correct, neighbor is also correct. Let's verify. Show IP BGP. Show IP and see that we have option or not. Okay, show BGP neighbor VPN1. So established, here it is showing established. Show IP BGP summary. Now it is established. So now you can see that the neighbor has been established. It was broken due to the key after the initial configuration. Now if I see that do I am getting BGP routes or not. Let's see. Now I am getting the BGP routes as well. So that's good. Inside VPN1, I am getting the BGP routes. These are E as the eBGP routes. So okay, up to this point I am receiving. Let me go to the data center 1 And let me see, show IP route BGP. I am getting BGP route or not. Nothing is coming. So why nothing is coming? What is happening actually, that whenever we are talking about any of the service routes, that is coming to my network, how it will come. So suppose I have one device here, let me draw. I have one device here that is VE, for example, branch 2. Now it is connected with router number 3, and router number 3 is sending BGP packets to him, but this is inside VPN 1, correct? Now this VPN 1, inside the Viptela fabric, whatever devices I have, inside that device, either it's a DC or branch, VPN 1, these BGP routes will go. Why? Because this device will advertise to VSmart, and VSmart will work as a route reflector. It will reflect those routes to other sites. Correct? So we need to fix that we are doing any type of redistribution or not. That's very important. So if I go here, if I check show run OMP, you can see inside OMP, I am not advertising BGP. So once I advertise BGP inside OMP, that means now my VSmart controller knowing those BGP routes, and then it will reflect to all the devices. Correct? So I can see that is still that DC1 is not receiving BGP routes, or maybe some issue with this device. Let me go and log to other device. I just logged into vManage to log into any of the other device. So I'll do show control connection. I just want to SSH to any of the device, any of the vEdge. Here I can go to 175. So let's check 5. Okay, and we'll verify that what is the thing that we are checking, because that is very important. Now this is DC2. If I check show IP route BGP, here also we don't have BGP. So technically that BGP route that I have to receive, is it a BGP route or is it some sort of encapsulation and I'm getting? So technically what is happening, say when any of the device, when it is getting BGP from any of the service VPN, then it will send to the VSmart, because inside OMP I am advertising that. Now when OMP or when the VSmart will advertise to any of the device, it will advertise as a OMP route. It will not advertise as a BGP route. Correct? So we know that what is the prefixes that is coming. If I go and check show IP route OMP, let's see. Do I have 13? Yes. You can see we have this 13, 13, 13 route. We have these 10 routes over both the transport, and these routes are OMP routes. So even in the DC1 also, if I check show OMP routes, or if I check show IP routes, you'll get this 13, 13, 13 routes. Okay, so this testing has been successful. We have successfully established the connection, BGP connection between this and this. Now if I go to router 3 and if I check show IP route, show IP say BGP. So these are my own routes that I am sending to router 3, but I am not receiving any route from the VE side, from the VH side. So for that, what we can do, we can go to say VPN1 and then say router BGP, whatever AS number we have. Let's see that can we do redistribution here. So if I type question mark, do I have redistribution option, or I have to go inside address family IPv4 unicast and then I can do redistribution? Yeah. So I can do redistribute OMP, correct? I can do say redistribute connected. Now if I go here and now if I check show IP route BGP, let's see, show IP route. I am getting any route here. I am getting routes. BGP is slow protocol, so it will converge late. I should have routes, you can see. So now I have routes 2291, 105, 136. Okay, and those routes are related to show IP route VPN 1. So we can see 2291 and we can refer the our topology diagram as well. So 91 is coming, 105 is coming. So 91 is coming, 105 is coming, 136 is coming, 136 is coming, and we can see. So now we have plenty of routes and we have successfully done a redistribution of BGP as well. So from the service side BGP to the V-edge, from that V-edge it is going everywhere. Okay. Now the next target we have is to prefer these BGP routes towards the data center. So for that obviously we need to create policy. Let me hide this or let me fix this. Now for that I have to go inside VSmart and then I have to check that how I can do that. So let's go to the VSmart and I want to SSH to VSmart, that is 1.3, correct? Yes. Let's go inside VSmart. Let me increase the font size for the VSmart as well. I have increased the font size for VSmart and let's do it. So what I'll do, I'm going to create control policy where I want to select this BGP route. So how we can do it? First of all, let's go here and create the prefix list. Okay. Say BGP routes, and what BGP routes we have, we'll give that. So that actually I want 13 routes. So 13, 13, 13.1 and then 2 and then 3. Let's take only 1, 2, 3. These three prefixes. Rest 2 routes, we'll see that how it is going. So we have these prefixes. Now I'll create say site list all DC, and here I will give the site ID for the data center. What is that site ID? It is 20 and 30. So we can refer the site IDs are 20 and 30. So I'll give 20 and then I'll give 30. Alright. Then I'll create one more site ID because what I want here that the branch, I want to apply these rules to branches. Okay. Or how we can do it. So what will be the strategy we have? Let's discuss that. What I want to do here. I have data center 1, data center 2, I have branch 1 and branch 2. So all these BGP routes, what I want that DC1 and DC2 will prefer. Okay. So what I can do, I will apply the policy for say branch number 2, BR2, and so what we can do here, we may have different strategy to do this. So I can do this. Say, I can create policy, say for branch number 2, where I will match the site list, match the VPN list, match the prefix, obviously with the route. So route of branch 2 will match these criteria, and while applying, I will apply to branch. So I will apply to DC, actually, all DC. And here, what I will do, so routes of branch 2 will have preference, higher preference value towards the data center. Okay, so let me do this, then you will understand what I tried to explain here. So let's do it. So I have all DC, and then I'll create one more site, say branch 2, where I want to match the BGP routes. So for branch 2, we have site ID of 100. We'll go to top, we'll check the configuration, what we have done. So I have list all data center, one of the branch, and then the routes, correct? I'll create one more list, that is VPN list. So policy and then list, say VPN lists, VPN 1, and that VPN is actually 1. Commit this. Great. Now we have to create the policy. So my control policy name is BGP DC prefer. BGP routes toward DC, we have to prefer. I'll go to sequence number 10. I want to match the route of the site ID, say branch 2, and that should be site list, branch 2, and the VPN list we have, what VPN we have? VPN list of VPN 1, and prefix list of BGP routes. Let's see what configuration we have. So what I'm telling that, okay, match route for branch 2 for VPN 1 for these prefixes, correct? And then we have to take action. So action, what I want to do here, action accept, set the preference value, say 500, and then we have service TLOC action, TLOC list, OMP tag. I think that is okay. So we are setting this, and then I will go to the default statement, and the default statement will give, say default action is accept. Okay, I'll go to top. Let us see that what configuration we have so far. So now we can see that, okay, we have one policy for branch 2 VPN 1 BGP routes. I am giving high preference to that, and the default action is accept. Alright, now we will apply this policy. Apply this policy to site list with all the DC. The control policy name is BGP prefer in the egress direction. Validate this, commit this. Wow. Let's go to DC1. Now if I go here, if I check show IP route, and even we can see VPN 1 as well, because we are specific to VPN. So all these VPN routes, say 1313, 123, 123, 123. So I should go to branch 1 as well. So how my branch 1, they are getting the route. So we have applied this policy, and I want to open one of the branch. So from here only I can open. Let me end this session, exit, and we'll go to one of the branch, that is branch 1. So for branch 1, what is the system IP? Let's see. I can see from here branch 1 system IP. Branch 1 system IP is 1.1. branch 1, sorry, branch 1.4. So 1.4 admin show IP route VPN 1. I'm just focusing that these routes that I'm learning, this is coming directly to, that's okay, OMP IP is 1.7. So let's just stop here and we'll continue this thing. We'll do more traffic engineering in the next recording. Let us continue where we left off. So now I'm checking the BGP routes and their preference value in branch 1 and say all the DC. So I'll go to DC1 and DC2 and I'll check that. Now here if I go to branch 2 also. Okay, if I go to branch, say DC1 for example, and if I check show OMP routes, you can see here the VPN, the BGP routes, it is coming obviously via OMP. So what we can do here, we can check show OMP routes, say for VPN 1, and you can see that, okay, I'm learning the VPN routes, but few of the routes that we have set the preference value, that is 1, 2, 3. Preference value is 500, means it will be preferred. These routes will be preferred. If you want to know more about this, then you can give this prefix as well, show OMP routes and then the detail. So now we can see here that, okay, I'm learning this route received from 1.3, that is the vSmart, path ID, the label ID, the status, and then who is the originator, 1.7, MPLS IPsec, and site ID, the preference value. So this is the originator information. It's the eBGP routes received from. So who is originating, from where I am getting, and then the attributes. Again, you can see the originator. So we are getting from two paths. One is the gold IPsec, one is the MPLS IPsec. Obviously, we can filter out whenever we wanted. And the preference value is set. And here also higher is better. Now, if I go to say, for example, branch number 1, and if I check show IP routes, VPN 1, and we can give this as well. Actually, I will check OMP route, but let's see this as well. So if I go here, okay, OMP, all these things, say protocol is OMP, we have two paths. Now what I'll do show OMP routes VPN 1, and then I will give that prefix 32. Now you can see that preference is not set. Okay, tag is also not set, and that was the result that we have done. And now suppose if you want, so again this is other use case that we can use here, and that will be again different use case, because by default we know that they are in full mesh. But if you want to break this full mesh, if you want to make this as a hub and a spoke, then what we can do, that this particular IPsec tunnel we can invalidate, and then we have either this type of topology or this type of topology. So any route that is going towards the any of the branch for a branch, so that will obviously go first to the data center and then go to the other branch. Go first to the data center, then it will go to the branch. Again, here also we can set the preference value that I am preferring DC1 or DC2 for these routes. Okay, so all these options also always available for us. So we are very good with this section. Let's close then. In this task, we have task related to branch 1. Now this branch 1 will prefer MPLS traffic, means originating traffic will go via MPLS TLOC, because we know that we have two transport. So here if you see the diagram, you'll find that branch 1 gold and MPLS. So I want to prefer this TLOC, originating traffic towards MPLS. That is the task 1. The task 2, that the DC1 is advertising this particular loopback address, and I want to block this to get to the V branch 1. Okay, so let's go to the lab and perform this task. So I am here in the, say, branch 1. Let's see that branch 1, say for example 22136.3. Okay, so this route, how, say for example DC1 is learning. So what I can do here, I can do show IP route, and we'll give the route. We'll see how it is learning here. On the top also you can see the same command. So inside VPN 1 it is coming via MPLS and it is coming via gold. Okay, let us check here in V branch 1 also. So if I check show IP route, say VPN 1, I'm looking to 22136.3. 22136. Where is that? Here you can see 22. These are the connected routes I have. Even it is used inside OSPF as well, but this connected route, and the next hop is obviously my connected route so itself. But we can see here that it is giving preference to MPLS and gold both. So what I want to give the route preference as a MPLS. What we'll do, so first of all we can see that what is the VPN 0 settings or configurations we have. Now I can go inside VPN 0, and then I can go inside, say, interface gig E0/0. That is my gold tunnel interface. Now I can give the preference. So let's see what options we have. We have allow service, carrier control, encapsulation, NAT, refresal, port hop, vbond, stun. So what I can do here, I can say give color gold, and then because we are giving the preference, so let me see that where we'll get that encapsulation, because TLOC has three things: system IP, encapsulation, color. So this preference we will get, yeah, here. So here you can see that inside encapsulation IPsec we have preference related to weight, or we have weight and preference related options related to TLOC. So now a preference value I will give some higher value. By default it will be 0. I will give preference here for gold, say for example 100, and for MPLS I will give some more preference, maybe say 200. So now I will go to interface gig E0/1 tunnel interface, and then the encapsulation IPsec preference, say 200. I'll go to top just to see that what configuration changes we have. So here you can clearly see that for one side I have preference 100. For other side, that is my MPLS, the preference is 200. Now if I go and check show IP route, so we'll see that now it should prefer the MPLS over the gold. So now if I go here and if I check these routes, see, it is preferring MPLS. Even we can do trace route as well. So if I go here, if I check show interface description, means what is the IP here in VPN 1. So this is the IP address. If I go and do the trace route, so let's do the trace as well. Trace route VPN 1 IP. So it is going directly via 91. So directly it is going. Show interface description. But you can see that there is change, and now the change is that the other devices, they are learning the routes over MPLS. All right, so we are very good with the task 1, and if we see here the task 2, for that we need to check that what is the routes we have for loopback 1. See, I have one loopback 1 2111. This should be received via this particular device, and here you can see it is learning via OMP 2111. So the next task is to block this. For this I need to create the control policy. So first of all, I need to remove the old one. I'll remove the old policies that we have created. The other old policy was the apply policy site commit. Now it should not do any changes that we are doing here. Okay, let me double confirm, because that due to the old policy we don't have any effect, so that's good. So we are on the same page now. The V branch 1 is preferring MPLS TLOC to reach to the destinations. Now for DC1 loopback we have to create one control policy. So first of all, we'll go here in the list and we'll select prefix list, say DC loopback. Now what IP preference I can give? I know that the IP is 20, so let us double confirm that what is the IP. 2111/32. So that should be 2111/32. Great. Then we'll create site list, and the site will give the name as well. Say branch 1 I want to block. And what's the site ID for branch 1? We'll see quickly. Show run system. The site ID is 10. Great. So we'll give the site ID as 10. Exit. Do I need any other thing? Even I can match the VPN as well, correct? So I'll create one VPN list, and I'll give the name this as a, say, let's see that what is the name. So okay, VPN 1 and then VPN 1. This also I can create. I can go to top. We'll see that what is the configuration that we have done. Great. Now we'll go inside the policy and we'll create control policy. Say block loopback, say loop for branch 1. Any name I can give. Then sequence number 10, match route, not TLOC, match route. Here in the match condition, I want to match the prefix list, and that is DC loop, correct? Now exit and action, I will do say reject. I'll go up, default action will be accept all. I'll go to top, just we'll see that what configuration we have. So now you can see that I have VPN list, branch 1 and all those things. In control policy, I'm matching the route and I'm dropping it. Even I can go and give the policy some more granularity. I can go here to match route and I can give, say, VPN list. So even I can, let's see that what are the things I have. Oh, see, I have this VPN list also, though I can match the VPN 1 as well. I can go to top. Now we can check the configuration, because we know this is VPN 1 related route, so that's why I have given that. So you can see match route, prefix, VPN list, action reject, rest all the routes, accept it. Now we need to apply this policy with respect to site list, and site list is a branch 1, and the control policy name is block in the egress direction of branch 1. If anything is wrong, commit will not happen, but stand. Alright, now if I go here, if I check show IP route VPN 1, it should not learn 2111 loopback. correct? So if I go up, 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 initially you are seeing here that we are learning the 21.1 route via 1.8. Now if I go down, I don't have 21.1, correct? But VSmart have that route, obviously. If we check show IP, show OMP routes, you can see that, okay, I'm getting this routes from 1.8, but I am blocking while sending outside. Okay, so that was the overall goal we have for this particular section. We are good now to stop here. And before stopping, if you want to do packet capture, you can do the packet capture like this. And suppose if you want to ping, so suppose I have one destination and I want to ping, so let me ping from any of the location to this particular IP, that is say 22136.3. So I'll go to DC1, I'll ping. Before ping, let's see that we have this route or not. Yeah, we have over MPLS. So I can ping to say this IP over VPN1, and it is pinging. If I go to branch 1, it should see these packets. So we have TCP dump option here, and TCP dump option we have, we can use multiple options inside the option field. Doing troubleshooting via vManage dashboard. You can go to this particular link. You will get the detail of all the steps. I'm going to log into vManage dashboard, and I'll show you the options that you'll get the options related to troubleshooting as well in the dashboard. So once we are here at the dashboard, I can go to network and say I can choose any of the device. For example, VE branch 1. In this particular dashboard, you'll find at the bottom you have this option called troubleshooting. If you go to the troubleshooting section, you will find that, okay, we have troubleshooting related to connectivity, traffic, and we can have the logs. So we can check the debug log that I have shown you via CLI. Same type of things you can get from here also. Mostly the network engineers, they prefer CLI type of troubleshooting because CLI is directly connected to the operating system, and we are getting very fast response when we are troubleshooting with respect to CLI. Now once you are here, you can go and check all the options, like you can check that device, bring up what are the phases, at what time this device come online. If we want, we can check the control connection live view. Here I can see, okay, I have 3 control connection, 2 with vSmart, 1 with vManage, and bottom also you will see what is the preferred color, okay. So likewise, one by one we can check what are the troubleshooting options we have. Apart from that, we can go and do the ping, trace route, speed test. Ping, simply we can do ping from the CLI as well. So if I know what is the destination I want to ping, what is the VPN interface I want to ping, let's do that. Let me show you the ping. So I have, say, DC1 open. Okay, this is the DC1 IP2291.3, and if I give that destination here, VPN1, I can choose the interface, say props, ICMP, TCP, UDP, all these options we have. When we have the advanced options as well, I can click ping. So once we'll click here ping, it should just start the ping process. You can see here, and we have these many pings. So we can see that ping is going on and we are getting the results. So packet transmitted, packet received, loss, round trip time, very much graphical output we have. TCP options, then TCP advanced option, UDP option, UDP advanced option. All right, so we have these ping probes, and let's go back. Trace route we can do. So trace route also, let's see. I want to do test route with this, and I want to do test route with this particular interface directly connected. So it is giving us the trace how I can reach here. Then we'll see what other option we have is speed test. Now it's actually very important that we can choose a circuit, say for example MPLS, and then I can choose a destination, and then I can choose say MPLS. I can start the test. So it will tell you what is the download, what is the upload status and all. Alright, in this lab simulation, it is showing that error because we are using simulated MPLS and internet environment. Now, suppose if you want to use this particular setting, one very important thing I need to highlight, then you have to go inside the vManage dashboard setting and you have to enable this data stream. Okay, once you enable this data stream, then only you will get all those options. So I have enabled the data stream, and inside that I have given VE branch 1, VPN 1, and then I am doing all those things. Okay, so let us go back and we'll see what other options we have. So the other options, I'll go to the troubleshooting. You can see connectivity you have, then traffic related to tunnel traffic, app route traffic, packet capture, simulate flow. Tunnel health, we can check, we can choose the circuits. So very much you can go and check. It's not difficult. If you know that what you want to check, you can go and check those outputs. So it is showing that, okay, what is the loss and what are the parameters. So say loss percentage, it is showing that how much percent it got lost. What tunnel option I have, one is gold. V branch 1 is gold IPsec V branch 2 tunnel I have, one is completely seems to be down or very less utilized. Other one is being utilized here. Okay, but you can see all these things means we have the visual representation that visually we can see. I haven't used app route policy. If I use that app route policy, then this also I can see. No filter and DPI. Say no filter, go. For this also it is giving us all the chart, and because by default there will be one policy related to visibility. So if I go here and if I check, let me go to say DC branch 1 for example, just to show you this. Show run. Let's see. Because by default we have some visibility options on over the devices, so that's why it may show you that visibility. Now here I don't have that enable, no problem. So we'll do one thing, we'll go to config, we'll go to policy, and inside policy we have this app visibility and flow visibility, correct? So exit. Better I'll do this to branch 1 because we are testing with the branch 1. Most of the time you'll find these are the default setting: policy app visibility and policy flow visibility. And let me go back to the dashboard. Go. Even we can select the time as well. 3 hours, we'll see 3-hour duration. And we'll give DPI. Then it is asking about the application you want to choose. The application, you can see Akamai, Apple services, BitTorrent. So these applications, even application families are also there. Better we'll choose the application family, or we can put the application family, date and time. So all those things we can filter once we have the app route policy configured. We can filter those things, and again we have the visual representation of all those things. So here you can see that we have VE branch gold, V branch 1 to data DC2 loss is 0%. So it is showing all the tunnels, all the tunnels. It is showing that the app route is working in these tunnels, and we have basically 1, 2, 3, 4 tunnels, and it is showing here in the graph. If I see 12 hour, if I see 24 hours, and we have the custom dates as well. Okay, so this is the way that we can check all these flows, and these are the options that we have to check here in the vManage dashboard. Oh, now my connection has been restored. Yeah. Okay, so you can see that the visual representation of these things are very easy. We can do packet capture, and we can further analyze by Wireshark. So those options also by default it will capture for 5 minutes of traffic, and then we can download it, and then further we can use it. Then finally we have simulate flow as well. We can generate some flow, simulate some flow, and check it. You have to go here and you have to give this option of simulate the flows. Finally we have this live logs and this debug logs. We have used a quite, we know that where exactly it is storing. So I have option related to these three things. What are those? So vconf, syslog, vdebug. Alright, so these are the options related to vManage dashboard troubleshooting. Let us discuss the tools option inside the vManage, and plus the other tool option also we have inside the edge devices. We'll discuss one by one. So first let me show you that what tools option we have in the vManage dashboard. In the dashboard you can see here that tools SSH, I can do SSH to any of the device. I can rediscover the network, and then we have this operational command. Now what this operational command will do, these operational command, if you click here to the more buttons at DC1 VH2, admin tech, interface, reset, request port hop color, and the locked user. Admin tech is one of the very important command. Generally customer services, they are telling, oh, I need admin tech. Now we have option that we can include log, score, and tech, or we can simply use this tech, and then I can click generate. Once I click generate, then we can check the list of this admin techs, and then we can copy those things and we can send across. Now let me show you some of the theory behind this. This is the page from the Viptela document. I will put this URL for your reference. So either we can use that admin tech from the GUI, or I can use request admin tech. Although I have options here to include or exclude. So see, request admin tech, and I can exclude the core, exclude the logs, and I can exclude the text. So means we can take the combination of that. Then once it is generated, I can go to vshell, and from there I can do SCP, and this file I can copy to the destination for further analysis. Okay, so obviously this is used for troubleshooting and diagnostic for the customer services, and this is the way that we can get these files. Here if you go, you can use this command, say request admin tech. It will generate it inside say home admin directory, and then we can do the vshell, and then we can export those things. Even if I want to extract, I can extract that. So we'll do this thing. Let me go to the lab section. I have my devices here, and these are the different topology diagram. Now in this particular section, I'm going to use actually all new different set of devices, controllers, and IP addresses, everything. But anyways, for any particular device, I can do request admin tech, and then I have these options like exclude core, log, tech. So I'll exclude, say, for example, core, exclude, say, logs, enter. Now this admin tech has been initiated, and at a moment I can run only one admin tech command. So it will take some time. Once it will get all those information, then it will come with, see, now it has generated that. So where it is telling that admin tech is there in the home. So we can go to home admin folder, and if we do ls minus la, we have files. So here you can see I have two files. What is the file name that I just generated? That is 332. So what I can do next here, that I can use this star and with some strings, and I can use this particular file name to extract. Now you can see that inside admin tech, what are the things that it is collecting. Not only it is connecting all the rollbacks, whatever configuration rollbacks it has, but it is collecting the informations related to vdebug, all the vdebugs, say var tech, .1x, conft, dpi, igmp, vrrp, omp, all the daemons information it has. So we can also go to the var and then tech. So let us go. What I'll do, I'll go to, say, cd var and tech, and we'll do ls la just to see what are the things we have here. So I want to see this config. What I'll do config, and it's very much like Linux stuffs we are doing. So now you can see that you can further go and analyze this. What are the changes, what add, what remove. So many stuffs we have, correct? Even let me scroll up. See all those configs and all those things. All the history we have, correct? Great. So it's really a great stuff for troubleshooting. Even we can also check that. If I go to, say, cat, and then if I check other thing, hardware, we'll leave hardware at the moment. Host related IZMP, OMP, daemon, OMP daemon, and VRRP daemon. So these two things we can check. OMP database, you can see OMP database, label database, network database, and if I scroll up, you can see all those things, correct? Which is not actually available in normal networking world. So I can go to cat VRRP daemon, and later we have troubleshooting for VRRP as well. It is telling that which interface, which VRRP group, etc., etc. Alright, so you can see that what valuable information we have inside this admin tech. Let me go back to the admin tech. Even in the same string also I can move, but just for sake of simplicity I'm going one by one. Home admin, and then we can check. We have extracted this, and let me execute that command one more time. So you can see that you can drill down very important informations, and again you can analyze all those things. So it is showing some error. Oh, sorry for that. I should not give a space in between. Alright, so further what we can do while we are doing our troubleshooting, that we can go to log. Often we used to go to log and then temp log, and then we are checking this vdebug. Even we have log folder also, and inside that also I have vdebug. So we can check the log folder inside var, obviously var log vdebug temp log vdebug, like that. Then inside var I have this tech and tech file related to everything I have. Great. Hardware also, app route also. Then var conf d daemon, and then we have all these configurations, rollback and everything. So once I generate the tech file, you can see that we have lot many things that we can get. Okay, let's move on. Now the second important thing I want to show you here, that you can go to tools. If you type question mark, say tools related to, actually these are the tools taken from the Linux. So tools related to IP route, iper, minicon, netstat, nping, ss, stun, client. So 1, 2, 3, 4, 5, 6, 7. 7 tools we have, and it's Linux tools. Even we can refer to Linux manual pages as well for that. But suppose if you want to know about, say, IP root, you can go to tools and then you can type help. It should show help. Help, like in Linux. Wow. Unknown command. Let me check if I get help for other tools. So sometimes I have help, sometimes I don't have help because maybe it don't have other options. Yeah, it's a, I don't have option. But if I go to SS, yeah, help. So most of the tool means approx all the tools, we will get the help option, iperf, and then you can check that we have help options, and then we can check what are the variables, what are the options we have one to one. So what I'm going to do, let me go to the main page where we have all these explanations. So here I am, I will post all these URL for your reference. So let's start with tools and then SS. So display socket stats for Viptela devices. This command is effectively the standard Linux SS command. What options we have? We can go, we can check the help. Then we have so many filters also. We can check those like tool, SSH, SS, VPN, something. We can check the sockets number, and it's taken from Linux. Obviously it is useful to get the socket stats. So let me go here and to the lab. Actually we can do say tool SSH SS, and then we can give say VPN, for example 0. See all the socket information we have. Now if you want to filter, you can filter with grep or some other commands, but we have all these options, correct? Likewise, I can go to tools, netstat. Now netstat, we know about netstat, that with help of netstat we can get network connection, routing table, interface stats, mask ring, connections, multicast, membership groups, etc. This is also taken from Linux because all these tools are taken from Linux. We can use help command, and I can go and check say tools, say tools netstat option, and in the filter option filter is ANR. So let me show you that also. I can go to tools, say netstat, VPN, for example, or leave this VPN option. So then can I have option? Yeah, option and then ANR. It will show you all these things related to network stats. Alright, so you can go to help and you can spend some time, you will understand this more. We have other option, that is netstat. With help of netstat, generate network packet. Sorry, we have this tool nping, not netstat. Netstat we have already covered. So we have nping, generate network packet analyze responses, measure responses time, etc. We can use this nping command, and we can have an output. So let me show you that. Suppose I am using tools nping and then this IP address, and it is generating all those things. But remember, we have examples here. So nping TCP port 80 flag reset TTL2, like that also we can give. Nping ICMP time delay of this much, then public public echo, etc. So we have so many filters related to nping tool that we can use. So let me quickly go and ping at least one of the destination. Okay, so where I am. Okay, we'll go to the lab section, and I need one destination IP. Oops, it is disconnected. Okay, so interface description. So suppose I will use this VPN 10 IP, and I'll go back. We'll do n tools and then nping, and then where this say without option, for example. You can see all these things, but always we can go and use the filters as well. So likewise, we have Minicon, one tool, that connection to the serial console through USB port. We can use this. Some descriptions are there. Have a look on that. Then we can get the IP route table. We can use that command, no problem. One of the very interesting tool we have actually is iperf. Now for this iperf, we can make one of the vEdge as a client and one of the vEdge as a server, and then we can determine the overall throughput in between. So this iperf and jperf is actually Java based performance analyzer. iperf we can use via CLI. So run test to display various parameters related to timing, buffer, and TCP UTP protocols for IPv4 and IPv6. This command is similar to iperf command, that is a standard iperf command. So very useful. Also this we can refer and check. Finally, we have tools related to SDWAN. Now SDWAN is something, you can see the big definition of SDWAN. It's a session traversal utility for NAT. Okay, so this is one protocol that if we use this particular tool, discover the local device external IP when the device is located behind the device. So if I am using NAT and I am behind the NAT device, then I can use these options to check that what is the local address, map address, and the other stuffs. Okay, so these are all the tools, and very much now you can understand what the tools can do. Let's go and finally run this tools IP route. So here I am, I can run tools and IP route. Even see iperf is also there, and it will tell you the IP route output. Okay, so these are the options. We have very interesting option, and these options can be used while doing the troubleshooting. So if any slowness, any performance issue with the server, we can use iperf, jperf. We can check what are the open sockets with SS. We can check the netstat. We can do the nping. So all these tools are actually good for troubleshooting. How to check when we have issues with ZTP server? You can go to this particular link and you will find document, means how this ZTP works. Let me go and open this particular document. All right, so this is the document I was referring in the PPT. For ZTP to work, what are the prerequisites? First of all, that particular device should reach Google public DNS, these IP addresses, correct? Then the edge or gateway router at the site must able to reach ztp.viptela.com. Okay, means your interfaces should resolve the DNS entries for that. Now, if you are using these particular series of devices, you should connect these interfaces to do the ZTP. Here is the diagram that how everything works. So you can see that once you turn on the device, first of all, it will try to contact the DHCP server to get the IP, or at least to get the DHCP messages. Then it will try to resolve the DNS. Then it will contact the inside. So first of all, it will contact the ZTP server, and then this ZTP server will redirect that message to the inside vBond server. So here you can see my ZTP is also a vBond. My inside vBond is also a vBond server, or it's a vBond device. All right. So let me quickly read this particular point 1 to 11. And what are the mandatory things we have? First of all, power on the device. They will start the DHCP. Now, if they got that DHCP offer, so you can say DHCP offer message that contains the IP address of ZTP interface, then ZTP process continues. If not, then they will do some process with auto IP, and then it will start the step number 3. So now my interface is able to contact to DHCP ZTP server, that is ztp.viptela.com, and then they receive the IP address. So here you can see that the router contacts the ZTP server. The ZTP server verifies the vEdge router and send the IP address of the vBond orchestrator. And this is very important. Now this vBond orchestrator is within my organization. So how many authenticator we have? We have one ZTP .viptela.com, and then we have one vBond. So in my case, that IP is cisco.ztp.com. We'll see that. So from ZTP, it redirects to the organization vBond orchestrator. Then the vBond orchestrator will authenticate the chassis number, serial ID if it is okay. So at that time, it don't have the public IP, or you can say not public, but it don't have the system IP of the device, because system IP of device it needs to further continue the process. So here you can see in the note that at this point the ZTP process, the router does not have a system IP, so the connection is established with null system IP. Often when we are doing show control connection, at that time you can see that the process starts with 0.0.0.0 with null system IP. The vBond orchestrator uses these two numbers to verify the router. The vBond orchestrator then sends the IP address of the vManage NMS to the router. Now, question is that how vBond knows what is the chassis number and the serial number. So what is happening? Whatever device list we are uploading to the vManage dashboard, that will be updated via vBond. Means vManage will update that chassis number, serial number to the orchestrator. So that's why they have the chassis number and serial number. Now once this particular authentication is done, so the vBond orchestrator then send the IP address to the vManage NMS to the router. The router establishes a connection with vManage and verified by the NMS. The vManage NMS send the router its system IP. So now the router will get system IP, and again it will re-establish the connection with vBond with the system IP. Again it will establish the connection with the vManage. If you don't have the updated software from vManage, it will take the updated software, it will upgrade itself, it will reboot, and again they will try and contact to the vManage. If everything is okay, then they will form the permanent tunnel. So here one important note we have that for ZTP process to succeed, the vManage must contain a device configuration template for the vEdge router. Okay, so what are the things that we need to check? So first of all, we should reach where we should reach? We should reach to ztp.viptela.com, correct? So whenever I am doing the ZTP process, suppose one of the C edge router I want to do the ZTP. So it has one VPN 0 interface that can resolve ZTP dot Viptela, or it can reach here ztp.viptela.com. From ztp.viptela.com, what is happening that it is redirecting that particular request to the local VBond server. So I have my VBond server in the organization. Now this VBond server, with respect to chassis number and serial number, it validates this particular device. Okay, and then it will contact to the vmanage. Correct. Now vmanage will give him the system IP. Once this device has system IP, again it will form a temporary tunnel with a vbond. Vbond will again validate it, and then it will establish a permanent tunnel with the vmanage and the vsmart. But to this process to be happened, we should have a template, device configuration template in the vmanage. So now we are going to check all this process. We have to check that do I have VPN 0 interface up? So I'll write up, first check. The second check that I should reach to ZTP, or I should resolve ztp.viptela.com plus the Google DNS 888 or 8844, like that. Then what will be third check? Internally, this ZTP should redirect towards the local vbond. So that is very important. For device perspective, what is the third is that the vmanage should have device template, correct? And the fourth and very important thing, that vmanage should have serial number, chassis ID, that he will update this serial number and chassis ID to the vbond, because first time when device will authenticate, the vbond should know that okay, I have that serial number, chassis ID, then it will forward that request to the vmanage. So these things we should have. So let us log to the device and let's see that where it is failing, and then parallelly we'll do the troubleshoot. So here we are in the lab section, and here you can see that I'm inside the vbond 1, but I have my ZTP. Here I can see the ZTP is there, and I have the vbond also. So this vbond also I will check, no problem. If I go to vbond, if I check that show orchestrator, say valid v edges, I have this list. Here you can see I have this particular list. In this particular infrastructure, let me show you the dashboard as well. I have 6 VS device, and one I'm going to do the ZTP. Okay, so here we see that how many serial numbers we have: 1, 2, 3, 4, 5, 6. That means one of the device that I am going to do the ZTP is this. Why? Because again, if I go to my vmanage dashboard and the devices, if we see the list of devices, only one is showing unresolved. And if we go here and if we try to fetch what is the cloud init bootstrap, so we'll go here and we'll see that generate a bootstrap configuration, that is cloud init bootstrap. From here also we can match that, okay, what is the OTP? OTP means the token. What is the UUID? What is the vbond? What is the org name? So these things this particular device come with. Okay, and these things has been communicated to the device. That means from vmanage, my vbond knows the list. So suppose if I go to my vmanage, let's log into the vmanage little quick, and we'll verify those entries, although we have seen in the dashboard as well, but From CLI also you can go and check show, not software. So I want to see that I have that valid entries. Let me see that if we can, well, see, you can see show control. It's, although the font is very small, but I'll read it. Show control valid V edges. Valid V edge. And here also you can see that's the same list that we have here inside the local vBond. Okay, so far it's good, it's okay. Now what I will do, I will go here to the my edge device to whom I want to bring up. So this is my edge device and I want to do the ZTP. I'll check show interface description because my VPN 0 should be up. VPN 0 interface. So VPN 0 interface gig E00, I should do no shutdown and then I should do commit and quit. Show control connection. Now parallelly what I will do, that I will go to the vmanage device and templates. Then I can see that okay, branch 1 I want to push the configuration because I have this configuration and here is the serial number. Attach this. I don't have these information, so I can upload these information from the Excel file. I can go to desktop and if I have the software image CSV configuration file for branch type 2 CSV, upload it. Next, this is the device I want to do the configuration. This is the configuration. Schedule. We'll wait. And parallelly, if I go ahead and check control connection, so what's the order? So order the operation is that this will contact, first of all, my vEdge will contact to ztp.viptela.com. From there, it will be redirected to local authenticator. In our case, that is a vbond.cisco.com. Why I am telling this? Because if you see the configuration, if I show you that, show run system, see what's the vbond IP it has? ZTP. Oh, that's okay. But once it will redirected there, this vbond IP will become something vbondcisco.com. Okay. And if I have any other device where I can show you that, see vbond.cisco.com. Okay, these are the vbond DNS IP. So either it will redirect to the local vbond IP or the local DNS server. Now once it will get redirected there, then all the ZTP process will happen, adding the point that we have pushed the template from the vmanage to the device. Okay. So all this process in depth happening, and if it is not happening, that means we have some issue. Still nothing is happening. So that means I have to go to the ZTP server. I should see what is the ZTP entries it has. You don't have entry. That means I need to put that entry, and we can put that entry, say request device add chassis number. What's the chassis number we have? So let's take that chassis number, and we know this is the chassis number we have here. Okay, serial number. What's the serial number it has? This the serial number. All right. Then validity, valid. Then vBond. What's the enterprise vBond we have? So the vBond I can take from here. That's the vbond.cisco.com. Alright, so vBond is this. Then port number. What's the default port number for this? That should be 1, 2, 3, 4, 5. Let's see if we have the port number here. Yeah, the default port number is 1, 2, 3, 4, 5. If you do show control connection, or if we go to say any other device, if we check show control connection, port numbers are different for that. So I'm going to use 1, 2, 3, 4, 5 for my ZTP port number. So let me go back here to the ZTP and we'll use that port number here. Alright, and org name, I have to give the org name as well. So let's check the org name. Let me copy paste the org name. Alright, we are almost done, and my port number should be correct, otherwise it will throw an error. Let us quickly verify this over the document. Okay, let me open the document. We'll see this command, because if this command is incorrect, again it will fail. So open the document. This also I'll put in the PPT, and here you can see that we are almost correct. Chassis number, this is just a demo, this is not the exact one that we are using, but we are here at the org name. So once I put the org name, then it should work. Okay, so let's go back and let's do it. Alright, so if I put the org name in this format, I should give quotes, otherwise it will not understand that. And then if I type question mark just to validate myself, enterprise roots here. So we are good. Press enter. That entry has been added, and our port number should be correct, because if we check the document, the default port number, it is coming with 1, 2, 3, 4, 6. But anyways, let's go and check that anything is happening here. So I think I need to restart the process. Show run, or maybe we can check show interface description. That VPN 0 should be, oh, so here it got the IP. You can see it got the IP, and if you see the configuration of this particular device, the ztp.viptela.com it pointed to, but it got the IP and it has resolved the DNS, it seems. So now if I go and check show run system, see now it tried to contact the port number 12345. So it has contacted the ZTP server. From ZTP server, I tried to communicate with this particular port number, and if I check show control connection, still it is there. If I go to vBond, say for example, if I check the entries, still it is not resolved. If it is resolved, it will get one serial number. So what I will do, again I will go and push the template. Okay, so let's go back and push the template. Still here you can see validation is successful, but I'll go back to the template. I detach this. It seems that it is showing that it has pushed the template. Wow, what's the status? Still 6. So we'll go back and First of all, we will detach this. Seems that nothing is attached to be detached. Cancel, no problem. We will attach the device one more time. And where is branch 2 VH1? Wow. So I don't have branch 2 VH1 serial number. Initially it was showing. Now it is not showing. So if I go to the dashboard, so these are the things that we need to check. Correct. And if I go here to the devices, sync pending, device valid. I don't want to delete it. I don't want to decommission it, because if I delete it, then it will be gone. Okay, so at least you understand here what is the process, what is the order of operation, and you have to give the correct entries at all the points, correct? Everywhere you have to give the correct entry. So I just to show you, I have missed so many things here. ZTP entries. Now we have the correct ZTP entry, but the port number I use 12345. I should use 12346 here, and rest everything is actually okay. So let me try to check that if I could do sync is pending. So if I remove from here and I sure want to delete this device. Okay. Behind the scene, it has some certification process because they're not able to contact. So here you can see I tried to do the certification, but it failed in some stage, and now actually it got stuck. This particular device is got stuck somewhere. Okay, so that's why it is not able to form the connection. To reinitiate the connection, at least I can go to gig interface. I can do shutdown, commit, no shutdown. Yes. Okay, so now what I will do, I will stop this lab here, and I will start with the correct ZTP and correct configuration, correct template, and then I will attach it. Okay, so we can stop here. Let us continue where we left off. So if I go to the ZTP, if I check what are the ZTP entries, I have put the correct entries, correct port number, everything is correct. Then if I go to my, say, vBond, if I check the orchestrator and valid vEdges, okay, I have this that I need to validate actually inside the ZTP process. If I go to vSmart, if I check show control and valid vEdges, let's see what vEdges we have. So this also have the list, vManage also have the list, everyone has the list. Now what I will do, I will simply go here, I will go inside, say VPN 0, interface gig E00, no shutdown, commit and quit. So let me do commit and quit, and then I will go to my dashboard. From dashboard configuration template, I am going to push the template. So I am going to push the branch type 2 template. Let us attach the device, and then we have to fill up all those criterias as well. So let me select this name, push here, attach it, and then we need to upload the serial number, host name, and all those things. So here you can see that I have, say, branch type 2 template dot CSV. That's the correct one. If I upload, then everything will come here. So you can see what is the site ID, the system IP, and all the variables. Let's configure this. And parallelly, what I can do, that I can go here and I can enable the debug, say with respect to vdaemon all. So all means conf events hello miscellaneous packet and transport events. It will be saved. So we'll go there and we'll check. Alright, if you want to see here, so that option also we have always. Let me do that as well. And then we have log and then we have vdebug. Alright, so let's push that configuration. It is scheduled. We'll go back here to check all the log messages. And here we can see that, okay, WAN interface, daemon miscellaneous, device certificate, see serial number 26, the org name. It is happening very quickly. It just started the ZTP process. And severity level and the certificate validity, you can see the 000 as the system IP that we have discussed already. So peer we manage IP 000, the public IP is 21. 21 is one of the vBond. I'll verify what's the 21. So 11 and 21 is the vBond. If I go here and if I check show run system and 11 and 21 actually the vBond IP. So try authenticate with vBond, success. So what I will do now, which is going very fastly, the ZTP process is happening, new state, yes. If I press enter now, you can see the name of the host name has been changed. So let me stop this. Okay, let's go here and stop this vdebug. And we have long list of messages that we can use to identify or to manipulate that how exactly behind the scene this ZTP process happens. There are so many important things from the template also, because we have debugged for the vdaemon config as well. So we are getting the config related logs as well. Okay, and we have all these things. So what I can do here, let me copy paste this log message and here it is. Let me copy paste and we can read it. Even I'll save this message and upload with the video recording so you can have a look on this, how this ZTP process happens. Okay, up to here, up to all this. So let me open the notepad and let's quickly read it. Here it is. And wow. So what I will do, I will upload this and you can check the entire log messages, that how things happens from where to where, so which process is starting, then the connection state change, severity level, major alarm generation happens, then the T-log, then you can see the home admin VHCSR. So the certification process also happening behind the scene, because it has to be certified, and all the devices, edge devices, they are doing the certification automatically. So CSR uploaded successful, root CS certificate install, where it is root cert, so you can go and check user bin. This is the place, so I can go to user bin. Let us quickly walk. So I can go here and cd say user bin ls-la. Now we can see here the vdaemon root cert compatibility check they have done. And what's that name? That is vconf underscore script. So even I can check the files related to April 6th that today we are doing this. So I can grep. I can do ls-la and we can grep what we want. Alright, let's see. So for 9th of April, otherwise we need to check it manually. And other thing that we have here, that from here itself we can copy and so here you can see that path, the root certificate path is the root CA certificate chain install called this. Path is home vmanage admin master root CRT, and the uploading certificate over VPN 0 master root CRT. So we have this home vmanage admin as well. So there also I will go upload CA permission denied. Yeah, it's okay, no problem. We can go to say home and we can see this vmanage admin. So we'll go to vmanage admin. We'll check master root cert. Okay, here you can see that from master root cert it is uploading that. So all the information that what is happening behind the scene we can go through and we can check now home vEdgeCloud cert. So inside the vmanage admin cloud.cert via vmanage, so that is also there. And then let me go down. So once the certification process happen, what it will do, so first of all they validated the serial number chassis ID, install the certificates. Once the certification is there, then OTP generation sync happen, all these thing happens, tracker grade etc. Now it is validating the serial number and the org name. Certification validation will happen. Till here it happens, then it will start the OMP process. Okay, because the underlay will communicate with the overlay. So we have the vsmart addresses, and with vsmart it will form the OMP process. So after the certification they form the DTLS connection. After the DTLS connection they form the OMP, and then the ZTP process start. Say config ZTP status success. See, so we have this success message, and even on the top you can see the OMP is happening. It is happening. Then ZTP success. Now with the ZTP we have pushed the template. So once the ZTP is successful, it will redirect that to the local vbond, correct? So inside local vbond, that local vbond with the system IP of 000, it will try to communicate with vmanage. From vmanage it will get the exact IP address, and then so if I go here, if I do say 0.0.0.0, this will be the system IP. You can see here in the bottom we have this system IP 000, and how they are doing the authentication with system IP 000. Okay, so we can see here that somewhere in the mid that okay, the state has been changed, it is going to be subscribed. The from the device it got the name, but it is doing all those things with system IP 000 here. And if I scroll down you can see the major host name, branch 2, the system IP, personality, the peer vmanage, because you don't know the vmanage IP. So it is try to communicate with this, whose public IP is this, whose port number 12346 that we have uploaded there. And once it got authenticated, then the vmanage will push the correct image and the configuration to him, and then this complete thing will happen. And then my device is up and running. So what I will do, I will upload this file for your verification and study purpose with the video. Now next task, we have issues related to VRRP. I have given this link, you can go and refer that how we can configure VRRP over the edge devices. We have some different configuration, although the concept is the same, that it is used as a first hop redundancy protocol. And here in the new topology, now we have new lab setup. In this new lab setup, we have say VPN 10, 20 and 40. For these VPNs inside this particular branch, branch number 1, so here you can see that okay, I'm inside VPN 10, and I have VRRP running here in the bottom where it is connected with a LAN switch, and in between VH1 and VH2 I have VRRP. So I have some issues related to VRRP in branch 1, and with respect to VH1 and VH2 that I need to fix, not only with a VPN 10 but VPN 20 and maybe 40 as well. So we need to check that issue and we need to fix it. Before moving further, let me show you the URL that I have shared here. So if you go to that URL, you will find the configuration option that we have for the VRRP is the same, that you can go and first of all, obviously you have to go inside VPN 0 and then interface. Inside interface, you can go to the VRRP, you can assign what is the virtual IP. But here we have two new things. One is track the OMP, track the overlay management protocol. So that means if my overlay is gone, is still then what will happen? What will be the use case then? Say overlay is gone, I have for example, two routers in a VRRP, then how the traffic flow will be. So if suppose overlay is gone, so suppose I have two devices like this connected in the LAN segment, my overlay is gone, say with respect to this device, and this is the master, and this may be backup. So what will happen, although this backup device has less priority, for example 100, it has the priority of 200, so that's why it was a master. Although it has the lower priority, still the traffic will go via this. And once this will be recovered, so that timer is like 1 minute or 60 seconds. So once this is recovered, then the traffic will flow in this direction. So this is the new option we have for VRRP. With respect to SD-WAN, and other option, very interesting option we have, that we are tracking the OMP plus some prefixes, that is track prefix list. So if anything happening with this particular prefix, then my backup will become master, traffic will go in this direction. Okay, so go ahead, read this particular document, you'll find very good explanation here and some of the examples, although the configuration example I am going to show you. So let us go to our lab and check the configuration, and then we'll start the troubleshooting. So here it is, I am in the lab, and if we go here, if we check that show VRRP, how many VRRP we have, it is showing that okay, init state. Few of the VRRP has different timer, few of the VRRP has a different timer. Priority is 200, but still it is OMP state is down. So I need to check and fix the OMP state. I'll go to the other side. Here it is up. One of the VRRP is down. The OMP state is up, but the VRRP state is init. So what I will do here, let's debug VRRP and say events VRRP for 10, 20, 30. So we need to give that value as well. So let me do this little quick. Events and packet for VRRP 10, and I'll debug the, so let's do for 40 as well. So debug the VRRP events for VPN 4040 and then the packets for VPN 4040. Now I want to see here, I don't want to go in the location, I just wanted to enable monitor start and then log and temp log and then vdebug. Let's see what is going on, because still it is in init state and other VRRPs are there, so they may send the messages, and we'll see. So here you can see with the log, with the debug messages, that yeah, they are advertising this and they are expecting what is the multicast address, what are the other stuffs we have. So from here, if we are able to figure out that what is going on, okay, so let's do one thing, let's stop this. So let me go up and let me see my debug. That's the problem with the debug. Once you start the debug, then it's very difficult to stop it. So let's do one thing. I will go monitor and stop and var log temp. Wow. Log and then temp log and we debug. Stop it. Alright, so we have same type of messages and we have lot of messages that we can, here also we can analyze. So let's analyze few of the VRRP messages. VRRP invalid RD, received 10, expected 20 gig E04. Advertisement message 40, source is this, destination is this, multicast, priority is this, advertisement interval 1, advertisement this, receive this, expected this, priority this. So first of all, see that which VRRP I have issue. VRRP 40, so that's why we can selectively choose the VPN. Suppose if I choose the VRRP for VPN say 40, then I'll get message for that only. And what I'll do here, I just wanted to stop this as well. So I want to do no debug all as well. Let's stop it completely. All right. And from here, we can see that I have one virtual IP that 10301 and 10301, 10320.3, 10301. So I have messages related to that. And you can see here I'm getting lot of messages for this. I haven't got messages, so what I have to do that I can copy this log and then I can search in the file because it is in the init state. What's the problem? Show interface description 05 is shut down, so that's why we don't have message for this. So let's quickly go to VPN 40 interface gig is 0, no shutdown. Commit this, and once we are done we can check show VRRP. So now this become backup. Okay, that means the other side should be primary, other side is down because the OMP is down. So what I'll do, I'll fix the OMP. OMP is down. Let me check what is the control connection. Control connection is at up, so I'll go here to OMP and we'll do no shutdown commit, and we'll come back here which see VRRP because it will take approx 1 minute. So it's still master backup. On the top you can see this is still in backup. Its timers are different for that. Rest now it okay, still it is the backup. Okay, still it is the backup. And here if I go back to the VH1, if I check show VRRP, now initially master backup, now master backup. Okay, although the priority you can see priority 100 less priority, but still it is master, and these things are not in stuck or anyways any state. So we can see now it become the master. Okay, so we need to fix the timers as well. So what I'll do, I'll go here and inside say VPN 10 interface Gigi03, we see that what options we have with respect to VRRP. First of all, we'll go to the group number. You can see here IPv for priority, timer, back track OMP, and the prefixes. Correct. So let's check the timer, and one. That's it. It will adjust the date timer. So we are very much good here. Now we can go to VRRP. We can see it's a master. It has the correct timer, and then I can check what other options I have. So I have options related to interfaces, and so VRRP say VPN 10 interface. I can choose the interface groups 10, and then here you can see that advertisement timer. So what uh, options we'll get here? So if I press enter, you can see here that okay, virtual IP is this, virtual MAC is this, priority is this, master is this, up. Now here I can check that last change time, master down, OMP state, prefix list, priority, track prefixes, virtual IP, virtual MAC, etc. So if I do advertisement timers, so it's like the same one by one option you will get. So that's okay. And any other result? So this is the only result we are getting. What other options we have? So I can go to say interface and I can press enter. So these options only, either you will get to know this information, or you can selectively select VPN or interface and you can check the output. So now our VRRP has been stored. You have seen that how we can check the debug messages, and if any configuration mismatch, how we can correct that. Okay, so we are very good to stop here. Let's stop. Hi everyone, welcome to the QoS section. In this section, we'll see that how in Viptela world, the V edges, they are reacting to the QoS policy. How many QoS policies we have in V edges or in this Viptela solution, and how we can apply those in the V edges or in the site. So let's get started. Before starting that QoS inside the V edge devices in the Viptela solution, let's have a discuss that if we don't have QoS, then how the packet is routed inside the fabric. So what is happening actually that from a service side, say I have one service VPN 10. So from that particular service side, a packet has source and obviously it has the destination, and from this segment we have the destination segment. Inside the tunnel we have IPsec tunnel. So what will happen that once the packet reaches to V edge, then V edge, according to its local TLOC and its remote TLOC, because we have IPsec tunnel, so it is adding the ESP header and outer header according to its local TLOC and destination TLOC. Actually, what the V edges are doing, that they are associating two types of security SA. Now the packet is traveled inside the tunnel. Once it reaches to destination, then obviously they will decapsulate the TLOCs, and again they have the IP packets to the destination. So this is the overall packet life without QoS policy. And here from this point onwards, let me mark you. So you can also pause the recording and you can go through line item by line item. The important thing here to note that the V-Edge router previously received its SA from the vSmart controller. There is one SA per TLOC, but more specifically, each TLOC has two SAs, an outbound SA for encryption and inbound SA for decryption. So that is very important, that we have two SA, outbound for encrypting the packet and inbound to decrypt the packet. Likewise, in the subsequent slide, you'll get the other information that already I explained to you. So you can pause the recording and you can just have a look on this. This is the packet life for a packet inside the Viptela fabric without QoS setting. Okay, let me go further and let us discuss that what happens when we apply the QoS policy and what sort of QoS we have in the Viptela solution. So let me do one thing, let me stop here, and in the next record we'll discuss that. Okay, let us check the packet forwarding status when we have added QoS in the V edges. So what will happen if we add QoS, because we know that from one VPN to other VPN, from one site to other site, we have by default VPN, or we have by default IPsec tunnel. What will happen from a local site to a remote site? Once the packet will go to the IPsec tunnel, that in between now the packet have some classifications. So before route lookup, we have input classification, input ACL and policy, and after route lookup, because this route lookup will happen from the vSmart, because vSmart, they will push the policy, will try to find what is the best path from source to the destination, or from one tunnel endpoint to the other tunnel endpoint, with maybe various parameters including TLOC. Then there is route lookup. Route lookup obviously
we have some vSmart policy, that is the centralized policy from where it will select or it will instruct that V edges they have to choose this versus this route. So this will happen. Then again in the egress direction we have policy with help of ACL. What we can do, I will show you in the lab section, that we can have various QoS settings and we can map inside a QoS map. This setting we can see in the upcoming session, but yeah, we can define cost map. And finally, if we want to rewrite the DHCP values and if we want to do some action on those values, we can have that option as well. So we have policy, we can classify the traffic, we can rewrite the traffic, we can have the QoS map. So all these features we have. Okay, let me go to the next slide. And yeah, so in this way we can understand that how QoS is working with respect to ingress and with respect to egress. And we know that this is a feature of V-Edge, so you can see on your screen. And the second important thing here to understand that how many QoS, how many queues we have and what queue are reserved and where we are applying the other QoS features. So we can classify, so one by one let's see that what are the other functions we can do. So we can classify the data packet according to their forwarding class, and obviously these things will become helpful or easier when we'll see the examples, when we'll do the lab. Then at that time you will understand it a bit more. So let me close here this particular recording, and in the next recording we'll see that what are the attributes or what are the features we have. So obviously the QoS features we have in Viptela for Viptela V-Edge devices. So see you in the next recording. So far what we have done, we have seen that in Viptela without QoS how the packet forwarding happens. After applying QoS, how it happens. Let us check some of the features or some of the QoS parameters inside Viptela V-Edge devices. So first of all, what we have to do, that we have to classify our data packet, and this is very much similar that we are doing in the Cisco world. We are using the class map for various classes, means these classes related to maybe AF or say B, that is the best effort. So we may have AF1, AF2, 3 like that. That is the assured forwarding. So like that we can create certain group of classes to classify the traffic. Again you will see this in the upcoming examples. So that is the one thing that we can classify based on the forwarding classes, and once we classify then we can do the scheduling, rewriting and other policies over that. So first thing is to create the class map, and what other stuffs we have here. We can do the scheduling. Scheduling means if we have hardware based V-Edge, at that time we have total 0 to 7, means we have 8 queues, and obviously Q0 will be there for control traffic. Q1 to 3 is there for the data movement or data traffic. Now say okay, I have the data and I have defined the queues. So I will show you in the upcoming example that I have classes and classes are mapped to a queue. Now what these queues can do, they can use weighted round robin method just to do the scheduling. Okay, So it's very much normal to the normal Cisco QS that there also you have some priority queues, some normal queues, and in the normal queues they can do the algorithm like weighted round robin method, or maybe some weighted algorithm just to schedule the packets. Apart from that, we can do the rewrite of data packets. What does it mean? That rewrite rule, it's very much that while the packet will leave the VH, at that time we can mark with certain DHCP value, and on the basis of that we can use something weighted random early detection or RAID policies to drop the packet, to drop the certain packets whose SLA or whose latency is not that much compatible with some voice or with some latency or jitter related packets or traffic like that. Okay, so this is again very much similar concept that we have in Cisco. And finally we can do the policing on the traffic. Here the important thing is that we can have policy in the inbound and the outbound interfaces. Policies applied to the inbound interface traffic allow you to conserve resources by dropping traffic that does not need to be routed. And while if we are using the outbound traffic, at that time they can control the amount of bandwidth used. Okay, so this is the introduction, or you can say that this is the theory of Viptela QoS. In the upcoming sections, I will show you the examples that how we can create classes, how we can use the ACL either in the inbound or the outbound direction to apply these QoS policies, how we can create schedulers, or how we can map the classes to the schedulers, or how we can assign the QoS with certain classes. And again, obviously by the end of the day we have to call everything inside the policy and then apply to a certain interface. Okay, so all these things we'll see in the subsequent recording, and see you in those recordings. Let us see that how we can implement QoS inside our VHs. And obviously in this particular section I'm going to show you that how we can implement QoS and then how we can verify it. There are several steps that we need to follow while we are doing the QoS configuration. First of all, we need to define our class map, and in that class map we need to map our traffic classes with certain queues. So we know that we have 0 to 7 queue, and 0 is used for control traffic. From 1 to 7 we can use as our class or as our traffic classes. Then secondly, we can use QoS scheduler. What we can do here in this scheduler, that we can provide bandwidth, buffer, and then they will use their scheduling as per RAID, that is the random early detection, or maybe WRAID, that is weighted random early detection, but the methodology is to use RAID. We can create QoS map, and on that QoS map we can map this QoS map with the QoS scheduler. We can define ACL, we can apply the ACL to the interface, even we can rewrite the policy as well. So let us see one by one that how we can do this. Firstly, we can create class map, and we can map our say best effort to class with Q2, assured forwarding with Q3, 4, 5 like that. So let me do it parallelly. I have my VH. Let me open that. And this particular VH, what I can do, first I need to go to policy, I can go to policy, and if I type question mark here, you can see that we have options related to class map, QS map, QS scheduler, rewrite rule. Here I am interested to build my class map. Even I can type question, and you can see we have option, but better we can do like this. We can give name something like name of class. Suppose I am using BE, and I am mapping this with Q, say 2. Likewise, I can give class as AF1. I can map this with Q3, class AF2 with say Q4, and finally say class AF3 Q5. We can check our configuration, like we can do show configuration, and here is our example. Obviously I need to commit it, and we have one error. Okay, because I'm using this cloud VH, and I told you earlier this thing, that if you are using the cloud setup, means cloud VH, so at that time we are limited with 0 to 3Q, where 0 will be used as a control traffic class, and then we have option, either we can use 1, 2 or 3 or all of them. So we need to rewrite our policy due to the limitation of the cloud based VH. So what I can do here simply that okay, I can abort. I can go to policy, class map, and then I can use something like this, that okay, class B can use Q, the class name is B, can use Q number 1, and then I can use class say AF1 can use Q number 2, and I can restrict here AF2 can use Q number 3, and then I can commit and quit. Now we can verify. System is vmanage, this is being managed by vmanage, so configuration is not allowed. We need to remove this from our vmanage. So what I can do, I can go to configuration, template, and from here I have branch to type 2. I can detach the device. I have this device configured with help of vmanage. Let me select it and detach it. So once I detach, I can go back. Now if I commit, then you can see that, oh, okay, still it is in progress. So once we'll get the success message, then what we can do, commit and quit. Okay, so we needed to detach it properly, and now we have the success message. And now if I click configuration through CLI is not possible, and this is DC1VH1. actually I have detached the other device, no problem. Let us quickly do this. Let us go to the template, and I can detach the device. You can see here that you have to select the proper devices to do the configuration. And here now I am detaching DC1 VH1, and if everything is correct, then hopefully we are able to push the, yeah, you can see we're able to push the policy. Now if I need to verify this, what I can do, I can simply go to show policy and I can check my policy. So here I can see that I don't have option to see my class map. I do not have option to check my class map configuration. Even what I can do then, I can do show run policy and then class map. So this way I can check my class map configuration. But if I do show policy and then if I check, I don't have option, but I can check my QoS information that we'll see in the upcoming recording. So let me do one thing. Let me stop here. In this particular section, I just explain you that we have 6 steps to do the QoS configuration, and we have done the class map configuration and we have verified. Obviously, we have checked one exception that in the cloud-based VH, we have only 4 classes. One is 0, that is reserved for control traffic or control class or traffic in the traffic for the priority or high priority traffic, and that is something prioritized. So let's just stop here, and in the next section we'll cover up more on this. See you in the next recording. We have done with our QoS. Let's move and check QoS scheduler and QoS map. We have one use case here, and what is the use case? This use case, it is telling that configure QoS scheduler in such a way that you can see here in the description, the AF3 traffic has higher priority as with BE with 10%. So it's something like this. Something like this, that we know that we have traffic classes. We know that we have class AF1, AF2. In this example, I haven't used AF3, but we have classes AF1, 2, and then BE. They are mapped with some QoS. So say QoS 2, 3, or 1, like this. That will verify in the CLI. Now what we have to do, that say for AF2, for example, it should have 30% of bandwidth and 30% of buffer. AF3, in our example, it is not a case, so exclude AF3. So what we can do, we can distribute the bandwidth, and I'll show you that how we can do it. We can distribute bandwidth. So here we can provide some bandwidth and some buffer. Here we can provide some bandwidth buffer. Let us remove this, and here we'll provide some bandwidth and buffer. So let's do like this. Give this 50 and then give this 40 and then give this 10. Okay, so this is something like 100. Okay, and then let's do the configuration for this particular section, and then we'll move further. For that, I need to log to my VH DC1, and And what I can do here, I can go to policy and then the QoS scheduler. Let's wait that we'll get our console. What classes we have? So we have class with bandwidth and buffer, something that we are going to reserve 50, 40 and 10 for BE, that is the best effort. We can check our configuration with something like show run and then policy and class map. Now again we can move to policy section. Inside policy we can give QoS scheduler and we can give AF1, that is mapped to Q2 actually. Here I can call my class AF1 and the bandwidth buffer I can give, and that again we can check that what is our use case. But for AF1 I can give bandwidth percent as 40 and then I can give the buffer. Let me type question mark here so you can see that I have option for bandwidth, buffer, drops, scheduling, like that. So the buffer percent I can give again, that will be 40, and then I can use drops and I have option either it can do tail drop or red, random early detection. I can check my configuration like this. Likewise I can exit from here. I can go to AF2 where I have the bandwidth percent of 50, buffer percent of 50, drop is the same, red drop, and finally I can go to my QoS scheduler BE where I have bandwidth percent of 10, buffer percent of 10, drops I have red drop. I can exit from here. I can check the entire configuration that we have. So I have class AF1. See here I haven't mapped any class. Here also I haven't mapped any class, so I need to map the classes as well. So here what I can do, simply I can go here, I can map with class AF2, exit, and then in QoS scheduler B I can map class B and exit, show configuration. Now we have the schedulers and we have the classes and we have the bandwidth percent and the drop percent. Now we are good. Here we can do the commit thing. Once it is committed, I just wanted to check here that without run how we can check it. So this is our QoS scheduler info, general info. So now we are getting it in a tabular form. Q1, Q2, Q3, like this. This is the bandwidth percent. I haven't used cost map here, but I will use in the next section. Here you can see it. It's nice and easy to do this. Let us go back. Let us check that what we have in the next section. In the next section, we need to do this inside a QoS map. So what I can do, that whatever AF1, 2, 3 I have, I can use inside a map. Okay, and then I can apply this as an access list. So let's do this first, the QoS map, and then we'll move next. Let me go to my VH, my policy. Here I can use QoS map I can give any logical name. Say I can give the flat name like this, but generally we are giving names in caps. If 1, if 2, B, show configuration, commit, show run policy. So we can see the entire policy. So what I have done so far, I have created the QS. I have created the class, map those class to queue. Then I have created the scheduler where I reserve the bandwidth percent and the tail drop. Bandwidth percent tail drop. And finally, these scheduler, they can do weighted round robin method. They can use it. So I group this scheduler inside a QS map. Now, if I check show policy, QS map info. So here you can see the map info. Apart from that, I can check show policy, and then I can check QS scheduler info. And you can see here that now it is in the tabular form. So now we have this name, percentage, buffer percent, queues, and the QS map name. Okay, so let me stop here, and in the next section we'll discuss about the how we can apply this over the interface. So see you in the next section. Let us continue our configuration section, and in this particular section I'm going to create access list, and I'm going to apply it on a certain interface plus the QS map that we have created in the last section. I will apply it, plus in this particular section I will create rewrite rule as well, and then I will apply it. So let's do all these things in this particular recording. I'm here in my DC1 VH1, and I don't want to do any configuration in this particular device because I want to do configuration in one of my branch, that is say my VH1 in branch 2. So let's do one thing. Let's copy all these stuffs and we can paste here like this. We can validate, commit, and quit. Now what I want to do, I want to create ACL rules and I want to apply it like we have in this slide. So here you can see that I can create ACL, I can match the source and the destination. In this case, I will use source as my VPN 10 source, and my destination is again in VPN 10 because I'm going to apply this policy inside VPN 10. I will use branch 2 VH1 and DC1 VH as a source and destination, and I will use this policy. So what I'm going to do, once I match the source and destination, I will set that traffic with class best default. If we have traffic matching DHCP value 10, then that will set as a class AF. And if I am matching the TCP protocol, then it will match the class AF3. That we have 3 classes here in our software-based VH, and the default action is drop. So once we'll create this rule, then obviously we need to apply it on an interface, and I'll apply it in the branch 2 VH1 VPN 10 interface in this direction. Okay, so let's do this. Let me open my VH, and here what I can do, I just want my source and destination IP. So for that I can check show interfaces, In VPN 10, this is my source. Now I can create my policy. Access list say ACL is 1, say sequence 10, and I want to match the source IP as this, and sequentially do I have, okay, it's not a valid value. Let's re-verify it. That can I take IP and length? Yeah, I can take it. So let me do like this. Okay, and once I am doing this, because I want destination as well, so I can do one more time here, and then yeah, okay, no problem. Then I need destination as well, so my destination IP is the data center 1 VPN 10 IP, and that we need to check it. Let me check here with show interfaces as well, and this is my destination. So my destination IP is 0/18. It's not in the value. Yeah, we need to give proper subnet. You know that. What does it mean? So once I have the source and destination, then I can set action. For that, I need to come to my sequence number, and here I can map a class. So my class in this case, if I type question mark, you can see all our classes are here. This is okay. Then we can exit. We can go to sequence number, again exit. We can go to sequence number, say 20. And in this case, I want to match the DHCP value of say 10. That is again according to our slide. Yeah, here exit, and the action is accept, and the class is AF1. Again I can exit, and I can exit. Now I can go to the sequence number 30, where I want to match protocol TCP 6, that is, and I want to set an action as accept with class of AF2, that is the remaining class. Now we can exit, we can set the default action is drop. We can validate it. Now I can commit it. I can go out, I can go to my VPN say 10 and interface gig 0/2, and here I can apply this as a access list. And what is my access list? ACL1 in the ingress direction. I can validate this, commit. Once I commit, now I can check like this. Now I can go to show policy and then access list, associations. Now we have the various options to verify it. Apart from that, counters, then name, and the moment I don't have policy, I can check this something like show run policy and then access list as well. So it will show me the entire policy. I have the policy where I have the source and destination matching the default class. Then I have DHCP traffic matching AF1, TCP traffic matching AF2, like that. So we are good with the ACL configuration. Then what next we have already applied. Now what I'm going to do, I'm going to configure the rewrite rule, and then I will apply this over interface. So only rewrite rule is left here. So let's see that what does it mean and what is the usability of this. See, if you know QS concept, we have something called RAID concept there, random early detection. With help of RAID, you can mark. So you can have low and high drop preference, means if traffic is coming in this particular queue, then the rate of dropping them, you can think like 1 out of 10. If it will cross this limit, then it may be 2 out of 10, means 2 packets will be dropped out of 10, and that is something like random drop, means your system will randomly drop or shoot those packets reaching the destination. Now here we can use the rewrite policy, and we can use this concept of RAID as well. How we can use this? Say I have one rewrite policy called transport, and with AF class, with you can see on your screen marking with DSCP3, then AF1 high DSCP4. Like that we can mark the low and the high drop preference in the rewrite rule. So what I can do here, let me open my configuration template or the configuration VH where we are doing the configuration, and then we'll do the configuration and then we'll check it. Going to my VH, and here let us do this thing. Let's do the configuration. So here again I have to go inside policy. I can use rewrite rule, and we can give some name like transport. We have here I can use my class AF1 and low DSCP value set 3, like that, class AF1, and the high preference is 4, like that. We have class AF2 with low of something, we can say that 5, a DSCP of 5, and same class with high of DSCP value of 6. Like that, we have one more class, that is BE, best effort, low with DSCP 1, and class BE high with DSCP 2. We can check our configuration. This is our rewrite policy. We can validate, we can commit and quit. So commit and quit. Now we are done with all our steps that we have discussed. Now the final step is to apply this. Now what I'm going to do, I'm going to apply this QS map and this rewrite rule transport policy in my VPN 0. And one important note here, that Q map and the rewrite rules are applied only in the outgoing traffic, or this is only for the outgoing traffic. Okay, so let's do one thing. Let's go and we can go to our VPN 0, and I have two interfaces actually, means I have two control interfaces, and here I can apply the policy. So I can check my QS map and the rewrite rule. My QS map is something test, and my rewrite rule is transport. Validate. Likewise, I can go to my other interface, that is 0/1, and we can use QoS map test and rewrite rule as transport, validate, commit, and quit. Now we can check our rules. So our final policy, you can see here that I have class map, then I have rewrite rule, I have class access list for the interfaces for VPN 10. I have something called QoS map where I am mapping the schedulers. Okay, so now you can see that the configuration is really big, and we have applied all this configuration. If you want to verify, you can verify it with show policy, and then we have the various options. Although I haven't used policies and other things, but still we have the verification options here. Okay. So I'm good with this particular section, and let me go back and let me show you that from where we have started this. So for that, let me go back to my slide deck. Here is my slide, and if I go back, so what are the 6 steps that to configure the QoS? Now let us revise it. So first of all, what we have to do, that we need to create class and then map the class with the queues 0 to Q7 or 0 to Q3 in the cloud-based VH. Then we can create schedulers for each forwarding classes. Then those schedulers we can map inside the QoS map. We can create ACL and we can match the traffic or match the class map inside the ACLs. Then we can apply the ACL to certain interface, that's okay. And finally we can apply the QoS queue map and rewrite rule to the egress direction. So all these 6 steps I have covered one by one. Obviously you can, if you want, you can pause the recording and you can verify it. Okay. So I'm going to stop the recording here. I'll see you in the next section. Hi, welcome. In this particular section, I'm going to show you 2 examples. One example that how we can use policy in our VEdges, and here you can see that what is the policy that I'm going to configure inside my ACL. Let me highlight that with black color. So this rate I'm going to limit, and this is my buffer size. Let's see what's the policy configuration. And you can see the constructs are very simple. We can go inside policy, name of the policy. We can fix the rate and the burst. If it will exceed that burst limit, then packet will start dropping. That is our rule. And likewise, we can apply these policies to our service VPN interfaces. And important thing here that we can apply this in either in ingress direction or egress direction, either in or out. Okay, so let's see that how we can execute this policy. Let me open my device. Let me go to my VHS. In this case, I'm going to use my branch 1, VH1. And if I check my interfaces, what interfaces I have inside VPN 10, I have one interface Gigi 0/0. So let's create the policy. Policy. Then I can give policy and the name of the policy. Then I can fix a rate like this. I can use the burst. and then we can use the exceed. The exceed is drop or remark. So in this case, in our case, we can use drop, no problem. We can validate. Even if we want to check this, or if we want to view this configuration, we can type show configuration, and here it is. Once we are good, we can commit, and we can go to top. We can go to VPN 10 interface gig E0/0 because I have only one interface. Then I can use polisher and the name of the polisher. Now we have option, either I can use in or out. Again I can commit. Even if I can do commit and quit, I can check my policy like this. I can check my policy with filter like policy and polisher like this. We can check our policy like this as well, show run, and then what options we have here. You can see access list options. We have not many access list options, and then we have access list policy, so we can use this as well. Okay. So at the moment I haven't tagged any of my ACL with the policy, so I'm not able to see this, but if I want I can tag my ACL with the policy and then I can check it. So these are the various options that we can have to view our policy. Let us stop here because in the next section I'm going to show you the next example. So let's stop here. See you in the next recording. In this example, I'm going to show you that how we can redirect traffic from one link to other link, and this is very much similar to the Cisco policy or Cisco conditional policy maps. So the thing is, suppose this VH has to link with internet, and this particular interface has 30 Mbps of speed. What I want here, that I want to give 10 Mbps of speed, providing my high priority traffics. If my lower priority traffic exceed 20 Mbps, then it redirect to gig 0/1. Okay, so means what does it mean? Means 10 Mbps is sure, but if out of 30 Mbps, if the low priority traffic will exceed 20 Mbps, then it will redirect the traffic. And the thing here is that we are using this with certain service VPNs. So I'm going to monitor my service VPN, say VPN 1, that is the step number 1 here. So in VPN 1, I will use one ACL to just track my incoming traffic, and once it reaches to a certain threshold, that is 20 Mbps actually here, then we redirect the interface. Okay, so let's see how we can do this. And for this we need actually two type of policy. One, we want local policy on a local VH interface, and one data policy I want in VSmart. Okay, so let's do it in our interfaces, in our devices, and I'm going to use VH1, branch 1 VH1. Okay, so let's do that. I can use policy, and this time the policy name is something, say bursty traffic. I can use rate, that is 10, Mbps, that is the committed rate we have. And then I can burst up to 20 Mbps, and even we can check that. Oh, okay. So we can burst up to 20 Mbps. I thought it will show that here you have MB or kbps like that, but it's not like that. We can burst up to 20 MB, and if my traffic exceed, so this time we are not going to actually drop it, but we'll remark it. We'll mark this, and then we can redirect on the basis of this marking in our vSmart policy. Okay. So what I can do, I can exit from here. I can create access list now, and the access list name, I can give any logical name here. So I can use something, say policy bursty traffic, but you can give any logical name. Sequence 10. I want to match my source IP. And what is my source IP that I need to check? That is in gig 0/1 interface in VPN 10. I think gig 0/0 is our interface. So my source IP is something this. They need to use subnet, so use like this. This is my source IP, and that's okay. Now I have to set action on this. So action will be accept, okay, because I'm going to monitor this. And the policy, I have something called bursty traffic. I can exit from here. I can exit from here because I need to set the default action as well. Default action is also accept. Can I validate this? Yeah. I can go to top actually, and here I can check show configuration. This is my policy. Bursty traffic 10 Mbps, burst up to 20. Remark the bursty traffic with this particular source, and the action is obviously the calling of the policy inside the ACL. Now what I can do, I can go to VPN 10, my interface gig E00, and here I can use my access list, policy bursty traffic, that's the name, and I can apply it to the inward direction. I can commit and quit. So if everything is fine, the commit will successful. That is the part 1 of this implementation. Now I have to log to my vSmart controller. So let me open my vSmart controller, and from there I need to use one data policy. I'm inside my vSmart controller, and here I can create my policy. I need to define my list. So list is my site list, because I wanted to apply this on a particular branch with particular site ID, and here I can give any logical name. I am using the same that is there in the slides. So you can pause the slides, you can pause the recording, you can check the naming, but obviously you can use anything. So the highest priority routes, my site ID is for example 300, because VH1 branch 1 is in 300. After that I can create one more list, that is my VPN list, because WAN VPN, because I need to define my VPN as well. So I have two sides of my policy. One is the WAN interface where I'm going to apply this policy, apply this data policy. So that's okay. Then what I can do here, I can exit from here. So I have two lists. What I have done so far, I have one site ID 300 and I have one VPN 0. Now I can do one thing. I can create the data policy. I can give any name. So say highest priority, but you can give any name. Now here I can give the VPN list that just now we have created, and we can define the sequence. My sequence is something 10. I want to match packet loss priority, and that should be high, with the source IP we have. So I need to check my source IP here, and we have source IP 10.3.0.2 that just now I use it in my branch 1 VH1. So let me, yeah, this is my source IP. Okay, means this interface I am monitoring, and it's okay. We can do the action here actually. So action is accept. We can just check what other options we have. So we have options related to count as well. I can count, and you can see here we have a lot many other options here that we can set. And before moving further, let's see that what we have. So what I have done, policy, then site, then 100, VPN 0, highest policy, sequence 10. All these things I have done. I match the source IP, action is accept. Then I can use the counter as a bursty counter, and then I need to set the TLOC. Further I can apply the policy like this. Okay, so let's do all these things. Okay, let me go to my count, and here I can give any name. So just give something logical, bursty counter, like this. And here I can set the TLOC, and let me check what is the options I have. So I have option TLOC, I have option local TLOC, I have option local TLOC list. I can use, say for example, local TLOC color. Okay, so I can use this, and if you check the topology, you'll find the local TLOC color is actually red. So when the parameters are matching, then I am setting this criteria. I need to exit, I need to exit, I need to exit, because my default action is accept. And from here we can check the configuration, because we have done so many things here. You can see here I have highest priority data policy. In that, simply what I am doing, I am matching the service side VPN traffic or the subnet. The packet loss priority is high. Action I am accepting, but count I am fitting for the bursty traffic. I am setting the next hop. So if this condition will match, it will go to the next color, and that color is red with help of the local TLOC value. Okay. So once we are done, now obviously I can type top to go to the top. So from here we need to apply the policy to a certain site, and I have site name highest priority routes. Here I can use my data policy. My data policy name is highest priority, and from service side VPN. I can validate it. The device is being managed by vmanage. Okay, so I need to detach this device from the vmanage. Let's go to our vmanage template, and my vsmart is here. So I'm going to detach it. Pull this here, detach, and now if I do up arrow, validate. So before doing the commit, we can check the entire configuration. From top, I can check the configuration. This is my data policy, and this is my apply policy. Now I can commit this. Once the commit is completed, I can go to my branch. I can check show policy from vsmart, and now it is downloaded here from the vsmart, and now we have this output. Now we can check various options that we are not able to check initially. So I can check something like access list, then policy. Okay, that was one missing item in the last example. All these things that we can check now, there is no problem on verify all these things. This time we check the policy. Okay, so I'm good with this particular keyword section, and in this particular keyword section you can see that there are so many things that we can do in the legacy traditional WAN. Here we can do with some different methodology, but this method is actually quite effective because we can intervene all these things with help of the controllers as well, and obviously we have control to the vEdge devices as well. Those vEdge devices are our local devices in branches. Okay, so I'm good to close the queue section. I'll show you in the next recordings in the upcoming sections. See you till then. Okay.
So let's see. जो T-shoots है हमारे, today we are going to complete point number 1 to 5. 5 करेंगे. Tomorrow we'll do from 6 to 10. तो हाफ हाफ करके हम लोग कंप्लीट करेंगे 2 सेशन में. क्वेश्चन नंबर 1, bring up branch 2 via ZTP. ये जो है ना, this is the same that you have in the lab number 3, lab number 4. जो स्नैपशॉट आपने भेजा है ना, वो लैब इसमें कवर होगा पॉइंट नंबर 1 में. ठीक है,
नंबर फॉर ZTP प्रोसेस.
ZTP प्रोसेस, हाँ वो कवर करूंगा मैं अभी. So bring up branch 2 via ZTP. Make sure ZTP is working properly. Capture syslog over the screen. And fix the routing issue between two branches. They are not installing the route. So what this point is telling that, let me draw here the diagram. So this point is telling that you have your branches. In our lab topology, we have say branch 1 और हमारा है branch 2. In branch 1 we have two devices, branch 1 vEdge 1, branch 1 vEdge 2. Or branch 2 we have one vEdge device. then we have ISP, and then we have data center. So DC1 and DC2 ऐसा कुछ हम लोग का diagram. Okay, so we have DC1, VH1, VH2. Now what this point is telling that, first of all, bring up this device. This device is not up. Once you bring up this device, then in the data plane you will see that he is not forming all the IPsec tunnel. So you need to bring up the control and the data plane of branch number 2. Something like we are going to do complete troubleshooting for one of the branch, starting from ZTP to fix the routing issue or data plane and the control plane issue. That's the point number 1. Any doubt understanding the question, you can ask. Yep, if you have any doubt, please ask to understanding the question. Give me 1 second. Any problem understanding the question? If you have, please ask. If no, then we'll start. So if you go and log into branch number 2, we have out of band management login access to the device. So I can go to the device. Here you have your device branch 2 VH1. If you see the VPN 512 IP, this is the IP address. So this IP address, if you want, you can log in from your local system as well. So I'll do one thing. I'll go here and I'll add one new server whose IP address is this. This is branch 2 VH1 SSH. Okay. Now once you log into this device, if I go and do, let me first of all log in. And if you see show interface description, because this is the device where you have only out of band management, you don't have much configuration because this is the brand new device. Ship to the device, ship to the branch where the vbond IP is ztp.viptela.com. And if you go and see the VPN 0 interface, VPN 0 interface is shut down. Inside VPN 0 interface, it will use IP DHCP client, means it will get the IP from the ISP. So what you need to do here, that you have to go here and first of all we should do VPN 0 and no shut, means this interface, that is gig 01, you have to do no shut. But since the question it is telling that make sure capture the syslog over the screen. So what does it mean? That you go and enable the monitor start and then var and log vsyslog. Okay, this you have to start and then you do the process, rest of the thing. So we'll go here to conft and then VPN 0 interface gig e0/0, commit and quit. So once you do commit and quit, then what this interface will do, first of all it will take the IP. So it is taking the IP address. You can see it is taking IP this 164.4.2 from the ISP. Since it will take the IP address, first of all it will try to connect with the ztp.viptela.com. This is the server hosted in the cloud. Now once it will connect with this ztp.viptela.com, he will see that what is the serial number and chassis ID of this particular device who is sending the request. Then he will redirect this particular ZTP to his vBond server, that is nothing but vbond.cisco.com. Now when the device will communicate with the local vBond server, that is vbond.cisco.com, after that the vBond server will give the vmanage the serial number and a chassis ID, and the vBond will give the vmanage IP to the edge device. Okay, so once they will get, means once my vmanage is able to reach out to the edge device with the 00 IP. So if you go and check the show control connection, you can see it is using null IP address to do the communication either with the vBond or the vmanage. After that, what you have to do, that you have to go to the dashboard, and from here you need to push the configuration. So you have one template called branch type 2 template. You need to attach this particular configuration with this burnt in address, and then you have to, if you have those Excel, in our case we have the Excel file in the desktop, and branch type 2, you can see branch type 2, upload, next, and here now you can see the much more information. Now what it will do, it will try to communicate with the new IP that vmanage is pushing to the edge device. So now this device has the system IP, exact system IP, that is 10401, and this 10401 is nothing but the system IP of the device. Now this system IP, with this particular system IP, again this vEdge device will start communicating with the vBond and the vmanage. And now if you go and check show control connection, you will see that it will form the connection, and once the push of the configuration is successful, you will see that its name will get changed. So here you will see that still it is in progress. Once the, now you can see the name has been changed, and all the steps you can see that is happening behind the scene. And now if you see the control connection, you can see that it is forming the control connection. Now what I will do here, that I'll go and turn off the monitor. So I'll do monitor stop, and these are the messages that we have collected. Now if you go and check the control connection, so you have the control connection. So you have two vSmart, you have one vBond, one vmanage. Later we need to figure out that why he is not forming the control connection over the MPLS. I can see only internet. I can't see control connection over MPLS. We'll see that. And next, if you go and check show IPsec inbound connection, it has the IPsec tunnel, you can see, but it has the IPsec tunnel only with DC. You can see some of the devices don't have the IPsec connection with all the devices. So this is nothing but DC2. This is nothing but branch 1, vEdge 1. So you don't have full IPsec connectivity with all the devices in the network. That we need to figure out why it is not forming. So if we go and check the question here, question number 1, first portion we have completed. Second portion, fix the routing issue between the branch. It is not installing the route. And if you go here and check, you can see clearly the IPsec tunnel. Only 3 IPsec tunnel we have. We should have more IPsec tunnels. So what's the issue? Let's see. If I go and check the system configuration, we'll do First of all, we should check the configuration. System IP is correct, site ID is not correct. Control session PPS is 1. Allow same site tunnel. So there are so many things that is enabled in this particular device which should not be enabled. So what it is telling here, that some of the configurations is not up to the mark. So first of all, the branches, say branch number 1 having site ID 300 and branch number 2 should have site ID 400. So this is not correct. I should go and change this thing first, then allow same site tunnel. It should also not be there. If I have two devices and I'm allowing the same site tunnel, this is not the correct configuration. So that also I'll remove. Now if you see the question paper, what it is telling that all devices should be managed via vManage. So I can't go log into the CLI and I can change the parameters. I can't do 400 like that because it is managed by vManage. So I have to change this. I have to change this in the GUI itself. So let's go and do the edit. So I'll go here and I'll see this branch template. I want to edit system configuration. System DCloud branch 2 is the name. So I'll go to the feature and system DCloud. So I'll type here system. Let's see. Where is that template? System DCloud branch 2. I'll go here and I'll do the changes. So first of all, this site is 400. Then let's see other things. The control session policing rate is, I'll make this default, that is 300. Then allow same site tunnel, I'll make this off. Default is off. Update. We'll update this configuration. It is in progress. Now let's see the status. Show IPsec inbound connection. Inbound or outbound connection. So now I can see that even there is less number of IPsec. Even the data center is also gone. And let's see the control connection. So control connection, still it is over the internet and over the MPLS it is not there. So what we will do here, what should we do here? We should go and first of all check the interfaces. So your internet interface is up, your MPLS interface is also up. And now if you go and check the system and the other configuration, let's see one by one. Still control session PPS is 1. This is one of the protection mechanism, and I have changed that, but still it is showing that I don't know, maybe it is not changed to get changed. Let me go back to the feature one more time. System and what is this? Let's see the branch, this one. I think. Let's see. Control connection, allow same site is off, and control connection policing is 300. So that's okay. It should, this is okay actually. If I go back, still why it is showing 1? It should not show 1 here. Or maybe I am using, still the site ID is 300. So maybe I am using the wrong template. So let's go and verify one more time. This I am using here. Oh, this is out of sync now. That's the problem. So we have changed the template, but it is showing out of sync. It is not attached. After doing the change, it is not communicating. So what you can do in these cases, and suppose if you have time constraint and customer want quick solution, your site is down or you're seeing out of sync here, the quick way to do this, that you create one copy. What I have done, I have created one copy called 1, and then attach your branch 2 with this. So here you can't see the branch 2. Never mind, go here and quickly detach this, because anyways this is out of sync. It's not in use. So we'll go back, and here we'll go and attach branch type 2. You can't see the branch type 2. It's still the, oh, here it is in the bottom. Well, wait, we should give them some time because it's not that fast. If you want to see the config difference, so here you will see the system wide configuration. I think it is okay. You can see failure. It is failing because we are not giving him much time to detach and attach. So first of all we should detach from here, and we'll wait. Now we'll see that we are getting some issue, that even I try to detach but it is not detaching, and when I try to attach, even the attach, it's not working as it is. Let's try one more time. You can see this validation. If it is successful, then it's okay. Otherwise it will throw an error and it will tell from vManage you don't have route, you don't have reachability, you can't manage whether we manage. And we should see the log messages here. Generating configuration from the template, checking the device, checking and creating devices in vManage. We'll wait. It is in progress. And while we are waiting, if I go here to the configuration and if I type show run system, still this is 1, is still this is 400. That means it has not pushed. So we should wait. You can see this much time it is taking, and everyone will be on call and they will eat your head. What is happening? Why it is down? Why I am not able to send the traffic from one place to other place? RUIs, no SD-WAN, those things you will heard. So still it is 400. So still it is not sending the message to the. So what it is telling, configuration template, this one scheduled to be attached when device comes online. So from my vManage, actually the vManage is not able to reach to the device. So it is telling that to go to the configuration devices, device option, and check that. So if you go to the configuration and devices, and you have your device here. Now you can see that you can go and check the running configuration local, delete VH copy. If you delete that VH, again major escalation will happen. So delete and decommission, do not do that. Change device values, that is one of the things that we can try to change the device value. Template log, device bring up, these are again the logging type of thing, but to change the parameters I can do these things. Alright, so we'll see show control connection. Still I can see that I am able to reach from vManage because the control connection is on up, but still if I go and check show IPsec inbound connection, I can reach one of the data center, that is the data center 2. Why this problem is happening? Because I have given one control plane policing option is 1, and if I go and check other configuration like show and OMP, OMP is no shutdown and rest of the things are correct. Show and VPN 0, that is the most important things that we are checking. You should check the VPN 0. Oops. You should go and check the VPN 0. You should go and check the OMP. Those are the correct. And due to the configuration that we have done, my vManage is not able to communicate with the VS device. And since he is not able to communicate, he is unable to send the instruction. Okay, so our host name is this one. It is not taking the host name. Whatever things that I am able to change here, only these values. But I want to do some changes in the configuration that I am not able to do. So now everything is in sync actually. Now it is working with this particular template. You can see this, the bottom template. And if we go and check the system configuration, so do not trust on the other stuffs. System DCloud branch 2. If you go and check this particular template, let's see the variables inside this. So here, so you can see site ID is 400, I already put, and the PPS is 300, so that is correct. If you go here and check show run system, so still it is showing the site ID as a 300 PPS one. So you can see the problem. This problem you see here, that if you go here to the template, that the vManage is telling, oh, I have attached, you can see the attached device. I have attached this device whose IP is 10401. vManage is doing the configuration with respect to template. So as an admin, what I will think, oh, my vManage configuration is there, But if you go check the vManage, so if you go back here and if you go to the devices, if you go here and if you click the running configuration, whatever in the device, let us wait, it is generating that. So you can see that via the template what configuration I am putting, it is not syncing the configuration whatever there is in the CLI, because via the template we have the site ID 400, but in the CLI the site ID it is showing 300, correct? So you are seeing the live problem. This is one of the live issue we have. Here it is showing 300, and here even he is not able to generate the configuration because of the control plane issue. Suppose if someone will do some sort of DOS attack in the control plane, your devices will not able, your vManage will not able to reach to the device, and since he is not able to reach to the device, you can't send the instructions, correct? So in this case, what are the things that you can do? First of all, you try to do like this, try to detach this from the vManage. Again, it will take some time, but if the detach is successful, then what you will do, detach this device from the vManage, try to restore the configuration from the CLI, and then correct the template and then attach the template with the edge device. Okay, so now it is, the detachment is in progress, and now if I go here and if I go here and type system and the site ID is 400 and the control session PPS, control session PPS is a, you can see what's the default, it's 300 packet per second, and commit. So it is not allowing you to commit because the packet per second is very slow, and it will do its work but it will take some time. Alright, so far if you have any question you can ask. Failure because he is not able to reach out. It's a very weird situation that you can't do anything. You're managing the device from the vManage, and your vManage is not able to reach to your VS device. Neither you can do the local configuration change, neither you can do the change from the vManage. You can't do anything. That's a big problem you have. Okay, so what we can do, what would be the other solution? This is one of the way we should try to restore while detaching, and then change the configuration and restore the configuration. That's the first way. The second way that we can go here and you can go to the devices. I think I don't have that option. See here also, if you go here and update to CLI mode device, so there also you don't have option. What we can do here from the configuration and the devices, that that's the last option you have, that you can decommission and then you do the provisioning. That's again not recommended way, but this is the last thing that you are doing. Alright, so let's see if it is successful. Still it is, I don't have access to do any change. So although it is showing in sync, correct? Let's do last try and then we'll do decommission and then we'll try to provision again. Okay, so let's try detach one more time. We'll wait for 30 seconds. If this method will not work, then we will remove and try to connect one more time. So it is telling changing device configuration mode to CLI. It is in progress. There. This way we are not able to restore. Now we'll go and check the other method. So we'll go to the configuration and the devices. And here we have option to delete the VH, to decommission the VH. Delete means simply I'll delete this device from the list. Decommission means this will invalidate the VeloCloud device. You cannot undo this action. So if I do the decommission, I can't do the undo. You cannot undo this section. Both the sections, I can't do the undo. So what I'll do, I will go for decommission. Device successfully decommissioned. Device is, you can see, it's gone. Now if I go here and because I have out of band management access, this device is doing manage the VNA configuration to this is overwritten. See now what message it is coming. Any configuration changes to this device will be overwritten by the vmanage after control connection to the vmanage comes back up. Yes. All right. If I go and check show run system, now it is 400. Allow same site tunnel is still there. I don't want that. System, I'll go to system first and then no allow commit. Yes. What it is telling, then when you attach this with the vmanage will push those configuration. Show control connection. At the moment I don't have control connection, and so IPsec I don't have the inbound. So what I'll do, that I'll go and push the configuration again. Before pushing the configuration, 100% confirm that the template that you are pushing it's correct. So I have one other template as well, that is branch type 2 template. Okay, let's see this template. First of all, edit, and system view template. Let's see. So site ID is 400, you can see. System IP is okay. Controller overlay, those are the correct. Then control connect 300, the PPS is 300, that's okay. And the allow same site tunnel is off. Alright, so those things are 100% correct. Now let's go and attach this. Attach the device. This is the serial number and token, and again we should update the branch type to template. Upload. Next. We'll wait. Show control connection. If everything is correct, it should come. And then show interface description. Let's see the interfaces. So first of all, the control connection should come, and then the data plane will come. So first of all, we should check the control connection. We'll wait. Device is offline. Wow. So now the device is not validating from the vmanage. And if I go here and template, so you can see these are the problems we have. So vmanage is showing that one template is attached, and if I go here to the devices, now there is some certification issue that is happening here. That happened actually after decommissioning. If you go and check the running configuration, it's error. It's not generating that. So what you need to do now, that you need to do the bootstrap. You need to go and authenticate this device, and you have to do it manually, this token generation and all. It is still trying with vmanage, and if it will get the certificate, because its OTP has been expired from the ZTP. You can see these many things we have. So let me try to restore once, and if I go back here, paste this configuration. See, this is the complete configuration. The only problem here related to the certification now we have. So if you see the cloud init file, this is the OTP that will be used by the ZTP server. This is the VBond, this is the UUID, this is the correct thing. And then you have the configuration in the cloud init file. If this will not get authenticated, it will not work. So how we can do this? Let's try to figure out. Although behind the scene it is try to authenticate, but it is not able to authenticate. So let's do one thing. I'll go and log into the ZTP server. Let's try to do this. 198.181.13 is the ZTP server. Let's log into this. Admin and admin. Show. Let's see what are the ZTP he has.
Hello.
ZTP. Yes.
I'm not able to access that link.
So we have the ZTP server here in the back, and not only the ZTP server, but whenever you have the V-Edge device like this, which is not doing the authentication after decommission, you have generated some sort of OTP and all. So in that case, you can go and re-authenticate that, correct? So what you can do for the re-authentication, let's see if we get some good document. Say ZTP reauth if we have. The other ZTP we have discussed earlier, and where it is going. I think, let's see, the reauth process is there that we can do. Let me see that what is that. That is, I think, request. So let's see this this way. Request and VeloCloud, that's the last option, and activate. See token number, and we have the token number from this OTP is nothing but the token. The new token that the vManage has generated. And the chassis number if we have. So let's see if we have a chassis. We don't have chassis number here. Oh, chassis number here, it's this one, you can see. But this is your UUID. All the servers, they have the UUID, unique identification number. So this is the way that we can give the next time OTP, because whenever the cloud init will work, they will generate only one time password. This is actually OTP. Now you can see CER happen here, CSR generated. You can see, you have seen the flip. Initially it was in cloud init. Now you can see the name has been changed because we have successfully done the authentication. Now if you go and check show control connection, it should show you this device got authenticated from the vManage. It may take some time, but it's okay. Now you can see the certificate sign. See, all three things I have shown you. Initially it was cloud, then CER, and then the certified. Now this has been certified, and that means we have restored the configuration. And now if you go and check show IPsec inbound connection, you have the inbound connection with DC2 with branch and the DC. Still one of the data center is down because some problem with the data center. We'll go log in and we'll see. But you can see that you have successfully restored the configuration. Okay, so if you have any question, this was the ticket number 1. Oh my god, where is that? So we have completed ticket number 1. Oh my god, I can't complete more than 2 tickets, so I'll complete ticket number 2 and then we'll stop. If you have any question on this, please ask. If no, then I'll go and the OMP peers are down in data center. So if I go to the data center, I should go and log into all the data center devices. DC1, oh sorry, this is CH. I should go and log into the, oh this is VH, so DC1 and DC1 VH, DC2 VH, and DC1 and DC2 devices. This will be easy because if OMP is down, then you know that what you need to do. You should go and check OMP only, correct? or maybe this will take some time. Let's see what's the exact issue. So DC1VH, if you go and check show run OMP, OMP shut down. Someone has done the OMP shutdown. This here also OMP is shut down. Here it is no shutdown. That's okay, good. And it's stuck. So OMP is down, and the question itself says that whatever you are doing, you please do via the template. So you are not allowed to do anything via the CLI. Although if you want to do via CLI, do with the CLI, restore the configuration, again attach back. So DC1 OMP is down, so I'll go here and click the template, and I'll go and verify the OMP template. So I'll go here and this is the template, OMP dcloud feature T-shoot. That's the name of the template, and the shutdown is no, that is no shutdown. It is showing no shutdown actually. Shutdown, no, that means no shutdown. So let's see one more time that the templates that is down, it's related to DC1 only, and what template I am seeing here, that should also be DC1. So first of all, you should go and check attached devices. Oops, sorry. List of the attached devices. Show attached devices. DC1, DC1. All right. So DC1, it is showing that OMP is shut down. That means I should go to the OMP template. So we'll go here and we'll see OMP. So I can see that OMP is there. I'll go and edit. OMP should be no shutdown. Shutdown is yes, yeah. So should be no shutdown. Date. Alright. So it is working. Let's see that OMP is still shut down. Once this will push the configuration, then we'll see the status. In the meanwhile, I was not able to log into DC. Okay, I was able to log in. Show run OMP. It is no shutdown. This is okay. This is also okay. Here I have shut down timers, so many issues. So what I can do here, that whatever DC2 is using, the same template I can go and use. Now it is no shutdown, means if you go and check show OMP peer, so you have to be smart now. Uptime is 38 seconds. Just now it will come back online. If you go here and check show OMP peer, oh, one is init in group or something. One is up from last 3 hours. We'll see that why this status I have from the vSmart. We'll verify this data center, but they're showing this status. But before doing anything, I will go and check branch 2. Now you can see the branch 2 has restored. So branch 2 has the IPsec connection with DC1, DC2, DC1, DC2 over MPLS over internet. So ticket number 1 actually is successful. Ticket number 2 is also successful, but is still we'll see later on that there are some changes. There is some problem in this. We need to check. So here it is okay, but if I go here and if I press arrow, you can see init in group. So he is not able to form the complete OMP peer relationship with the VS Smart 2. Why? We'll check later on. This is okay. This is also okay. Alright, so according to that, the first prerequisite for this particular T-Shoot lab is this, that all the devices should be managed via the vManage. Means once we complete point number 1 to 9, because 10 is different. So once we complete point number 1 to 9, at that time, after say point 1 to 9, all devices should be managed via vManage, means they should be in the vManage mode. So yesterday we bring up one of the branch. We have seen there are so many issues. vManage was not able to push the configuration. Then we have seen the device got decommissioned. Then we generated the OTP. Again, we re-authenticated the device. We have captured the logs over the screen as per the request in the question or scenario. And then we fix the ZTP. After fixing the ZTP, we'll found that is still they are not building the control plane and the data plane. Then we fix the control and the data plane issues. Then branch number 2. So if I go back to branch number 2.
Yeah, can you set the topology again? How is the network now, lab network?
Alright, I'll show here in the screen. 1 second. One second, I'm opening the lab topology. 1 second. Where is the diagram? Yep. So
Hello, sir.
yeah, Shahid.
Are you recording the session?
Yeah. Alright, so here you can see the diagram. This is the lab topology. We have two data center, DC1 and DC2. We have two branches, branch 1 and branch 2. And then we have VPN 10, VPN 20, and VPN 40. So first of all, in ticket number 1, this particular site was down. We have done the ZTP, but while doing the ZTP, we found some issues. So we have done all the troubleshooting, and now this device is up and running. If I go to branch number 2, let me log into branch number 2. Branch 2 VH1. I'll mute Varun. Alright, so here if you go and see show IPsec inbound connection. So now all the IPsec, they are up and running. By default, they will work as a full mesh. So the ticket number 1 yesterday we have completed. Then we have completed ticket number 2 as well. The OMP peers are down in the data center. So if you go to data center, let me re-log in to all the data center devices. I'll go to DC1, VH1 and DC2, VH1 and 2. Let me log into all the devices one by one. And all right, so here if you go and check show OMP peer, should see 2 peers. So OMP was down, and for DC2 VH1 still one OMP is down. We'll see that why it is down. We'll do the troubleshooting further. Show OMP peer. So for all the data center, OMP is up. Only for data center 2 VH1. So I'll mark here that for this particular OMP is still down. Okay, we'll see that why OMP is down for this particular device. Let's see now. So for this device, data center 2 VH1, OMP is still down. So how we can troubleshoot? What you will check first? Yep, any answer? Obviously, we'll see the configuration.
You have to
Yep.
OMP advertise or something is configured or not, other end.
Other end configuration we'll see. Okay, we'll see that. So if you go and check the OMP configuration, here you can see, oh, controller group list is configured. So what you can do in the SD-WAN troubleshooting, first of all, we should go and check the show control connection. So if I see the control connection, I can see that clearly that
So,
VSmart and MPLS, and
that
so I
live
can,
internet. Okay, internet only.
yeah. So I can reach both the transport is working, but I am unable to reach to one of the VSmart, because you can see one VSmart IP is 12.12, other VSmart IP should be 22.22.22. So same type of branch I will log in, that is DC2 VH2, and here also I will run the same command, show control connection. Now here I can see this 12 and 22. It's quite strange that we don't have redundant connectivity, correct? We have only one connection. We should have 4 connection here, but we have only. Okay, next what you will do? And let me do one
You
thing.
have to
Let me
also check VRRP also you are told, right? To check if
VRRP.
OMP is down.
I will check here. Let's see here also. Here also I can see only 1, 2. So number of control pin connections are less. That means some issue is there. VRRP is related to local connectivity. Now here the issue that we have, this issue is something related to control connection. Control connection means that connection that is going from VPN 0 to the ISP.
Okay.
So I say, for example, I have only one VH inside data center, and I have two ISP. I have VS1 and VS2. So with one of the ISP I can see that I have connectivity, but other ISP I don't have connectivity. But again, this is not the case here. You will see that here we have a very different type of issue. So if I go to this particular branch, DC2 VH2, here you can see that one connection is going to VS1, one connection is going to VS2.
Going to 22.
But if you go here,
one is through MPLS, other through internet.
But if you go here, you can see both connections are going to one BS. So both the issues are different actually. This issue and this issue is different. All right, so that means first of all what we can figure out here that means some issue related to VPN 0 configuration, because this is related to connectivity via over VPN 0 on top of ISP, and then it is going to the control plane. It is in our lab there is no issue with ISP. So from ISP side everything is okay. ISP told that okay. From my side it's okay. You check your configuration, you check from your side, either your interface is down or any other things. So now it is confirmed that there is no issue from the MPLS or internet service provider. We have to go and check all the configurations one by one. Now while checking this configuration, one thing is clear here in our case, that everything is managed via vManage. So that means if you see the template for, say for example, we'll focus to DC2. So if we go and check the DC2, if I go here to DCVH template, here you can see DCVH's template I am checking. Here you can see that same template is attached with two of the VH. That means same type of configuration I am pushing to two devices, this device and this device. So they should have same type of issue, not different issue. But here you can see that they have different issue.
The route also can impact, is it? Check OMP routes.
OMP routes. So as long as we have reachability to one of the control plane, so there is no
Control plane.
Yeah, there is no effect in the control plane routing and all those things. Everything will work. But we don't have redundancy in this case. Suppose if VS1 is gone, that means this he will lose the control plane. So that's the problem we have. Okay. Anyway, so let's go and what we are going to check here. So we know that we should check the ISP connectivity and some sort of limit in the hardware. Suppose if I am here in one of the DC over VPN 0, I have, this is my VPN 0. I have two interface, one is going to MPLS, one is going to internet. So I will go and check the configuration to these interfaces one by one. So let's try to restore the configuration of branch number 1, on DC2. First of all, we'll try to do DC2 both the devices, and then we'll check the DC1. Now if I go here and do show control connection, we'll see in this particular scenario, in this particular case, our VSmart is mapped with the group ID. VSmart is mapped with the group IDs, you can see. So VSmart 2 having group ID 2, VSmart 1 having group ID 1. Now if you go and check the, first of all, interface and the description, what are the interfaces you have inside VPN 0? So we have interface gigi 0/1 and 0/2. Now gigi 0/1, you can see there is no configuration related to controllers. And if I go to 2, so many things are there. So what it is telling that control connection is, max control connection is 1. Exclude controller group list. So it is excluding, it is limiting, and it is preferring the vManage. So these things are there over this particular interface that I don't want. Likewise, I'll go here and check this configuration as well. VPN 0. Let's see the VPN 0 configuration. Show run VPN 0. So here also I can see the other interface, that is the internet interface, where we have some limit over the interface, and that's the reason that they are not forming the control connection properly. So first of all, what I will do here, I'll go to the DC2. This is the DC2 devices. I'll go here and check the template for VPN 0 interface. So we'll open this and we'll go to VPN 0. Here you can see you have internet T-lock, you have MPLS T-lock. So let's see first of all internet T-lock. First of all, let's try to identify in the template how it is, and then we'll correct it. So if I go here down bottom, you can see exclude controller is 1, vmanage is 7, maximum control connection is 1. So what I will do here, I'll go back to the feature, and inside the feature, we'll wait, it's a bit slow. We'll wait for the connectivity. I have RDP session as well. If I want some faster access, I can do from RDP as well. Okay. I'll do one thing, I'll go to the template and we'll go to the feature. How you can search? Go to the search box and type T-lock because you want to search the feature template. So I will go and type T-lock, search the T-lock, simply type and enter. You have internet T-lock here. Then here what you can do that you can go click edit. It's coming up, it's slow but it will come. Now we'll go and correct that. So as per company policy, whatever values you want, you should put that. For the internet facing interface, DC2VH1 and DC2VH2. Yes, I want to push this configuration to 2 of the devices. And now if I go here and check the configuration, so after it will push the configuration, this 117 will gone because we are changing these values. Sorry for that. We are changing these values from this place. So it will take some time to update the data. Once it will update the data, then if you go and check the show control connection, you'll find most of the control connection will come back, or we'll see still if we have issue, again we'll go and check that it is working or not. Since it is gone now, I can see some more number of connection try to get established, but we'll wait for some time. Here we'll go and first of all we'll check the configuration. Now it is gone, and check the control connection. So here I can see now 12. I can see only 12. We should see 12 and 22 as a VBond. So after doing the improvement, still I can see that 22 is not coming into the picture. So if 22 will not come into the picture, that means if I do show OMP peer, you'll see only one peer. But our goal is that we should see 2 peers. So here it is showing 2 peers, and control connection should be, so you can see it's very strange, correct? Your peer is showing 2 and your control connection is showing only 1. Great. So we'll do one thing. We'll clear the OMP peer. Let's force to clear the OMP PS. And let's see. Init in group. So we'll give some time, no problem here. So what we have done, you can see here that after doing one of the change, still we can see that the data center that we have, DC devices 2VH, still they are not able to form the relation with 12 and 22, correct? Although we have corrected the configuration over the VPN 0. So we check with the ISP. So our checklist, we check with
There was one more restriction on the VPN 0 interface, right? There is one more command was there.
Okay, so we'll go and check the configuration of VPN 0. For example, show run VPN 0. Let's see. So here you'll see VPN 0 configuration.
The second one, color internet restrict something is there. That is not
color
part
internet
of
restrict. Yeah. So here we can see that we have this restrict option. What this restrict will do?
Maybe towards this internet it will not create the tunnel.
Yeah, restricts means that if you have MPLS and internet, so if other side also you have MPLS, it will form the tunnel, and other side if you have internet, it will form the tunnel. So restrict means MPLS will not form the tunnel with internet,
Internet. Okay.
and internet with MPLS, but MPLS, restrict means same color tunnel.
Okay. Okay.
So this is the thing here. All right. That also I will check later on, but it should form, correct? It should form the connection with 22, 22, 22 as well. All right. So in our checklist, what are the things we have checked? We checked that ISP. So we have checklist. We check with the ISP. L1 team had checked with the ISP. They told, okay, there is no issue with the ISP side. Then we check the VPN 0 status, like show interface VPN and what is the physical status of the interface. And then we have checked the configuration of the interface. Then if you like, you should check the CPU and memory as well. Sometimes we are checking, you check the logs as well if you have any log. So we have checked all these things. Still we'll find that with VS2, the edge device, they are not able to form the control plane connection, or they are not able to form the OMP peer. So now what we'll do, we should log into these devices and we'll see that have we put any restriction on VS1 and VS2. So I will do that also, but before that I'll make sure that in my device I have checked everything. Now if you see here, we have one configuration, controller group list on this device, and if I go here, show run system, here also I have controller group list. Now if I go and check show run VPN 0, so only two things you need to check. You have to check the system wide configuration and you have to check the VPN configuration. That's it. Show run VPN 0. So we have corrected those things. And next what I will do, I'll go and remove the controller preference that is there in the system wide configuration, and then further we'll do the troubleshooting. So I'll go here to the edit section. Let's see where is that controller configuration. It should be there in the systemd cloud view template, because that is the system-wide configuration. So we'll go and check the configuration. Somewhere you will find some controller group 1. So I'll go back and system-D-Cloud feature. I'll remove that and I'll make that as a default. System-D-Cloud. So we'll do this thing, system. You search with system. And I have this T-shoot. I can go and edit this. If you edit in the bottom, you make this also as a default. And we'll go next. Next, both the devices. Okay. It's working. So now we'll go and check the control connection one more time. I should see 22 here. So it is in progress. While it is booting up or while it is pushing the configuration, let me log into VS1 and VS2, the control plane devices. All right, and go back. You can see 22 just it is coming. Show control connection. 39 seconds is the uptime. OMP pair is 48 seconds. We'll see the control connection. You can see 12 and 22. So now inside data center number 2, we can see that I can reach to both the control plane. Let's go and quickly check DC1. Oops, sorry. Show control connections 12 and 22, MPLS and internet. And here 12 and 22. Yes, now it is okay. So they are able to reach to all the control plane devices. It's done. Yeah, you have any question you can ask?
So what did you do? The default configuration, what was there? You just overwritten that, or?
Yeah. So what we have done that by default, there are some default configurations. So let me show you what does it mean by default configuration. There are two types of system configuration we have related to control plane device. One is the system-wide configuration. So if you go to the system and if you go to the control, you can see controller group list. So what we can do that certain number of VS devices we can map with certain number of group of VS Smart. Suppose if you don't want to do that, then leave those things default. If you leave those things default, then automatically it will form the control plane connection with the VS Smart. Okay, so those things I have removed, and now we can see that we can pair with both the VS Smart. All right, so let's move to the point number 3. It's actually a big. It's one type of scenario. What it is telling that branch 1 route prefer DC1, fall back to DC2. Branch 2 route prefer DC2 and fall back to DC1. So what does it mean? That you have two branches. Here you can see in the diagram, you have two branches. So branch number 1, it should prefer to DC1. And if DC1 is unavailable, it will go to DC2. That means this is the primary and this is the backup. From branch 2 perspective, this is the primary and this is the backup, just a vice versa, reverse of branch 1. That means they are working as a primary. This is primary for him, this is primary for him. Now to do this, how we can do this thing? This is not a troubleshooting, but this is a requirement that company told that you set up your infra in a way that DC1 and DC2 are primary and secondary. And this can be one of very good interview question as well. So in interview, they can ask you that how you can prefer one over other. All right. So for this, obviously, we need to go and create the policy. Please mute from your side. Otherwise,
Sir,
when you
please
get
stay
the
on mute.
recording, then you will. Yes, Varun. Yeah. You're asking something?
Sir, I'm telling that some voice is coming in between.
All right.
I
Okay.
have not muted.
Yes, he has muted. Okay. Yeah. No problem. All right. So we are going to create one type of control policy, and in that control policy, what you can do in the control policy, I'll write here first so you'll understand. I have, say, DC1. I'll match the route of DC1 with some higher preference value, say for example 200, and then I will match the route of DC2 with the preference value of, for example, 100, and then I'll apply this rule to branch 1. So if you do this, that means he will prefer DC1 first because the higher is better, and then it will prefer DC2 in the same rule. Same thing I will do with branch 2. Okay, so let me create the policy, then you'll understand more about that. So we'll go here and click add control policy because this is a routing related policy. So you need first of all list related to DC1, DC2, branch 1, branch 2. Okay, so I'll show you that while creating the policy also you can create the list. Now I want to create a control policy, custom route and control policy. This is, say, for example, say prefer DC1 backup DC2 for branch 1, like that is the name, and I will put the name in the description as well. Prefer DC1 backup DC2 for branch 1. Now we'll go and add the route sequence. What you want to match? I want to match the route. So first of all, we'll match the, say I have option match the site, match the origin, etc. Match the site. Say if I scroll down, you can see you can create the site list as well. So I'll go and create here DC1. DC1 whose site ID is 100. Okay, and we'll go and put DC1. So I have DC1. Once I have the DC1, what I want to do, I want to take the action and I want to set the preference value of, say for example, 500. So what I am doing basically here, match the route of DC1 and then in the action statement, I am giving the action statement is that prefer that to 500, and then in the next statement what I will do, that I will prefer with some lower value. Okay, so I can save this, no problem. Then I will rename this to look better. Prefer DC1. Now what I will do, I'll create one more rule here. Either you can create here, so I can click plus, it will come in the bottom. Now what next? Scroll down, this time say DC2 whose site ID is 200. Same thing I'm going to do. So this time in the match condition, match the DC2. Okay, then take the action except set the preference value of less than 500. So for example 100. Now if you see the rule number 1, DC1 500, DC2 100. The default action, if you want, you can accept. So you have the rule here in your rule book. Save the control policy. This is one of the control policy I have created. Now I'll create one more. You can cheat as well. So you can import the same policy that you have created and then you can edit as well. So where is my policy? If it is here, it is not showing actually, but I can do that also. If you want to edit the policy, basically in troubleshooting scenarios you have to edit the policy, whatever existing policy you have. In this case I'll create one new policy, but I'll show you that how you can edit as well. Let me complete this task and then I'll do that. So in this case what I'm going to do, I'm going to create the policy for branch 2 where I want to prefer DC2 and backup DC1. So prefer DC2, backup DC1 for branch number 2. Just the reverse case for the other branch. Sequence. And this time match the site. This time I will match DC2 first. Then action for DC2, I am putting the preference value as 500. Save this. And then site DC1, we will put the action and we'll put that preference to 100. Then we'll go to the default, accept, save. So now I have two different control policy. You can see prefer DC1, prefer DC2 for branch 1 and branch 2. We'll go next. I don't have any data related things, so I can go next. Then DC failover, DC failover for the branches. Like that I can give a name. Now you can see your control policy name, you have to apply it. So this is obviously for branch number 2 in the outbound direction. If you have list, you can use it. If you don't have, you can create and apply. So here I don't think so I'll get the option to create the list. I think I should get, let me see. Yeah, no. Anyways, here you can see branch 1. So I'll use this. It's not branch 1, correct? It's a branch 2. You can see this is applied for branch 2. So we'll go and use here to branch number 2, and then for branch number 1, add it and add it. So we have 2 policies added like this, and before saving it, let's do the preview. So now we can understand the logic. For branch number 2, DC2 having higher preference value, and in the same rule, DC1 having less preference value. For branch 1, DC1 having high and DC2 having low. Save this policy, and you need to activate this policy. So before activating this policy, you can see my VS Smarts are not attached. Okay, so I'll attach those VS Smart later on or after doing all the troubleshooting. But still, if you want to push this configuration to the VS Smart, what we can do, that we'll go to the policy, DC failover policy. We will preview it. We'll use the CLI thing. I'll copy the complete CLI configuration. I'll go to VS Smart. Sorry for that. We'll go to conft. Paste that configuration. You should have same configuration to both of the devices. Oops. Yes, we should do commit, otherwise it will not committed. Should do commit and quit. Show run policy. This is the policy. Show run apply policies. But later on, what I will do, that I will use the template, because in question it is required everything should be managed by vManage. At the moment, for troubleshooting purpose, we have detached the template, but once completing the step number 9, I'll attach this with the vManage. So these devices are also managed by the vManage. Okay, so this was the task. If you have any doubt in this, please ask. All right. If you don't have any question, then we'll move to ticket number 4. Check the control connection, control plane and data plane, and fix it. Yep.
Ratnesh, can we check this fallback option? Like you can disconnect the connectivity between DC branch 1 and DC1 and DC, is it going through DC2 or not?
Let's go to branch number. All right, let's verify then. So we'll go here to branch number 2. Where is branch number 2? I think we have branch number 2. Branch number 2. Okay, I'll log into branch number 2. Let's see the routes. So as per our configuration, branch number 2 is preferred is DC2. Check the IP routes. You can see these are the DC2 prefixes. These are the DC2 prefixes. And some places I can see that 10.1 is also there. So let's see this table first. Leave this default route. These are the data center 2 routes. This is directly connected interface. So leave this also. This is coming for, this is own route 10.4. 10.10, then 198.1. So some of the routes I can see that like 10.1.20, it is coming from DC1, but most of the routes they are receiving via the data center 2. So let's see some of the prefix in data center 2. I'll go to data center 2. Let's see if I have any individual where I am logged in. 1 second. I'll do the testing. Yeah, we're in the correct place. I want DC2 VH1. We'll go to DC2 VH1 here, and we'll do show interface description. So any of the route, say for example VPN 10. This particular route 10.20.211 will go to branch number 2. Show IP route. Let's see about this particular route. It will take the prefix also, but in that case you have to put 0 here instead of the exact IP. So if you put 0 here, it will give you the detail. And the detail option. So it is getting this route from how it is getting this route. Let's see, because this is clearly the OMP route, that means coming via the VSmart. That's why the AD distance is 250. So for this particular route 10.2.0.0, because we have MPLS, we have internet, so we have 4 equal distance. It is learning like this. Now if I go to DC number 1 and check this route. So what we want to do here, I have 2 data center, I have 1 branch, I have 1 route here, we have actually 1 router here also, DCI router. So let's check the routes behind the data center, behind the DC2, this place. So if I shut down this connection, it should reach via this direction, because this is the backup. So let me go and check this DCI route. That will be important. Let me log into the DCI router. Sorry for that. We have the DCI as well, where you are. Okay, here it is not, but let me add that. DCI. DCI IP is how you can find the DCI IP. Say it is connected with DC2. So if I am doing anything wrong, I need DC2. Okay, let me close few of the. Yeah, this is correct. So I am concerned about this particular network, but let's see, I have one DC data center interconnect device as well connected with this device, and we don't have source TCP neighbor or something like that, so we can check that. So what I will do, I'll do this thing, show run VPN 10. I think it is connected with VPN 10. So VPN 10 interface IP is, what's the VPN 10 interface IP? Here you can see this is the VPN 10 interface IP. So if you go and check the diagram, I'll show the diagram. See this router we have here. This is a DCI router. This is in the same LAN. So if I log into this device, then I can test the failover. Okay, so I just want to log to this device. Alright, so how I can log in? Because the IP is /24. If it is /30, so I can know that okay, this is the IP. And I think that IP is 10.4.0.1, something is there. 10.20.1 is the IP, I think. Okay, let me try once. Better I'll try from here, from this location, so I'll get the IP. Okay, if I SSH, sorry for that, DC2VH1, let me log in there, come on, one second, it's slow. Yep. I put the password, it is coming. So let me try to log into the DC because we need that. And if you find slowness here, then you can use your local system. So SSH 10.2.0.1, I think this is the IP. I think it's logged DC2VH. Oh, this is logged to same, I think. Fortunately, I don't know the exact IP connected to this device. Okay, what you can do, say if this is a troubleshooting case and I don't know the IP that is connected with this device, what you will do? I know that in LAN I have one device, but I don't know the IP. What I can do? Just tell me. It's very simple. We can do show IP ARP, correct?
Yeah, yes, sir.
Alright, so you have so many IP. I'm actually focused only on VPN 10. Okay, so show ARP VPN 10. And so here you will see a good thing about Cisco and all that. Suppose if you have the MAC addresses and you can go to the Wireshark OIU. Generally we are using this method. So we can search what is the MAC address related to those devices. If it is a Cisco device, then you can put that MAC address. Say for example this 100. I'll go here and if I put find it, it's a VMware. So like that you can find. This is the one way to find the which vendor that particular device is. So I have these 5 IP. I know that this is self IP. This is the other vEdge IP. So I have these 3 different IP addresses. Okay. So I will try all these 3 IP addresses one by one. One of them is the DCI device. So what we can do here that gig 0/0. Let's see. I think this is the same. This is the same. Then I'll SSH to 21 and 100. I don't have access seems to 21. Some devices there. Let me try this 100 once. Okay, so I think the 21 is the device. Let me see if I have putty here. I'll try to log in with the putty. It is coming in the back. Paste. Telnet. Open. Connection refuse. Let me try once the SSH. I don't have access to seems this device. I don't have access to this device, but we'll think that how we can do the testing. So let me try to log into this device, maybe because one of the device I have actually access. So I'll try to log into this. For this I have to go to DC1 VS devices. So let's see. We'll go here and DC1 VH, say for example 2, DC1 VS2. This may be also connected with the VPN 10, and here we have plenty of interfaces. This is my interface, this is the other interface, and then here list of the devices. My god, so many devices are there. Now we need one of the IP, so maybe from here to here any of these IPs are the device that
We
I'm
can't find the neighbor option or something. It is if it is neighbor of some other device from that.
neighbor option of the device.
In the diagram, I think you have mentioned OSPF or something is configured on the LAN.
OSPF, yeah, you're correct actually. Yep. So what we can do here, we can go and check show IP OSPF, show OSPF neighbor. You're correct. So we can check with the OSPF neighbor because these devices we have the OSPF configured, and I think this is the OSPF peer I have. So if I go here and SSH to this IP, let me try once. 10.1.0.1. It's very strange because you will see that okay, we'll do that actually. So with the OSPF we'll get this information. I'll do this thing, show OSPF neighbor, and let's see if we have the detail option. So who are the OSPF neighbor? We have 3 neighbor, and if you go and check the diagram here, this is 198.18133 subnet. It's a very big subnet, and this is actually the other device. So what I'm telling here, if I go and do show IP, sorry, show interface description. This is my IP 212 and the other side device is 211. So I have this device, I have this device. I just want any of these IP, correct? So these IPs I have. One of the IP that we are using is this device. So let me open the CMD. If I go and show you the IP, just a minute, it's very slow. IP config. So we can see 198.181.133.36. Okay, this IP is behind the firewall. Sorry, behind the device, even in the firewall also, no problem. This IP I can ping from one of the branch, and then I can do the failover testing. I have one.
Yeah, it is there. Dot 36.21.
Yes, .36. So this is the same workstation that we logged in. So what we can do that from this PC, we can send the ping to these devices. Then I will reboot both these routers. If I reboot both these routers, then it should go in this direction because we have DCI connectivity, so it will go like this. Is this pattern will work? Yeah, this will work. So at least it will try to reach up to this point. If it will reach to this point, that means the traffic is diverted, correct? So let's do. I'll go here and check. We have one test PC as well, 10.30 something in the branch number 1. So if you go to the branch number 1, where is my branch number 1? Yep. 1 second. Let's see. Show R for VPN 10. I think in VPN 10 I have that RDP PC. I think this is the VIP IP. Maybe what's the IP? 21, correct, in the diagram? This is 21. Yeah. So 21 we have one remote desktop. I'll open from here. 21. Yes, let's try to connect. RDP is not enabled there. Alright, so I don't have access to this device, so I will do from here. Okay, I'll source interface the LAN interface. I'll do. So I'll go to branch number 1 and inside show run VPN 10. See that what interface you have. This is your LAN interface. So first of all, let me ping to the what is that IP? 198.133.36 VPN 10 count to source. First of all, we'll see that we are able to reach via the LAN interface or not. We are able to reach, correct? From the LAN interface, I am able to reach. So I'll increase the counters. So bigger number. Wow, this is much bigger than 1 more 0. Okay. Okay. Now I will reboot branch 1 devices. So I'll go here and devices. We have this option in the tools. We have operational command option. In DC1, we can go here and I think in the maintenance we have this device reboot option. This device is DC1 VH1, DC1 VH2 reboot. Alright, and we'll go here. So if it is successful, it will start dropping the packets first and then it will try to go via the data center 2. So we'll see this. And parallelly what I can do here, that I could check the DC1 devices. I should not have access to this. Sorry for that. It is in progress. Device will take 10 to 20 minutes before it come online. Okay, no problem. I'll re-initiate the pings because I'll do the trace route as well. Should do the trace route as well, so we'll understand that VPN 10 how it is going. It is going directly. You can see directly it is going via the DC1. So if we reboot that, it should try to attempt to go via the DC2. Still this is in progress because we are doing via the template. Otherwise I can go to the CLI and I can reboot it. Still it is reachable. Still devices are on. Reboot is done, but you have one device that is still reachable. DC1 reboot is done. I'll do one thing. Now it is rebooting. Okay. We'll wait for 2 minutes. Let's see. It is in progress. See, now it is trying to go via 1. That is the same data center. Because now he is thinking that 1 is up. So that's the thing that he has done with us. Let me go here and detach the template. DC1 template I want to detach. Because what the vmanage is doing, that one by one it is bringing down the device, but I want both the devices down at the same time. So attach devices, DC1, detach. Let me detach and do a CLI. Otherwise we can't see this output. Now it is trying. This is again DC1 only. Alright, let me do this thing. I am detaching the devices and then I will do the reboot in a single shot. Both the devices I'll reboot at a time. Should have both the devices here, DC1 and DC1 I have. Let's lose the connection. Okay, so let's reconnect DC1. DC1 and DC2. This is the same device. Okay, so I have DC2. Let's log into DC1 and I'll reboot via the CLI. DC2 is up. This device is up at the moment. Okay, this is also up. So here you can see let's see, let's do the reboot. Come on, it's very slow. Reboot now and reboot now. All right, and then he loses the connection, so it should try to go via the data center 2. Let's see in the routing table, do we have route via data center 2 or not? Show IP route /24. This particular route, I don't have route via DC2. I need one route. I need one prefix which can reachable via DC1 and DC2 both. Somewhere here, from here also it can reach, from here also it can reach. Okay, so then only we can do the testing for this, otherwise we can't test. For this particular prefix, I don't have route via DC2. So it will not reach anyways. Okay. Yeah, any doubt if you have? I need one route here which is common to DC1 and DC2. Okay, shall we move? We don't have actually route here, but I have gone through the process. You can check whatever steps that we follow. You can use that step. But we don't have any common route here, so it's difficult to do the testing for this case.
Okay.
All right, let's move on. Let's see the other use cases. Check the control and the control connection between the control plane, data plane, and fix it. So what this is telling that up to point number 4, we should have all the devices with the correct control plane and data plane. So if you start the lab and if you go to the dashboard, inside the dashboard, you should have all the control plane up. You should have all the data plane up. So generally what we are doing, if you go to monitor and network, so you should have 100% BFT, you should have 100% control connection. Those should be up and running. At the moment I can see the branch number 1 VS2 has 0 BFT. That is not good. The control, you can see the control is correct for all the devices. For all the edge devices, we have 2 VS Smart, means we have 4 ways to reach to VS Smart, and one path is for vManage. So this is okay. In branch 1 VH1 this is okay. In branch 2 VH1 is also okay. But I can see here that in DC1 all the data centers, they have only 8 BFT. Why? So my question here is that branch have 10 BFT, but data center has 8 BFT. Why? BFT means IPsec connection. Any reason? So that we need to restore. What I'm telling here, let me draw this diagram. That you have, sorry for that. Anyways, I'll draw here. You have DC1, you have DC2, you have branch 1, you have branch 2. You have 2 devices here, 2 here, 2 here and 1 here. You have 2 ISP connection, ISP1 and ISP2, say MPLS and internet. If you check only one device, say branch 1 VH1, how many IPsec connection he will form? So here you have 2 devices, say 1, 2, 3, 4. So 4 here, correct? And then 4 here, and then 2 here. Any doubt on this? 10. But if you see the data center is showing only 8 IPsec connection, because we have used the keyword called restrict. So if I go to any of the branch, let me log into any of the branch. I'll show you branch 1 VH1. This is branch 2, no problem. Let's see how many connections are there in branch 2. Branch 2 having 10 IPsec connection, correct? So if you go and check show run VPN 0, you'll find that he's also using restrict. He's also using restrict. They are using restrict keyword. So what I'm going to do now, that all the devices I'm going to use the restrict keyword, so they will not leak their IPsec connection. Before doing that, let's quickly go and see that any of the data center, why they have 8 only? Why they have 8? So I'll go to DC2 VH1 or 2. We'll go here, DC2 device, because DC1 we have rebooted, so it will come back. We'll go to DC2 VH1. We'll see that why it has 8 IPsec connection, why it don't have 10. Show IPsec inbound connection. See 1, 2, 3, 4, 5, 6, 7, 8. It has 8 connection, and if you see the IP addresses, we'll come to know with this system IP. So it has 2 with DC1, so 4 with DC1, and 2 with one of the, alright. So it clearly shows here that because one of the branch is 0, see, that's why there is some issue. So I should go and check branch 1 VH2. Some issue is there with branch 1 VH2. So if I go to branch 1 VH2, and we'll see the configuration branch 1 VH2, because there is some issue. You should see the system-wide configuration, the 5 mandatory thing, the system IP, site ID and vBond should be checked. Then we should go and check the OMP configuration. So I should go and check the OMP. See, OMP is shut down. Clearly it is showing the shutdown. Then after that I should go and check the VPN configuration. VPN is no shut, restrict is there, and alright. So it is clearly it is telling that your OMP is down, and since your OMP is shut down, manually shut down, or maybe some issue is there, that is it is shut down. So that's why it is down. So if I go to branch 1 VS2 and if I check the template, oh, this is the CLI. Great. So OMP should be no shutdown. Let's try to no shut and check. Alright, and now if we go to the dashboard, your dashboard should be clean. Clean in the sense that if you go to the monitor and network, 10. So now they have come back. Still branch 2 has 12. Wow. So branch 2, we'll see that why branch 2 has 12 and others have less. Because I think in branch 2 if we go branch 2 VH1, let's see, I think we are not using restrict keyword in branch 2. So branch 2 VH1. Alright. So let's go to branch 2 VH1. This is DC, this is DC. Branch 1. Branch 2 VH1. You see here the VPN configuration. Restrict is there. And restrict is here. Oh, it's very strange. You need to figure out. Let me refresh this dashboard once. You can see this branch to all the branches, they have 10 IPsec connection, but branch 2 alone having 12 IPsec connection. So how it is? Let's see why it is. If I go here and check show IPsec inbound connection, why it has 12? Should not have 12. It should have 10 only. DC1, DC2, branch 1, again DC, DC2, branch. So it has like 4 plus 4 plus 4. I think its number is correct. You have any doubt in this? This is the correct number? You please ask. I'll draw one more time.
Sir, restrict means what?
Yes. Varun, what you are asking?
Restrict means what?
Restrict means MPLS will form tunnel with MPLS. Internet will form
Okay.
only tunnel with internet.
Okay.
So now is the solution is correct actually. This guy, because here we have only one device. So he is forming 4 tunnel here, 4 tunnel here and 4 tunnel here. That's why we have 4 plus 4 plus 4, 12. But if you see any of the other device, because they are in the same site, they will not form tunnel with each other. So that's why he is forming 4 tunnel here, 4 here and 2 here. That's why the number here is 10. So he has 10 BFT and he has 12 BFT. Okay. Alright, let's see that where we have reached up to this point. So we have successfully completed point number 1, 2, 3 and 4. Let me quickly complete this VRRP because it's very easy. Where the VRRP in branch 1? Yes, Varun?
For VRRP,
Yeah,
VRRP, how much time it will take?
2 minutes.
Okay, okay.
So the question here is that VRRP not working in branch 1. Now VRRP theory is that if your OMP is down, your VRRP will also go down. If your OMP is up and running, VRRP will up and running. That is the one dependency with OMP. Other dependencies are also there. So if you go and check show VRRP, you'll see this is up. All the VRRP is up in branch 1 because we have bring up the control plane. Let's see what is the scenario here. Tab. Here also it is up and running. So there is no problem with the VRRP because if you see the VRRP configuration, if your OMP is down, your VRRP will go down. Or if you have any issue in the LAN, means two devices are connected with switch and you have VRRP. If any problem with the LAN interface, this interface, any physical issue or any routing issue in between two devices, VRRP will fail. But in our case, because we have successfully bring up the control and data plane, so the VRRP is up and running. Okay. Next, we have ticket number 6. This is also not a ticket, actually it will also take 2-3 minutes. OSPF route policy QoS issue. Check the local policy if any related issue per other device in branch 1. So it is telling that check the QoS and the OSPF issue in the branch number 1. What is happening in the production network generally that you have same type of configuration related to QoS to all the devices, same type of devices. So suppose if branch 2 is running same type of QoS configuration in the same type of device, those configuration you can copy from branch 2 to branch 1. So branch 1 QoS will also work properly. Next is the OSPF in branch number 1. So what you can do here, first of all, see in branch number 1, do you have OSPF or not? Because in branch 1 we don't have OSPF. OSPF in data centers and the branch 2. So I don't think so here we have the OSPF. I don't have OSPF in branch 1. So it's not issue with the OSPF. And then the next very important thing that we need to check is the QoS. So first of all, you can check the QoS policy. Same type of QoS, you should match the same QoS in all the devices if you have QoS issue. Now, how you will check you have QoS drop or not? You should go and check the interface where you have applied the QoS. So for example, for WAN QoS, I will go and check the interface and then the, not like this, show interface. Say, let me see if I have any queue related. Only one command is there in SD-WAN related to queue drops over the interface. Show interface queue. So if here if you have drops, you can see there is no drop. So you can go and check all the interfaces, and if you have QoS drop, then you can go and check why the QoS drop is there, and then you can alter the policy. Okay. So we don't have QoS drop, but your QoS configuration should be same in all the devices. Okay. So that was the point number 6. Let's quickly check this 7 also. It will also take 2-3 minutes. All traffic from branch 2 should prefer MPLS. This answer you have to tell me what I will do. How I can do this?
The same thing you had done, right? Preference.
Yeah. So without global policy. Yeah. So there is one command in the interface. If you go to the interface, branch 2. So if I go to branch number 2, where is branch 2? Here it is. I'll show you that command. If you go to VPN 0 interface, first of all we should know that where is the MPLS interface? What is the MPLS interface? MPLS interface is gig 0/1. This guy here. So VPN 0 interface gig 0/1. You go to the tunnel interface first, and then if you do encapsulation IPsec, then you will get the option for preference. If you give more preference, that's it. Then irrespective of two interface, it will prefer the traffic over the MPLS. Okay, this is the command. Right. Then we have point number 8. Advertise loopback 99 with IP this from DC to VES2. All the branches should. Varun, you have some work or something, or if I continue for 15-20 minutes, these tickets will complete. Okay, so we'll go to DC2 and simple command VPN and interface loopback 99, and then IP address 32 no shutdown. Okay, and we need to do commit and quit like ASR routers, Cisco ASR also we have to do this commit thing. Once we commit, we'll go and verify to branch number 1 and branch number 2. So where is the branch number 2? V1 VSmart branch 1 CH branch 3. I can't see branch number 2 here, but anyways I'll log in via I'll log into that also. Let's see first that particular route in branch number 1. So if I go here and type show IP route VPN 10 99 99 99 99, we are not getting it. We should get it. So we should get 99 route. Maybe some policy is there who is protecting this. Let's go back and see if I have any policy. Let me log into the VSmart. Show run policy. No policy is there. So we have created one route here, and this route should go to all the branches by default. That's the default behavior. If you go and check show OMP routes for VPN 10 99, it should go. We should have OMP routes and VPN and IP routes. It is not there. So let's see here in DC2 why he is not sending. We'll go and check one more time that 99 is there or not. You can see clearly that 99 is there. Now if you go and check show IPsec inbound connection, oops, seems this side is, this OMP is down. So you can see this control plane was down, that's why one of the site was not getting that route. Now you can see clearly that OMP route is there and this route is also there. This thing I want to verify in the branch 2 as well. So branch 2 I need to log in. Let me log into branch number 2 whose IP is 106 management IP. So display name I can give branch 2 VH1 and SSH. So you have branch 2 here. Let's try to log in. This is not deployed, so I'll leave it. This is not deployed. I'll do one thing. We'll do the same verification in DC1. So if I go to DC1, show control connection, everywhere you should get that route, that 99 route, correct? So if you go back here and copy this command, show IP route and VPN 10, you should get 99 here also. Show IPsec inbound connection. There is some other issue going on in all the devices. Any reason? Can anyone tell me why I am not receiving 99 routes here?
There also that OMP problem or something?
OMP problem. OMP is
No,
up
it's not
here.
that.
Some other issue
Tunnel we
is
can check
going on.
here. Tunnel is up or not?
Yeah, actually some other issue is going on. I have created this lab for other class. Some issue is there in the DC1 and DC2 devices. So if I fix that again, I have to create that issue. So I'll leave it as it is. But the agenda here for this lab is that you have the route here. This route will go to one of the branch here, but it will not go to the other branch. That's the agenda I have. Okay, so let's do that thing.
It's like one device on the branch, it will go in the same branch, another device it will not go, something like that.
Yeah, it is going to one of the branch, but it will not go to the other branch. So that's the ticket we have. Ticket is from DC to VS2. All the branches will receive 99 except branch 1. So in branch 1, all the routes will not receive the route.
Okay.
All right. So for that, we have to create the policy. What we can do here, that we can go to the configuration and policies. Wow, what is this? There's some different type of version is running for vManage. Okay, so how we are doing this, we'll go to policy and you can see define list is very different, correct? So we'll go and add the control policy. This is 17.1.1 block 99. Okay, then we'll create the rule related to routing. What you want to do, you want to match the site of of the DC2, and then match the prefix as well. So what prefix you have? So you have prefix that will create here, say prefix 99. So I have IP 99.99.90.99.99. So we'll put that /32. Rule is very straightforward. Match the data center with the prefix and then take the action to reject, but the default action is to accept. Then we'll apply this policy to the branch number 1. So now we'll save this policy. We'll go to the policy, assemble full policy. It's little bit different that what we have studied this display. What was that control policy? And what was that control policy that we have just now created? This is block 99, where you want to apply in the outward direction of branch number 1, but its CLI equivalence will show you the same. So now if I scroll down and if I click preview, you can see the CLI format. Match the route of DC2 with this prefix reject, everything except, and apply this to the branch to this branch number 1, that is 300, and apply in the outward direction. So what we need to do here, go click here, click activate. Now the vSmarts, they are not in the template mode, so we'll go and attach the vSmart to the template, otherwise we can't push the policy. Wow. If this issue happen, then you have to attach this one by one. Sometimes this will happen. Okay, you can attach one by one, it will work, no problem. I'll show you some other method also to do this. Suppose if everything you are doing via the CLI, then do one thing. You copy this CLI configuration completely. Copy this and then log into the vSmart 1 and vSmart 2. So I have vSmart 1, I have vSmart 2, and manually put this from the CLI. Again, this is not the recommended way, but sometimes we can do this also for some troubleshooting or some other purpose. Commit and quit. And commit and quit. So now if we go and verify the output for branch 1 VH1, it should not get the routes. You can see it is not getting the routes 99. Okay, so it's very straightforward and easy thing. Yesterday also we have done the same thing with some other IP. Just one example. This. Alright, let's move to the point number 2. This is little bit big. This point number 2 is little bit lengthy. To do this, we should understand that how TLOC extension work. Otherwise, it will become difficult to set this. So let's see. Now, if you go to branch 1, is this ticket is related to branch 1 and branch 2. So I'll delete, close other sites. Okay, branch number 1. Yeah, if you go to branch number 1, if you type show control connection, you can see you have equal number of internet and MPLS links. 2 and 2. 1 is for vManage, so we'll leave it. But physically they are not connected like this. Their physical connection is 1 because we are using the TLOC extension. So that's why it is showing like this. So before doing any change, any configuration, we should go and check, do we have TLOC extension configured? Yes, it is configured. Okay, so what is the question? Let's see. Question is telling that create the new set of TLOC extension with IP 33334444. So instead of whatever that is we are using here, instead of that you have to use the new IP set for the TLOC extension. Once you use that new IP set for TLOC extension, when you verify, then you should get the same type of output in terms of control connection. Okay, so let's do that. First of all, what we need to do in such type of cases, when we are getting configurational change, we should go to VPN 0 and take the backup of the connection. So where is the TLOC extension used? It is used in this private address space. This is for branch 1. So I'll go here to the notepad and here I have to use IP in the range of, as per question, 444, and here I have to use 333. Now this is not required because we are not doing any change with this. So you can see clearly in the TLOC extension, not only we are changing the configuration in the interface, but we are changing the configuration in the default route as well, or IP route as well, and that's very important. So this is the configuration for branch number 1. We'll go here. Wow, some error. Should go to VPN 0 and then we should configure it. Now one side is IP is different, other side IP is different, so obviously control connection will not show you full output. It will show you only physical connection because now it is broken. So sometimes if you go start troubleshooting, you'll find, oh, some issue is there, it is broken, partially working, etc. So we should check the configuration as well. Now this portion also will check the configuration and change the configuration. Show run VPN 0. So from here onwards, what we'll do, we'll create one other tab. This is branch number 2. This is 4.4.4.1. and instead here we are using 333. This is nothing but 3.3.3. Now whenever you are doing such type of changes, quite often we are getting changes in NAT rules, changes in ACL. So we have pre-configured from where we are doing the copy paste, etc. This is day-to-day operations. So you should verify both the configuration and where you have done the change. So you can use the notepad and you check both the both configurations side by side. I'll get the clear idea. So here it's 4442, here it's 4441, here it's 3333, here it's 3332, the gateway is 4441, 333. So almost mirror configuration we have. I'll go here and we'll go to VPN 0 and then push the configuration. Now if everything is correct, you should get all the internet link and everything correct. So let's do commit and quit. You start getting the internet connection because now your TLOC extension is working. Oops. Okay, so this is the way we have to do if you have any new requirement related to TLOC. Either in this example I have changed the IP, but this is one of the way that you can set the TLOC as well. So whatever IP you have, according to that, in our lab infrastructure as per our design, we have internet interface, TLOC extension interface, we have MPLS interface, TLOC extension. This 100% same configuration, only some of the services will change, IP will change, etc. Alright, so we have the last question, that is break the branch 1 VH2 from the SD-WAN and form BGP in between branch 1 and branch 1 VH1 and branch 1 VH2. Check the routes, create loopback 44 and advertise to DC1 or maybe DC2. So we have to create the BGP. At the moment, what type of diagram or topology we have? Let me draw here. So at the moment we have diagram like this. You have branch 1 VH1, we have TLOC extension. Just now we set the TLOC in between. So it is telling that break down this, break the OMP, and this is non-SD-WAN device. Make this non-SD-WAN, means you think like this is connected with one of the router, and then create the BGP relationship between this router and this router. Just to understand that how BGP work inside the, or how we can configure the BGP inside the edge devices. Okay, so what I'm going to do now, remember all these interfaces that you are seeing here, all these interfaces are in VPN 0, correct? All these interfaces are in VPN 0. VPN 0. So we need to break the VPN 0 from this device, but still I need one connectivity so I can form the BGP relationship. Alright, so let's do in branch number 1, if I do show interface description VPN 0, these are the interfaces I am going to break now. VPN 0 interface gig 0 / I can do like this, no interface gig E0/2. Okay, and that's it, I think. Then we'll see show run VPN 0. In this example, we are seeing that how we can delete the interfaces and configuration in the interfaces as well. I don't need this full configuration. So I'll do one thing, VPN 0, no interface gig is 0/1, and then again I'll go to gig is 0/1, IP address, say for example 4.4.4. I'll give 1 here. Commit and quit. Okay, so it is telling that IP route is already there, you can't delete this. So we'll do one thing, we'll do no IP route as well. These are the things that we need to take care. Show interface description VPN 0. So now you can see that one interface is gone. This interface is back to back connected, so that's why I have given this IP. Show run VPN 0 interface gig is 0/1. This IP should be /32, not /30, not 32. So I need to change this. I'll change later on. Show VPN, we'll do like this, show interface description VPN 0. Here I need to break everything. So what I want to do, VPN 0, no interface gig is 0/0, no interface gig is 0/1, no interface gig is 0/2, and no IP route and then I'll go to interface gig is 0/1 and the IP address is 4.4.4.2/30, no shutdown, commit and quit. Here I will go and change the IP. VPN 0 interface, oops, sorry for that. Interface is what interface we have? Interface is gig is 0. Let me go out, otherwise it will throw an error. VPN 0 interface gig e 0/1, IP address 4.4.4.1/30. Commit and quit. So after that we should ping 4.4.4.2 with the source of 4.4.4.1 with the count of 2. Sorry, what I have done here, it's a very straightforward thing, that we have two devices. This is the SD-WAN device, this is non-SD-WAN device, where IP is 4.4.4.0, this is .1, this is .2. Now I will form the eBGP relationship. So I'll do one thing, I will make this as a AS100 and I'll make this as a AS200, and then later on we'll see. First of all we'll create the neighbor relationship and then we'll add something on top of that. So branch 1 VH1, how we can do that? Router BGP. Now if I create router BGP here, it can cause some issue because VPN 0 is for OMP. So for the safer side, what I will do, that this interface I will move to VPN 10. Otherwise some issue will get created. So how we can move that interface? It's very easy. Go to VPN 0, no interface, gig E0/1, go to VPN 10, commit and quit. So we are moving the interface. Show run interface, show run VPN 10. You can see. Now we'll go here and we'll do the same thing. VPN 0, no interface, gig E0/1. Now we'll go to VPN 10 and we'll copy paste this configuration. Once we do that, we should go and ping to 4441 and the VPN is 10 and the source is 4442. Count is, wow. Okay, so very straightforward. I move those interfaces inside the VPN 10 because ideally those interfaces should come from service side VPN. So if this is the branch 1 and this is the branch 2, service side VPN, it should be service side VPN. So VPN 10 where I have 4444.0/30 IP. Let's create the BGP. So we'll go here and the conft VPN 10 router BGP autonomous system 100 address family IPv4 unicast. Neighbor is, what is my neighbor? 4.4.4.2 whose remote AS is 200. It's very much like Cisco. And the address family IPv4 unicast, commit and quit, and 100% like Cisco ASR. Cisco ASR also you have to do like this. Router BGP 200 address family IPv4 unicast, neighbor is 4.4.4.1 and the remote AS is 100. Then address family IPv4 unicast, commit and quit. Once you do up to this point, you should verify the neighbor. So we'll go to show BGP and you'll see the neighbor for VPN 10. You should see this establish keyword. So now it is showing established from last 7 seconds. The same thing will verify here also. Show BGP neighbor for VPN 10 establish. Now the next task here is to create one network and advertise. So for that what I'll do, I'll go to, from here I have to create and advertise. So I'll go here to VPN 10 interface loop back 44 IP address 44.4.4.4/32 no shutdown, and then let me commit this first. Then inside router BGP, so VPN 10 router BGP that is 200. See here the change. Here I don't have option to do the advertisement. I should go to address family. Once you are inside the address family, then you have option for the network or redistribute. These are the commands to do the advertisement. So what's your IP? Your IP is 44.4.4.4/32. Let me verify this. is the IP, and then commit and quit. So let's see that what configuration we have for BGP. So we have created the BGP neighbor relationship as a eBGP. So this is the command for that. Inside the address family IPv4 unicast, because BGP is very much address related protocol, means you have multiple options, address families, identifier, sub address families, identifier, etc. So we are using IPv4. You may have IPv6, you may have VPN v4, you may have L2 VPNs. There are so many things inside BGP. So once you do that, now next, because you have done the change, so you can go and check the BGP routes. So you should receive this 44 is coming from the neighbor. This is valid and best. Now suppose this particular route you want to send to the other devices inside the fabric. So we have eBGP relationship, 44 is coming, 44.4.4.4 something is coming to here, but you want to send to the other routers, then BGP need to be advertised inside OMP, correct? So we'll go to OMP and then we'll use the keyword advertise BGP. Then it will go to the other devices. So if you go and check show run VPN 10 OMP, nothing is there. OMP advertise BGP. I think there is no other option. OMP advertise and BGP, and that's it. So that means this will get advertised to other devices in the fabric. I should go and check this in the VSmart, because if VSmart will get it, he will send to all. Show IP route VPN 10. We'll do this thing because he is understanding only the OMP. Wow. 44 is going to the VSmart. Yeah. Nowadays, the interviews are becoming very tricky, and we should have the expertise in the domain to crack the interview. This series I have prepared with 25 interview questions related to Cisco SD-WAN. So let's start all these questions one by one. Let's start with question number 1. What is that? So maybe it can be asked that what is SD-WAN? Explain various components of SD-WAN. Means you have existing network, then why you are going to expend money and you want to upgrade the network to SD-WAN? What's the benefit we have with SD-WAN? Now, what interviewer can expect here that we should give him the top features in the SD-WAN, so he obviously gets satisfied. The first point we have, and if you go and see different type of SD-WAN designs, you will find that industries and companies, they don't want to have their data centers, they don't want to have their own IT infrastructure, but they are very much prone to host everything in foreign location. So for example, cloud. So they don't want to manage the entire data center because of the specific specification of data center area, or the area should have proper cooling, cleaning, cabling, power, etc., etc. So overall, there is operational cost, there is expense to manage the data center rather than what they want. So that's why all these cloud solutions are very popular nowadays. Either it's AWS or Azure or nowadays Google as well. That when we are using cloud resources, so at that time we are not investing much for developing or to invest much in design for the say infrastructure, in-house infrastructure or on-premise infrastructure. That is one way of cost. The other way of cost you can think is that say for example MPLS circuits. Now, everyone knows that MPLS circuits is quite expensive. I personally have seen designs and we can think this as a modern network design is that in SD-WAN you have control plane and data plane. Not only control plane but management plane and orchestration plane. You have what you can do that you can decouple. We know that SDN is decouple of control and data plane. So you can decouple this and you can host over Cisco cloud. Again, Cisco is using, or they can use any of the cloud to put their controllers. So they can install their controllers over AWS. Now what I am responsible is to manage the data plane devices, maybe VH and CH. Now, instead of MPLS link, what I can do that I can go and use the internet link. And again, I told you that personally seen that instead of say for example 100 MB MPLS link, nowadays it's common de facto that companies they are using 1 GB internet link, and even the cost for 1 GB link for internet is less than 100 Mbps MPLS dedicated link. So on that we can see the operational cost, even the cost for the MPLS versus internet is quite interesting. So companies are looking to save the cost, so that's why they are looking for the SD-WAN solution. Apart from that, you can see the reliability and SLA, but more so we can argue that we have better visibility in SD-WAN. You have one common dashboard. From there, you can manage your entire SD-WAN fabric. So that's one of the nice thing we have. Now, when we are talking about reliability and SLA, that we can track the SLA, we can check the reliability of the circuits. Everything is transparent and visible from the management plane. Again, cloud integration is there. So we have inbuilt feature, say software as a service and infra as a service. And from same vManage dashboard, we can track the feasibility or the health score for the SaaS hosted application and IaaS hosted application as well. 100% this is secure. Cisco SD-WAN is the most secure one we have. So now you can see that you are getting the features related to cost, related to visibility, cloud integration, security, and then finally we have the app route policy and app firewall policy. So not only that we can create the policy related to IP addresses, subnets, etc., but we can leave those things. We can leave IP addresses and those things apart, but we can create policies related to application. So for HTTP, for voice, for other bulk traffic, uh, for high, say for example, mission critical application or high sensitive application, we can give some more bandwidth. We can prioritize some higher bandwidth link rather than the low bandwidth link. Again, we have option that if we have zones, by default we have zone based firewall in the SD-WAN solution. So we can integrate and we can do the app route firewall policies as well. Okay, now so maybe the follow-up question, so once you explain all these things, follow-up question may be that how you can do this. Obviously, when the how thing is coming, that means the interviewer, he wants to go deep inside your knowledge. So how means, say for example, if you are creating the cloud related policy, so for that you should go to vmanage and you should go to configuration, and then you will get options related to cloud on ramp for SaaS and cloud on ramp for infra as a service. For this, for security, again we have a different dashboard. So inside policy we have security policy. You can go and provide the security policy. For app route policy and other policies, whatever policy you have, again policy is divided into two parts. You may have localized policy, you may have centralized policy. Local policy, global policy, you can think like that. So anyhow, the policy that you have to create from vmanage, you can go and go to the policy section, you can create the policy. This will get pushed to vsmart, and then vsmart will go and push to vEdge. If it is a data policy, it will be downloaded. Control policy will reside at the level of vsmart. Okay, so this was the interview question 1 and the solution as well. You can refer this video. If you have any doubt, you can obviously play, pause, you can redo these things over the video player. All right, so let's stop here and we'll go to the question number 2. Now the second interview question may be that what type of branch design we have with Viptela. Now different vendors, they have different type of combination, or they have different type of design. So for example, if you read some of the books, you'll find that few of the vendors, they are categorizing their branches, so for example, as a platinum, as a gold, as a silver, and bronze. So what does it mean by platinum, gold, silver, and bronze? Is that here you have high level of redundancy, then you have mid level of redundancy, low level of redundancy, and you may have one router. So what does it mean? It means that in a branch you may have 2 routers, and then you are behind the firewall, and then your traffic is going in and out. Now the mix here you can see, and this is just a hint that you may have mix of MPLS, or you may have MPLS both, or you may have, say for example, right here, so you may have MPLS, you may have MPLS internet, or you may have internet, correct? And that's true for platinum, and that's true for gold as well. So gold design may be that your router is directly going outside. Maybe you are making these ISR router as a firewall. So all the rules that you're running to the internet edge firewall, maybe Palo Alto, maybe Cisco Firepower, or any type of internet gateway firewall. So in gold, you may have high level of redundancy, means you have 2 routers. You may have mix of all, but you're not using firewall, although you're going to run all the firewall services over the virtual image of the router or over the router. Then you may have silver, where you have one router with two link, and again these all these links are having the possibility like this. And again, you don't have firewall, or maybe there are chances some of the design they're telling that you may use the data center firewall to redirect the traffic, etc. Again, it depends that what security policy is there and how you're going to terminate your link. And then finally you have bronze, that you have one router and then you have one link, either MPLS or internet. Okay, so this is the way that branch designs are, mostly the branch designs are. And again, there may be some other use cases as well, but these are the high possibility use cases, branch designs that we have at this point of time. Okay, third interview question we have is that to list out the methods for application optimization in SD-WAN. Now we know that SD-WAN we are using at this point of time has major benefit with respect to existing WAN, and we have so many inbuilt tools to do the application optimization. That doesn't mean that we can't use the external tools or we can't integrate the external optimizer. So what are the main tools we have? And here you can see in the hint section that in terms of optimization that is inbuilt in SD-WAN, we can go and use the FEC, forward error correction. Now what is forward error correction is that suppose when you are sending the packets, and remember in Cisco SD-WAN we are dealing with the per flow mechanism, not per packet. But few of the vendors, so for example Silver Peak, they can do per packet load balancing as well. But in Cisco SD-WAN we are at this point of time we are dealing with the per flow load balancing or per flow application that is going from one place to other place. Now when we are talking about FEC, at that time what is happening, that whenever you are sending the packets, at that time you have parity, or you can think mirror of packet. So suppose you are sending 1, 2, 3 and 4, and for those 1, 2, 3, 4, it depends that how much level of parity you have. Suppose if you are using 50% or 30%, so for example 50% means 2 of the packet you have copy as well. So suppose if packet number 2 will get lost, then you have the FEC, means you have the copy of a packet that can be used, rather than you will go and re-establish the TCP connection, because we know that TCP, if any packet loss is there, again it will go and do the retransmission. So this is one of the way to provide the high resiliency. This is one of the way that will actually boost the traffic flow, or it will optimize the traffic flow. Now it is not recommended that if you have a problem with the bandwidth, or if you have less bandwidth, if you have congestion, at that time if you use FEC, it will go and even make things worse. Okay, so FEC will be used in those links where you have sufficient bandwidth, first of all, so it will enhance the performance. Now next thing is the TCP optimization. Again, if you have two devices and one place you have the source, one place you have the obviously the destination. Now this source and this destination, when they are doing the transaction for the application, or when they are working as a server client model, suppose one is the server and one is the client. So at that time they are not thinking that in between they have some network or they have to go through the network. So in that case, if you are using TCP optimization, obviously these devices will work as a TCP optimizer, and they have some sort of cache or they have some sort of algorithm in between, that whatever latency there with respect to LAN. So this LAN and this LAN latency, obviously Then you have the WAN connection. So WAN latency will be very much higher than the LAN latency, but still these devices will do some sort of TCP handshaking in between, and they have some cached buffer, so the overall performance will be very much good. So this source and this destination, they will think that they are directly connected source and destination, because the optimizer in between, TCP optimizer in between, is going to enhance the or it is going to boost the traffic flow. Now again, there is one catch, that this is not a good choice when you have the asymmetric flow. So traffic is going in one way and it is coming via some other path. So when you are designing your routing flow, you should think about the symmetric flow whenever you are going to use the TCP optimization. Now again, we have the application aware routing. That is one of the key function of SD-WAN. Why we want to use SD-WAN? Because my SD-WAN, so either it's a Cisco V-Edge or Viptela V-Edge, or it's a Cisco C-Edge, and nowadays Cisco also using Viptela operating system in their ISR routers. That is model is 1100, that you can go and check. So either it's a V-Edge or it's a C-Edge. In both the case, in V-Edge actually they have the engine known as Cosmos, that is the application recognition engine, or DPI, Deep Packet Inspection Recognition Engine. And C-Edge, the popular term is N-bar, and again Cisco has done lots of improvement in N-bar inside N-bar 2. So we have more number of application added inside N-bar 2, and inside the N-bar 2, if you go and check their design, you'll find that we have something called fast processing, fast recognition of applications as well. So Cisco has done tremendous work on N-bar 2. Even nowadays, we have the VMs, virtual machine for N-bar as well, that you can go and check from the Cisco downloads software side. All right, so what is happening in this case, that whenever application is flowing, these devices, they are intelligent enough to learn the metadata of the application, and with help of those metadata we can go and create either application aware data policy, or we can go or create application aware firewall policy as well. And again, this will provide the optimization inside the SD-WAN. So we have these three inbuilt method. Apart from that, for cloud hosted application, we have Cloud Express, that's the engine, say Cloud Express, and the term that Cisco is using nowadays is cloud on RAM for software as a service. So for example, Office 365 or any cloud hosted application, and then cloud on RAM for infra as a service, that is your services are hosted over popular cloud vendors like AWS or Azure or Google, etc. So in that case, these devices, let me clean the slate here. So these devices means this V-Edge or C-Edge, they can work as a gateway device. They are working as a gateway device, and with help of Cloud Express, at this point of time, up to 8 applications, they can do some sort of load balancing. So suppose going via one gateway, the loss latency jitter is not good, then it will go and redirect and it can go via the other gateway. So some rerouting, some performance analysis, everything will happen, because for those applications, for those SaaS based application, we are sending some sort of HTTP packets just to check that the application is live or not, application is up or not, and then we are determining the loss latency jitter with respect to OMP Cloud Express. That's the term we have, and then according to that it can go and do the change in the routes. Okay, so now you can see that we have 4 very important methods. Apart from that, we have QoS and how intelligently we are going to apply the quality of service. So either it's a QoS for the WAN interface in the in and out direction, or QoS for the LAN interface, how we are doing the marking, how we are doing the classification, etc. Okay, so these are the inbuilt features that we have in the Cisco SD-WAN. Okay. Now next to this, what are the other stuffs we can do? So maybe in interview you can get the follow-up question that how the TCP optimization we can apply. So we can apply over the device as well, means you can think like conft global configuration mode, or you can go per VPN and then you can apply per VPN as well. So that's the model of application. Then how we can go and apply the app route policy and QoS. Now in the modern code like 19 and 20, those codes you can go to the vmanage. There you will get the option to create the policy inside the say for example inside the data policy you have app route policy. Even inside data policy you have QoS policy as well, but QoS policy can be used as a device specific configuration as well. Next very important question can be asked that what about policy? What type of policy we have inside the SD-WAN and who has the authority for these policies? Now we know this cycle that we have vmanage as a management plane, we have vSmart as an intelligent device in the network, and then we have the data plane devices like vEdge or maybe CH. So this is the order. Now this is the intelligence, this is the brain, say inside the SD-WAN. But what we have to do that we can go and use the GUI of vmanage and we can create the policy. Now this policy will be pushed to vSmart and then vSmart will go and push those policy to vEdge or CH. Now suppose if it is a data policy, the vEdge or CH will go and download that policy. If it is a control policy, then it will go and reside at the level of vSmart. So when we are talking about policy, we have two different type of policy. We have control policy and then we have data policy. Now both the control and data policy can be centralized and localized. So these policies can be centralized and these policies can be localized. Now the very important difference between the control and data policy is that control policy is unidirectional, data policy is bidirectional. Data policy will be downloaded by the device's control policy will go and reside at the level of vSmart, and that's the term we have CAE, configure, apply, execute at the level of vSmart, that is control policy, and then you have CA, configure, apply at the level of vEdge, at the level of vSmart, and then the execution will happen at the level of vEdge, that will be the data policy. Okay, so that's the key difference we have between the control policy and data policy. Now control policy at this point of time you can think that is the routing policy, and routing means we know that the vSmart understand only one protocol, that is the OMP. So OMP related attribute and routing policy will come under vSmart policy, correct? So that can be the answer for this question, but still if we want to learn more about that, so again, so for example I have policy and then policy has control policy, and this policy is control policy and data policy. So for example, let me try to read one more time. So we have the policy and this policy is control policy and data policy. Again, these are centralized, localized. So let me write here localize, centralize and localize. Now the centralized control policy is itself a control policy where you can go and do so for example route leaking, service chaining, traffic engineering, etc. Now this localized control policy may be local to the device, as name suggests, the localize. So they may be any type of route policy or route filter, etc., etc. Now, when we are talking about centralized data policy, so example will be app route or any type of data policy. Data policy name itself data policy can be a centralized data policy. Now, when we are talking about localized data policy, so that may be QoS, that may be any type of ACL, that may be port mirroring. Okay, so that's the difference. We have the first portion of this question. What is control versus data policy in the given list? Okay, so if we have the list, suppose if someone will tell, okay, I have list of policy like app route, cflow or net flow. I have data policy, I have VPN membership policy, I have control policy, and inside control policy again you can define so many policies, correct? So this app route, cflow, data policy, they are data policy. VPN membership policy and control policies are the control policy. Okay, so that could be the answer for this question, and that's it. So let's just stop here. Now the next tricky question, question number 5 may be, what is packet out of order in SD-WAN and how SD-WAN solve this issue? Now this may be not related to Cisco Viptela, but this may be related to other SD-WAN solution, for example, Silver Peak, because Silver Peak is purely, or they are creating purely optimized solution, and the code or the algorithm of Silver Peak is used by so many vendors. So many vendors, they are using Silver Peak optimization code. Now Silver Peak is also in the SD-WAN market and it's doing good. And the concept actually belongs to Silver Peak SD-WAN, packet out of order. So suppose if you have your optimization device and then you are sending the packet obviously in order, but because of two different ISPs, so for example, one is MPLS and one is internet, somehow you are sending per packet load balancing, or some packets you are sending via one link, other packets you are sending via other link, other tunnel. So when packet will reach here and maybe they reach by, suppose you have sent 1, 2, 3, 4, but they reach 4, 3, 2, 1 or 1, 2, etc. How you are going to reassemble this, because this is in not in order. So from here the packet 4, 3 goes, from here 1, 2 goes, and because here you have loss latency jitter, so to reach the packet in this particular place there may be delay. So that's why your packet is not in the order of 1, 2, 3, 4, and that's the mechanism called packet out of order. Now Silver Peak devices, they are basically for not only for optimization, but they are very famous with the optimization techniques and all. So they are somehow keeping track of the packets, that if it is in out of order, they have the capability to reassemble the packet at the destination, and then it will go to the end host or end machine. Okay, so that's the issue we have, packet out of order. Cisco SD-WAN can use this method if we can go and integrate maybe Cisco optimization technique or Cisco optimizer. In Cisco ISR, we can create, we can install virtual images, or we can have the container for optimizers, or we can use Cisco standalone app optimizers. So options are there, or we can use some other third-party optimizers as well, who can assemble these packets if the packets are out of order. Okay, so this is the answer for this particular question. Again, if you want to learn more about packet out of order, you can just do a little bit of search, some sort of Google, and you'll find some more explanation about POC, packet out of order. This actual term is POOC, P and double ONC, packet out of order. Okay, all right, so let's stop here. Nowadays, it's very common in the interview that people can ask you that what type of licenses we have in SD-WAN and why we should use one versus other. Now here you can see in the license that we have three different type of license. So for example, we have DNA Essentials, we have Advantage, we have Premium. The question here is that DNA is something that used in a campus fabric, and SD-WAN is a WAN technology. First of all, why Cisco has given this DNA name for their licenses. The Cisco long-term goal is this, that from DNA GUI, that is the DNAC, in final integration, once you reach to, for example, they have phase 1, 2, 3. Once you reach to final phase, and once you integrate DNA with SD-WAN, so then from DNA GUI, you can manage your SD-WAN resources. And that's why they have given this DNA option inside their licenses. Now, if you want to learn more about this capability and licenses, you can go and check this URL. So let me quickly go and log in or open this URL. So let me open that. So here you can see the URL, and here you can see all those three licenses. We have Enterprise Secure WAN. Let me quickly scroll a little bit up. So you can see those licenses name and details. So here you can see that you have Essentials, you have Advantage and Premium. Now, if we are in the Premium, that means each and every feature of SD-WAN will get supported. Mostly, people are not using Essentials because they have base features. So you can think that basic and then advanced and then very advanced like that. So basic and advanced, and then you have advanced plus license like that. But yeah, most of the companies, they are using Advantage license. Obviously, the other side also, you can go and check that what is the cost as well. So here, that Advantage versus Premium, what's the main difference? So in Advantage, you can see that it is supporting the WAN edge, centralized management, unlimited segmentation, and the cloud integration, both software as a service, infra as a service, colo facility, WAN optimizations. We have the analytic and assurance. Analytic, again, that is the V analytic. Then they are supporting Cisco SIG Essential, something like security group tagging. And then they have the Cisco Thread Grid Sandbox integration. These two features you can see, they are there in the Premium. So they are not there in the Advantage. And maybe different companies, they have different type of security option. So if they are using some other vendor like non-Cisco security options, or if they have those options, then the best option for those enterprise level industry or companies, that they can go for DNA Advantage. All right, so these are the licenses and the use case we have, and this could be the answer for this question. Next question is quite tricky, although it's a very small one, but it's actually very interesting. Explain the hardware and software types in SD-WAN. Now, if someone don't know that we have mix of so many different type of hardware and capabilities, so he can caught in the interview. Now, starting with ENCS, that is Enterprise Network Compute System. So what does it mean? Suppose if you have a virtual branch, means you have branch, but you have put all the virtual image. So for example, either CH, VH, plus you are using third-party vendor virtual software like Palo Alto, or maybe F5 load balancer, or any other optimizers as well. So in that case, you can go and use ENCS. If you want to learn, understand more about ENCS, you can go and refer ENCS 5100 and the data sheet, or 5400 data sheet. You will go and get the list of the capabilities that it is giving inside the SD-WAN. Next, again, if we come and see, we know that the evolution of SD-WAN is, Cisco SD-WAN is from Viptela. So that's why you can see that we have the Viptela hardware, so V-Edge 100,000, 2,000, and even we have 5,000 as well. Now, if you want to use new hardware and if you want to use some less cost hardware, you can go and use VH. VH devices are also great, and they are supporting because they have the native SD-WAN image, so they are supporting almost all the features that we have from day zero inside the SD-WAN. So it is good, stable, and it is supporting so many features, actually all the features in SD-WAN. Now, Cisco has added some new features as well. So for example, security related features that is not added inside VH. Again, you can go and compare the chart, VH supported features plus Cisco CH supported feature or CH supported feature, and you will get the information, but you can't do the security inside the VH, although you can create the zone-based firewall. Now, when I'm telling about security and why the ISR devices can do the security features, because ISR devices, they have very good amount of RAM. There you can go and put some sort of secure virtual images, and with help of that secure virtual image you can go and take the role of IPS IDS or URL filtering or AMP, TG, etc. Okay, so that's capability and feature that ISR is giving with respect to security feature that is not there in VH, but there are so many features that is supported in VH, or that is supported more precisely inside Viptela operating system, that is not supported inside the ISR or ASR. Okay, so for example, cloud related features, or for example, tracking to the WAN interfaces. So these features are not there in the ISR or ASR routers. Now here you can see that suppose a customer has a requirement that he want to use Viptela operating system inside Cisco hardware, correct? So at that time he can go and use ISR 1100, 4G and 6G. Now they are supporting native Viptela OS, and native Viptela OS means the native SD-WAN code. On other hand, the iOS XE supported platforms like ISR and ASR, where we have to go and patch the code for SD-WAN. Okay, so one place you have native operating system, other place you have the uh, code patching. So obviously you can understand the baseline feature in between that. Now again, if your requirement is very high throughput, so in that case you can go and see that the ISR 1000 and 4000 and ASR 1000, the throughput capabilities, the ASR can support from 2.5 gig to up to 200 gig PS, GBps. So that's the thing, that if you have the high throughput requirement, you can go for ISR and ASR. Now you can think that, okay, what is the throughput for ISR? ISR is still supporting a less throughput. You can check the datasheet, maybe in range to 1 to 10 gig, but if your requirement is more than 10 gig, again you can go and check the datasheet for that. You have to go and use the ASR. All right, so the next portion of this question is, what about the software? You can go to this link and you can go and check various type of image. Various type of image means that various update in the code we have. So now the question may be that which one we should use. Say with respect to edge devices, you can go and check the say iOS XE SD-WAN or V-Edge routers. You can go and check the images with respect to that. So for example, if I go to ISR 4000 and SD-WAN software, here you have the patch for iOS XE. These are the iOS XE, and the stable version, obviously we are going to use the stable version. So in 16.12 we have a stable version, in 16.10 we have a stable version. It is telling that you have some issue related to 17.21R. Okay, so you should go and read the data sheet before going to use these hardwares, this software over the hardware, correct? Now let me quickly go back and let's go and check the image related to the controllers. So if I go here and see the image related to SD-WAN, and I'm looking for vManage. So here you can see that Cisco has released 20.111 as well. Again, you can go click here and you can go and check the release note as well. With 2111 is target only for customer using cloud and ramp for co-location or vBranch. So already I told you that Cisco is not supporting all the features inside the ISR, correct? And in the upcoming release, Cisco is giving the customer new features. So here you can see that 21.1 is target only for customers using cloud on ramp for co-location or the virtual branch or NFVIS. Still, it is not supported in ISR, this cloud features. But yeah, even in the CCI blueprint, we have 18.4 image, and this is a stable and long run image, or you can go and use the 19.22 as well. Okay. All right. Seems my session is time out, but the question is also get answered. So these are the things that we can tell for this particular question. Question number 8 is very important, and this is the sure short question that you're going to get in the interview. Explain ZTP process. What is the difference between the ZTP and PNP? So that's the reason what I have done, that I'm going to give you a great explanation about this, and obviously you can go and refer the Cisco documents as well. Now, when we are talking about ZTP, so let's just start with ZTP. This diagram is related to ZTP. You can see that you have a step number 1 to 11. So first of all, you power on the device, then it will go and take the DHCP, DNS, it will go and contact with the, say for example, ztp.viptela.com or ztp.cisco.com. This is the public orchestrator or public vBond or public server, where you have all the information, and how the information will fit inside ZTP we'll see in the next slide. Then it will go and contact to the local vBond. So at that point of time, this vEdge device, he don't have the system IP, he has 0 or null IP. Now the vBond will offer the vManage address, and once the vEdge will start communicating with vManage, vManage has to push the template, configuration template. And once vManage will push the configuration template, we know that we have 5 mandatory things inside that at least. Then he means the vEdge will get the system IP, and then again he will go and contact the local vBond, and again if suppose the image is not up to the mark, again it will go and contact with the vManage, it will got a reboot, again the configuration will get pushed. Once all the DTLS tunnel or once the control plane tunnel is up and running, then this device will go and join the overlay fabric or the Viptela fabric. All right, so this is the explanation that is expected. Maybe it can be asked that, okay, you're going to connect vEdge 1000, so what port you want to connect? So for that you can refer the document. Some hardware you have to connect with gig E0/0, some hardware you have to connect with gig E0/2, some gig E0/4. Okay. All right, now the second question is that, okay, so what is the difference between ZTP and PNP? ZTP is zero touch provisioning, PNP plug and play. Now the term plug and play that came from Cisco, because now we know that Cisco devices also supporting the SD-WAN fabric. So iOS XE based devices like Cisco ISR devices. Now here you can see in the diagram. So first of all, here you can see on the top that again the same thing will happen, only instead of ztp.viptela.com, it will go and communicate with devicehelper.cisco.com, where you have the PNP server. But now it is, things has been changed. You have to go and create the smart account at the level of, say for example, software.cisco.com. Once you go there, you have option that you can glue different type of virtual account with a smart account. Now, once you have the smart account, or maybe once you have the virtual account, then you have to go and click to plug and play portal. In the same page, you will find one link related to PNP portal. Now, new portal will pop up where you can go and put the device list, all the Viptela supporting or SD-WAN supporting devices you have to put there. You have to go and create the controller profile as well. So once you do all these things, means once you put all the information to the plug and play portal, then it will automatically sync. In vManage, we have that option to sync the information. So it will go and sync the serial number, uh, the file name, the hardware model, whatever information that we are going to put there. And the same thing will go and sync with the ZTP server as well. So that will be here. You can see that will go and help the edge devices, and the PNP is going to help the or going to happen with the Cisco devices. Now again, I have two more slides, so that will clarify the thing. Now we have deployment model. So what type of deployment we want? We want automated. So for Cisco IOS XE, we have PNP. For Viptela devices, we have ZTP. If you are going to use some sort of bootstrap configuration, for that we have IOS XE. If you want to do the manual configuration, so for manual means manually you're doing the configuration. So for manual configuration, you have the support for both iOS XE and edge device. Okay, so this is actually important, and again we have one chart here. So here you can see that iOS XE device onboarding option, where is plug and play, bootstrap, manual supported, which hardware is supporting only bootstrap, ISR 4K supporting actually all three, PNP, bootstrap, manual, 1K also supporting all three. Then about this VS devices they are supporting ZTP and manual process. Now this will be the answer for the question in detail. One of the favorite question in interview is that, do you know what is underlay and overlay in SD-WAN? And can you explain me where is underlay, where is overlay, what is the boundary between the underlay and overlay? Now once you answer this, then maybe the follow-up question is, so can we redistribute in between the underlay and overlay and vice versa? So let me give you the answer. The overlay protocol is OMP, that is Overlay Management Protocol. Behind the scene, if you go and check OMP, you'll find that it's very much influenced by BGP, or in loose term, you can tell that it's like custom made BGP. So taken attributes from BGP and then added the attributes of SD-WAN, and then we have the Overlay Management Protocol. Now the OMP protocol is the only protocol that my control plane, and we know that control plane is the vSmart. So vSmart is understanding only OMP. Now in this diagram, you can see that since vSmart is understanding only OMP, and then again OMP has their rules and responsibility, like OMP can exchange different type of data. So OMP can exchange different types of OMP routes. So actually there are three types of OMP route. One is, say for example, service side VPN route. One is services. So services means firewall, load balancer, etc. Any type of security service. So those route. And third one is the TLOC route, transport locator location or locator routes. Now in this diagram, you see that although we don't have firewall here showing, but you will see that, yep, you have service site prefix, a site 1 prefix, and then you have three different transport, internet, MPLS, and 4G. Now at this point of time, we know that TLOC is transport locator, and it has three main attribute: system IP, color, and encapsulation. So here you can see the system IP, and then you have different color for different ISP, say color green, orange, blue, and then encapsulation. Here you can see encapsulation maybe internet, MPLS, 4G. So actually the color, again color, we have you can think that custom made color option we have. Color is also not some networking term, but it's again it's not a label as well. So again, you can think here how deep we are going in the SD-WAN. Color is not a label, but color you can think as an abstraction of ISP at this point of time. So for example, different ISP we are denoting with different color. Your system IP is unique and then color may be same. There are chances, but at least one of the term, say for example, system IP color and encapsulation, one should be unique. Anyways, that's the T-log. But again, in T-log, we have certain attributes, other attributes as well. So now what is happening that all these edge devices, they are OMP peer with the VSmart. Now VSmart is working as a route reflector. So once you send the update to VSmart, it will go and reflect that route to all the remaining sites, all the remaining V edge. So what does it mean? It means that site A prefix, the VSmart will learn from 3 different path or from 3 different color, and then same he will go and advertise the other site. That means the other site, so prefix B can reach to prefix A with 3 different color or 3 different paths. Say if all the attributes are same, then it can do ECMP with 3 different paths. Okay, so now you can understand here that where the overlay fits in, where the underlay fits in. Underlay is your TLOC and the underlay protocol is your IGP protocol. So maybe in the service side VPN you are running EIGRP, OSPF, or maybe BGP as an underlay. Those things, those IGP, we need to redistribute with OMP. So how it is? We can do the mutual redistribution. Suppose if you want to call OMP inside OSPF, go to VPN 10, router OSPF, redistribute OMP like in Cisco we used to do. Suppose you want to send OSPF inside OMP, go to OMP. So here you can see the command is VPN 10 OMP, and then you can use this command advertise OSPF external. Okay, so the answer for this is that suppose if you are able to draw this picture, then it will become very much easy even who is taking the interview to understand that you know these terms and these terminologies. All right, so let's stop here. Again, question number 10 is quite important, that explain the route control option in SD-WAN, and in other terms that what is the central policy and the local policy. Now if you go and check, we'll find that we have 2 different type of policy that we can create. As a policy, inside that we have control policy and we have data policy. Now interesting thing here is that either it's a control policy or it's a data policy. We know that we have again 2 options. So we have option that this control policy may be global or it can be localized. Actually the term is globalized, localized. Again, the data policy may be globalized, may be localized. So that means that policy is global control policy or localized control policy. Now, control policy, you can think at this point of time is very much like routing policy. And we know that whenever we are talking about the routing in SD-WAN, we have the VSmart that they are understanding. They understands only OMP. Correct? So whatever OMP routes we have, so for example 3 types are there. OMP, you can say that service side VPN route or OMP route. You can say services route, like any security route, and then finally you can tell the TLOC routes. So you can play around with, you can do some sort of service chaining, you can do some sort of filtering, blocking, etc, etc. You can play around with these attributes of OMP when you can create the control policies related to either localized policy or globalized policy. When it is coming to data policy, now this data policy, that means that actually the edge devices will go and download this policy. Now again, data policies, they are useful data policies like app route policies, NetFlow or CFloat policy, QoS policy, etc. So once you explain up to this point that what is control and data policy, again there are some difference like control policies, unidirectional data policies, bidirectional, and one of the key thing that in interview people will look for you is the term called CAE. So where you want to go and do the configure, apply and execute. That's the term CAE. If the execution will happen at the level of edge, those policies are data policy. So data policy itself is a data policy, control policy itself is a control policy. Okay. And now maybe as per the skill level, they can ask you that, okay, tell me that how we can go and create the policy and what will be the direction of policy. So that's actually very easy in Cisco Viptela SD-WAN, that first of all you have to go inside policy framework. So this list, that is the interesting traffic. So you may have data prefix list, site list, TLOC list, VPN list, whatever traffic classification you have, that will fall under list. Now that will glued to type of policy. What type of policy? Data policy, control policy, app policy, VPN, etc. So A plus B, that means this is your policy, but you have to apply this policy. And the third section here, you can see that apply policy. Remember, apply policy is 100% of time applicable or applied to the site list. Whenever you will go and apply the policy, you have to go and apply to the site list. Now the next very interesting aspect of this policy is that what will be the direction of policy. So suppose control policy is unidirectional, so you're applying in or out. Remember, out means from vSmart to vEdge. In direction means from vEdge to vSmart, and that's the significance of the direction. So I hope that you understand very important points related to policy, and you can utilize this information. Question number 11. List out high availability option in data plane. Now data plane means that your vEdge or CS devices and the data path. And we know that data path is via the IPsec tunnels. Now here you can see even in the answer also that what are the high availability option we have. So generally what we are doing, that you have multiple links, so link level redundancy, device level redundancy, ISP level redundancy, and site level redundancy. You can do like that, so achieve full redundancy. Now say for example, if I want to have the control plane redundancies, that means suppose if you have less number of ISP connected with one device, or maybe one ISP with one device, and still you want that you can borrow some other control plane, so at that time you can go and use TLOC extension option. Although this is not very good high redundant option, but it's still although we have one physical link, that but we can feel that okay, we have one physical and plus one borrowed, that means we have two or maybe three physical links depending upon how many TLOC extensions you are using. Then obviously we can do the ECMP with the protocol. We know that protocols can do equal cost multipathing. So if you are using layer 3 protocol, say for example IGP or BGP as an underlay, in that case you can have the redundancy in terms of protocols as well. We know that VRRP is also providing first hop gateway redundancy or first hop redundancy protocol, and you can create certain groups, group A, B, C. For some group, the router A will be primary, for some group the B will be primary. Like that you can effectively load balance across the gateway. BFT is nice thing, and I have separate question for BFT, means what type of BFT we have, but what BFT is doing, what's the final goal of BFT. At the moment you create, at the moment your data plane will come up and running, your IPsec tunnel will start forming. At the moment your IPsec tunnel is formed, to check the liveliness even sometimes the health as well, and that's true statement that we are monitoring the health of application that is going via the tunnel with help of BFT, that we'll see in the next slide, next question actually. So at this point of time, just to check the liveliness of the endpoint tunnel or the tunnel endpoint, we have the BFT and how BFT is providing redundancy. Obviously, you are tracking the tunnel in that way. If one tunnel is down, obviously it will fall back to other tunnel. So it was doing ECMP, and then the load will shift to other tunnel if any of the tunnel is down. Now, there may be follow-up question that, okay, VRRP. So now you're telling VRRP, is there any difference between existing VRRP and the VRRP in SD-WAN? And the answer is yes. The VRRP in SD-WAN that we are using, where we can track the OMP. So remember, the VRRP that we are using with existing WAN, where we can track the ISP interface, decrement the priority, etc. Those type of things tuning we can do with HSRP and VRRP. But VRRP in SD-WAN that you can track the OMP, means we can track the control plane, and even further we can track certain prefix that is beyond or behind the OMP. Now suppose if that particular prefix you are tracking is unreachable, that means it will mark that OMP is also down, and then the other device will become active forwarder, or it's become the master and he will forward the traffic. So that's the difference we have in the VRP in SD-WAN. And again, you can refer the document as well if you want to know more about this, but this will be the sufficient answer for this question related to interview. The sure short question that you will get in your interview is that what are the different modes of BFD and what is the use case related to bidirectional forward detection, why it is important, and do we have any other usability of BFT like that? So maybe same question in different styles people can ask you. Now BFT is very important, as we have discussed in the last session, that BFT at the moment your tunnel is up and running, it's a responsibility of BFT that it can track the tunnel. Now on other hand, it's a responsibility of BFT that suppose if you have app route data policy or application route data policy, again those applications that is using the tunnel, so who is going to check the loss, latency and jitter glued with that application? That's the use of BFT we have. So BFT, say suppose BFT is a type of hello packet as well, who is checking the health of tunnel, or in other word you can tell that at least the liveliness when we are talking about BFT hello packet. Here in the chart you can see that we have three flavor of BFT running inside SD-WAN. One is the hello packet. What hello packet will do, it will go like how ICMP echo request and reply is working. You're sending the echo and then you are getting the reply, and then you can measure the round trip. At least one way or one side loss, latency, jitter. Correct? Now suppose if you send 5 ping packets, means 5 echo request and echo reply like by default routers are doing, and then they are giving what is the minimum, maximum and the average of the loss, latency, jitter you can say, or we can say that round trip loss, latency and jitter, etc. Likewise BFT is also doing, but it is doing in much more effective manner, because first of all it has the timer of 1 second. Obviously all these timers that you're seeing here are tunable. You can go and change that. One thing important here, that BFT is per color. So suppose if you have two ISP color or you have two link with two color, that means you have two BFT going via those tunnels. That means you are sending two independent BFT packet, BFT hello packet to reach out. Now think like that you're sending some application, and for that application you have certain SLA parameter. So suppose voice application where loss, latency, jitter you have given very less. It's very, say for example latency sensitive application, or it's a very much say delay sensitive application as per SLA. So who is going to measure? So that's the answer that BFT is going to measure that. When we are talking about one way, at that time BFD hello packet will check one way loss latency and jitter. But suppose you have to examine or you have to collect certain number of samples, and then you have to decide on an average basis. So for that, for sampling reason, we have the bucket feature, or we can see that we have the bucket option. That's the poll interval. That's the second, actually the third column. You can see the uh, when we are coming to the row, let me try to highlight here so you can see here. This is poll interval of by default 10 minutes. That means you are going to sample 600 BFT packet, and those on top of those samples, obviously 600 BFT packet, then you can take the average of loss latency jitter. Correct. Again, the configuration is there, how we can increase or decrease this. These are the default setting. Now the last thing we have is the multiplier. So suppose you have one bucket of 600 sample, but is still with time, means obviously if the time will pass, that bucket will exceed. So to have the history of that bucket, or to collect all those buckets, we have this multiplier. Means the device, they have some sort of buffer, and they are having 6 different, you can think as a bucket of 600 BFT. Not 600 bucket, but 6 bucket. Let me correct myself. 6 bucket, each bucket having 600 samples, and then we are maintaining the history of the average of loss latency jitter. Correct. So that's the correct statement. Now here you can see 1 second and then 10 minute and then 6 multiply means 6 into 10, that will give you 60 seconds. That means 1 hour. So 1 second, 10 minute and 1 hour. And that's the BFT types we have. Remember here is that BFT, that first option hello packet is per tunnel, but the poll interval and the multiplier are per device. Question number 13. What is the difference between feature template, device template, policy template, and security template? And this question may be a little bit confusing because we have so many different type of features, and where to use what for any of the new guys, it may be a little bit a learning curve. So here you can see that, let me try to draw here. Give me a moment, I will draw. Say, for example, you have feature template. Let me write here feature and template. Let me clean and write. So what's the use of feature template? Feature templates are very small templates that can be reused inside a device feature template. So device feature template, this is the actual configuration for any of the device, and again this device feature template also we can reuse. So here you can see that you can reuse first of all the feature template. Even you can create variable inside device feature template, that also can be reused. So now you can understand that device feature template can have n number of feature template. Now when we are talking about configuring the device, so let me go up. You can use the feature template or you can use the CLI template as well. Remember this thing. So you can have CLI template, you can have device feature template, and then you can go and use n number of feature template. Now again, when we are talking about device feature template, so let's focus here, because this is going to be configured, or this is going to be pushed to the device. So what is the hierarchy that we manage is using a protocol netconf to go and push the configuration, say for example device feature template, to n number of VH plus VSmart. Correct? Great. Now you can go to the vmanage and you can create security template as well. you can go to vManage and you can go and create policy template as well. Okay, so now we have these two term, policy template and security template, and where it is going to be used. Now this security template is part of device feature template. So device feature template, you have big template, and if you go and see in bottom, you have something called additional configuration. Here you can go and use the security template. So again, that means the vManage will go and use netconf to do this configuration. But when we are talking about this policy template, so you can go to the vManage label, you can go and create policy template, but this policy template will get pushed to vSmart, and then vSmart will go and push to VH, okay, as per the site list. So you can see that how much difference or variations we have here. We have vManage, and at the level of vManage, you can create, say, feature template, you can create device feature template, you can create security template, you can go and create the policy template. Now this policy template, so policy template will go and push to the vSmart, and vSmart is using OMP to go and push to VH. Here the underlying protocol again is netconf. Now for this vManage, you can create FT or DFT. And remember, FTs are part of DFT. So this device feature template, again it will use netconf. And again this security template is a part of DFT that will go and push to the VH directly. Okay, so that's the importance with respect to templates we have, and that will be the answer for this particular question. Next qualified question we have is that in secure SD-WAN, what security features we have? What are the things we can do over the ISR routers with respect to security? So answer here is that Cisco SD-WAN supports all sort of security features. We can go and create firewalling rule, although this is true with vEdge as well. So cEdge as Cisco and vEdge as well with Tela. So cEdge and vEdge, both we can go and create the zone-based firewall rules. But in cEdge, we can go and create AMP related rule, advanced malware protection, URL or web filtering, IPS IDS rule, and then we can integrate with Cisco umbrella as well. Although vEdge also we can integrate with Cisco umbrella. So what are the new features we have? You can see here new and advanced feature like any next generation firewall. We have AMP, web filter, IPS IDS. Correct? Now the next very important thing here to understand that these devices mean the ISR devices where we are going to enable the security features, they are actually not security device. So that means we need some extra virtual image. So these devices can work as a container, or over these devices, assuming that we have the container functionality, and then we can go and install some other image related to security, and that's the virtual secure image. Can be downloaded from the same place from where you are getting all the softwares related to SD-WAN. So you can install this. Again, there is one very important point. So suppose you go to vManage, because from where you have to create the policies. Your policies you have to create from vManage, and suppose if you are coming to from Palo Alto world, we have Panorama as a central off mode controller or GUI. From there you can go and push the configuration to the different say for example Palo Alto firewall. Same, say for example we have Firepower where we have FMC, Firepower Management Console, from where you can create the policies and you can push to FTD. Correct? So likewise here also vManage is working as a central console or central manager where you have to go and create the policy. Now what will happen in this case, So first of all, you will install the virtual image at the level of vManage, and then you can go and create the policies related to AMP, URL, etc. Now, once you create the policy, obviously you have to push the policy. How it is going to be pushed? Again, in the device feature template, you have one option for security template. So you can create the policy in the security policy template feature template or security feature template section. Then that policy will go inside the device feature template. So that's your template part. Now, once you go and use the netconf, means vManage will use netconf to push the policy to the ISR devices. Once you go and push the policy, what will happen? Because these ISR devices, they don't have virtual image. So first of all, they will contact to vManage. They will download the virtual image. So this will take time. So first time when you are creating the policy, it may take 20 to 40 minutes. Why? Because first of all, he has to, or the ISR or the endpoint devices or edge devices, they have to download the virtual image. Once they download the virtual image, then they will go and install the policy, or then they will go and write the policy over that virtual image, and then whatever flow related things we have, it will work. That I will explain in the next question, that what is the difference between app aware routing and app aware firewall, that we can check. But yeah, that's a very key thing, and it's a very important thing, that what will happen, that when you are creating the policy, it's not like that FMC or Panorama that you create the policy push and within a few seconds it will go and push to the selected devices. First time it will take time, next time onwards when we'll go and create the policy, it will be faster. Now we have tricky question number 15. What's the difference between application aware routing and firewall? Can I apply app aware firewall within the same VPN or VRF? Now this question is very interesting. We know that one of the core capability of SD-WAN is that they are supporting application aware routing. So application aware routing, this is one of the data policy that you can create. So certain application will go via MPLS, certain will go via internet, fallback, etc. So this is one of the capability. Now the question here is that how the SD-WAN devices can do either app route or app firewall policies, how they can do. So the answer is this, that the devices, they have something called DPI, Deep Packet Inspection. Now these DPIs, say in Viptela, that engine is Cosmos, and in Cisco ISR, we know that's a famous term, NBAR, Network Based Application Recognition. Sometimes Cisco is referring as a AVC as well, Application Visibility Control. So this is the engine. What is happening whenever the packet is coming and hitting to the device, they can learn the metadata of that application inside the deep packet inspection. Now your DPI engine can learn, recognize the application, and then either you can go and apply or create the say app route policy, or you can go and create the app firewall policy. Okay, so that's the answer of first part. Now the follow-up question is that, okay, so your answer is correct, that it is supporting app aware firewall. So when I have VPN, say for example service side VPN 10, and then suppose I have VPN 20, so can I go and apply the app firewall to the same VPN or different VPN? See, you can go and apply to the same VPN the firewall rule, there is no problem. But at the moment you'll go and apply, so you can take say source zone for example as VPN 10, and then the destination zone as VPN 20, That time, suppose if we have only firewall rule, this will not work. Before applying the firewall rule, you should have or you must have the route leak policy. So the VPN 10 can leak the route to 20 and 20 can leak the route to 10, and then only you can apply the firewall policy if in case of intra-zone communication. Alright, so that will be the answer for this particular question. Let's stop here. One of the good question may be that what is the difference between or similarity between TPM and TAM? Now we know with the evolution of V-Edge hardware, we have trusted platform module that is nothing but the TPM chip. Inside that, vendors are pre-loading the RSA certificates, and that can be used whenever the vendor will ship that device to the client or to the business unit. At that time, they will go and deploy those devices and they will get authenticated. So it will cut down the number of certification steps or the process, because in certification, if you check controllers, the number of steps are more than the physical devices or than the edge devices. Why? Because already certificates are the RSA, at least the certificates are there in the TPM chip. Now, on other hand, you can see that with the C-Edge devices, with the Cisco devices, we have Cisco Secure Boot method, and that's the TAM. So the same chip module, not exactly same, but same type of concept we have with Cisco ISR as well, where you have trusted anchor module. Now, if you go and do a little bit of search about trusted anchor module, you find that Cisco is using this anchor module in other hardwares as well. So for example, UCS, Unified Compute System. So there also Cisco is using, and maybe in other Cisco routers and other switches also you'll find that Cisco is using this. Why? Because of to protect the hardware. So here you can see in the step number 1 up to 4 that before the actual OS will get launched. So what's the order of operation? That your micro loader in general, the process will start from step number 2, where you have the micro loader program. That's a small program which is helping to boot the operating system. Like that you have this bootloader, so micro loader and then the bootloader helping to start the operating system or run the operating system. But before that we have, so here you can see the micro loader is anchored, or you can see some sort of a screen via the anchor, a small anchor module program who is going to do some sort of code level check, some sort of sanity check, you can say. So that's the thing we have, that in case of hardware protection, we are using this anchor module. And again, you can see what is the difference between TPM and TAM. Both have different type of program, but overall the goal is to protect the hardware. Question number 17. What's the importance of vBond in Cisco SD-WAN fabric? Is this forming TLS or it is using the TLS channel? Now again, this type of question may be underrated, and may we think, okay, because of all the devices in network, in at least with respect to control plane, they are very secure, so they should form TLS tunnel instead of TTLS. Now, what is the difference between TLS and DTLS is that TLS is TCP based SSL, DTLS is UDP based SSL. So if you go and check the specification of tunnel, you'll find that the vSmart and vManage, they can have option, they can use both DTLS or TLS, means it's optional. But for vBond, it's mandatory that they should use DTLS. So vBond, we don't have even option to choose TLS. They are always using DTLS. Now, one of the potential reason for this may be that of the DTLS connection may be faster, although it is not much reliable like TLS, but still what we want from vBond. We want from vBond is to do the authentication related to all the control and data plane devices. Either they are joining the fabric or they are leaving the fabric. In both the case, first of all, they have to go and inform the vBond. And suppose if that time we are looking for reliability or something, so it's not that fair enough that we should use TLS connection with vBond. So that's the reason that vBond is using DTLS. That's the one of the reason, but uh, other reason may be that DTLS tunnel is faster. Maybe there are some sort of acceleration related to DTLS that is not there in TLS. Maybe some hardware related stuffs as well. That number of DTLS tunnel could be more with compared to TLS tunnel in terms of manageability of the tunnels. So these may be the probable answer that choose A versus B. But here is the caution. When we are doing the network design, at that time we should prefer the highest level of security. So at that time what we should do, that for the vManage, for vBond, for vManage, vSmart and the edge devices, we should use TLS. And obviously the vBond is by default using DTLS, so it's fair enough to use such type of design model in terms of control plane and data plane devices. Question number 18. How we can achieve high availability in vBond, vSmart and vManage? Now, it's actually a very tricky question because for all the controllers, we have different methodology to reach the high availability. So first thing should be here that what type of controller deployment do you have? Do you have cloud hosted or do you have in premises? Now, if you have cloud hosted deployment, then at that time, mostly Cisco will take care of the high availability of the control plane devices. But still, how you're going to do the connection with the vEdge or CS devices to the vSmart and vManage, that's again important thing. At least the connection or the control connection between the control plane and the data plane should be optimized. Either it's a cloud-based deployment or it's a on-prem. In both cases, we have to do like that. So suppose when we are inside on-prem, in that case or in that scenario, what about the high availability? So we are doing the DNS method for vBond. That means suppose you have 3 to 4 vBond, and those vBond, instead of giving the vBond IP, we can use the URL or some DNS, and that DNS will be mapped with different vBonds. So if one vBond or two vBond is unreachable, still with the URL you are able to reach to the remaining vBond. Correct? Now for vManage, we are doing the clustering. So we are creating at least 3 vManage in a cluster, and that's the Cisco recommendation. And we should have very low level of latency in between these vManage because the databases are going to be replicated across the vManage. So you have your one logical distributed switch, maybe inside the data center or across the data center. So with DVS, you can have the vManage inside the cluster, correct? Now finally, and the important one, what about vSmart? So for vSmart, we have a technology called Affinity, and what this Affinity technology is doing, or the strategy is doing, is, so let me try to explain here, because it's very important that we should design proper method for vSmart. So suppose if you have 3 vSmart in a data center, suppose I have DC1 and I have DC2, and suppose I have 1, 2 and 3 devices. So what will happen, we know that all the data plane, they will go and form the connection with all the vSmart, correct? And suppose if we have multiple paths, they will go and reach to that particular VSmart with multiple ISP. So that means in this case, you have 3 VSmart and then you have 3 devices. That means your number of control connection is 9. Now think if you have 2000 devices, then your number of connection will become 6K. Number of connection in number of control connection. 6000 control connection unnecessarily you are managing, and suppose if due to any reason this data center is down, you don't have redundancy. So this is not a scalable design. Rather than what we can do here is that we can group the VSmart. So suppose I have group 10 and I have only 2 VSmart here, and then I have other group here, and in that group suppose I have only 1 VSmart, so group number 20, and then one of the, suppose I have 2 VS device. So for one of the VS device, this is the primary and this is the secondary or backup. For other set of VS devices, this is the primary VSmart and these are the secondary or the backup link. Correct. So primary and backup link, you can go and use the connection. Now if you go and see the number of active control connection in this case, that will be drastically reduced to, so from 6K they will go and reduce to 2K, and still you have better redundancy than what we have in the 6K. So this is the affinity feature inside the VSmart designing, and we can reach the highest level of redundancy with this particular feature inside the VSmart. Alright, so remember, we want DNS, we manage cluster, and VSmart, we have to do the affinity feature. Question number 19. It may be scenario based that the interviewer can ask you that suppose if I have data center 1, data center 2, 2 branches and 2 ISP, then you have to go and create a global policy or global rule, like branch 1 will prefer DC1 and then fall back to DC number 2, and vice versa with branch 2 will prefer DC2 and fall back to DC1. So how we can achieve that? Now in this case, say for example, you have DC1 and branch 1, you have one ISP, you have DC2 and you have branch 2 as well, and you have other ISP. So your connection is like ECMP by default, equal cost multipathing. But what we can do at the level of VSmart, we can go and create the rule in a way that the OMP preference, so for example, OMP preference for DC1 will be, so for example, this is 500, and for branch 1, when you are applying the policy to branch 1, and in this direction you can give, so for example, 100. Likewise, for branch 1, you can go and give the OMP preference as 500, and OMP preference for DC1 will be less than 500, say for example 100. Then in this case, what will happen that for branch 1, the primary path will be DC1, but the fallback will be DC2, and reverse will be the case for branch 2, whose primary path is DC2 and fallback will be DC1. So with few lines of global policy, you can see that you can achieve this target, although this will be possible with obviously the routing use case with BGP or maybe any other protocol if we go and tune it. In terms of SD-WAN, it's very easy to do it with the help of OMP route preference. Now we move to question number 20. Question number 20 is also very important and frequently asked question, that what is TLOC and what is the significance of TLOC? We know that transport locator is the glue factor. So your TLOC is the glue factor for the underlay and the overlay. So your overlay is nothing but OMP protocol. Say overlay, that is your OMP, and underlay may be any of the IGP protocol, but the key determining factor is transport locator. With help of transport locator, the vSmart, they will go and reach out to the devices over VPN 0, or they will go, means this VS devices will go and create the data path, or they will create the IPsec tunnels. Now, in this case, suppose if we have two different ISP and we can mark this as a color as well. So TLOC, let me write here, TLOC is nothing but transport locator, and they have three major attributes. They have system IP, color, and encapsulation. This color may be, we can think at this point of time, is the abstraction for any of the service provider or the carrier. Encapsulation is IPsec most of the time, and system IP is the system IP over the box. So the next follow-up question here is that, okay, what does it mean by restrict when we are using restrict? So to answer that, suppose if you have your VS device and you have two different color, you have color MPLS and you have color internet, and then the other side also they have MPLS and they have, say for example, internet. Now if you make this mode as a restrict, so MPLS will form the IPsec only with MPLS, and same is the case with the internet will go and form the IPsec tunnel only with internet. Now if we do not use the restrict, so there may be chance that MPLS, internet, and internet MPLS. But in case of restrict, you have possibility number 1 and then you have possibility number 3. Okay, so that's the use case we have with the mode called restrict. Now we reach to question number 21, where the interviewer is asking that can VH/CH create IPsec/IKE tunnel with non-SD-WAN devices or cloud providers like AWS Azure? If yes, then what type of tunnel? Now this question is mix of many questions. So first question may be that either I have V-Edge device, that's a Viptela box, or I have Cisco devices, C-Edge, over VPN 0 or VRF 0. Can they form IPsec tunnel, say with ASA firewall or Palo Alto or any of the other vendor device like Juniper or any other? So for this, the answer is no. They will form the IPsec tunnel over VPN 0 only with the same Viptela devices or with the same SD-WAN devices. The next question, so this is part 1. The next part is, so can VHCS devices can form the IPsec tunnel or IKE-based tunnel at least with AWS Azure? Now again, here there is some difference. So CES devices, those are the ISR or other devices, iOS XE. And again, you can see the platform. So next generation Viptela devices are ISR 1110, which is supporting everything. They are like Viptela. But for example, ASR and ISR devices where you have upgraded the image and then you are using the features or using the services of SD-WAN. So in that case, first of all, they are not supporting the cloud integration. So they are not supporting cloud on ramp based on software as a service, infra as a service. So no point of making the tunnel over VPN 0, but yeah, you can go and use the service side VPN to reach out to these clouds. Correct? Now, the next question, what about VH? Yes, VH and next generation Viptela devices or ISRs, they can go and create the IKE-based tunnel with AWS, and we can monitor over the vManage dashboard. That's a two-year statement. With AWS, they are forming IKE version 1, but Azure, they can go and form IKE version 2 as well. Okay, so this is the answer for this particular question. Again, you can go and check the new release note. At point of recording, Cisco has already released 20.0 as well. So you can go and refer that as well. What are the features we have in 20.0 image? Question number 22. It is highly recommended that before going for SD-WAN interview, we should prepare this question. What is the significance of OMP? Explain the best path selection in OMP. Now, the significance of OMP is that OMP is the overlay. So if we don't have overlay, then even there is no concept of control plane and data plane. So that's the significance of OMP, because it's the overlay for us. The other very important aspect of OMP is that the only protocol, and that is with respect to routing, that we as smart understand is OMP. So the communication channel between vSmart and vEdge is only OMP. Again, we can frame this in other word. So suppose if the vSmart have to exchange routing information, have to push policy information, have to give or have to share the IPsec key information, all these critical information will be shared with respect to OMP. So OMP is a protocol who is helping vSmart to communicate to VS devices. And again, we know that with respect to vSmart, we can create certain rules. So if we tweak with OMP, and that's the global routing we have, or the global routing table we have. So if we tweak the global routing table, then we can do certain things like service chaining, traffic engineering, route blocking or filtering, etc. at the level of global. Now OMP is active within the vSmart and from vSmart to vEdge. This is not active in between vEdge to VS devices, and that's why the VS devices, they have local intelligence, because they don't have the global intelligence, means they can communicate with vSmart, but one vEdge with other vEdge cannot do the communication with OMP. They have to go via vSmart, or they have to get the information via the vSmart, and that's the significance and the distinction we have in terms of global intelligence and the local intelligence, and who has what type of role. Correct? Now the second question is that what is the best path selection criteria in SD-WAN? So for that I have few slides, and these slides you'll find we have point number 1 to 7. Point number 1 to 3 at least you'll find very much Cisco type. So first of all, you should have valid route, you should have validity of OMP, means OMP should have certain valid attributes to start with. Then the point number 2 is that OMP route is valid if it has been learned from same Viptela devices. Select the OMP route with lowest AD. So we can think like this, that lower is better. So for example, OSPF and EIGRP, who will win? EIGRP, because it has lower AD value. Likewise here also the same type of point we can analyze. Then higher route preference, we know in case of BGP, weight and local preference, if these guys are high, then those routes has much weightage, those route has much preference to win. Here also the same case, and we have discussed this type of route preference in case of local, and let me show you the question number. So we have discussed this in question number 19 as well, where if you give the route preference for branch 1 to DC1 higher, then it will prefer DC1, and then it will fall back to DC2. So first, second, and third points are very much Cisco type. Even point number 4. So first, it will check the OMP route preference. If OMP route preference for certain routes are same, then it will go and check TLOC preference. Again, if the TLOC preference is also by default, you haven't set it, then it will go and check the fifth criteria, that the origin of route. So it's static, eBGP, OSPF, intra, IBGP, etc. And we know this is also indirectly related to AD value. So static route AD value is lower than eBGP, then OSPF, and then IBGP. So for example, 120, 110, and 200. Okay. Then finally, if all these point from 1 to 5 is same, then it will go and match 6, where it will go and check higher route, OMP route with higher router ID, and then finally it will go and check, means if all the criterias are same from 1 to 6, then it will go and check the higher private IP address of the OMP route. Okay, now suppose if 1 to 7 is same, so at that time they will go and do the ECMP, equal cost multipathing. Now there is one note here in this paragraph, in this block, that we should understand. What does it mean? So suppose once you have your IPsec tunnel up and running, that IPsec tunnel is associated with BFT. So BFT is going to track the liveliness of the IPsec tunnel. If the tunnel is up and live, then only they will go and install the fib table. Suppose if tunnel is down, if your BFT is giving some sort of complaint that the destination is unreachable, so at that time the edge devices, they will tell that VSmart that I don't have destination for this tunnel. Then you can go and delete the entry for this particular destination, and that entry is nothing but the fib entry. So remember, there are different type of tables. There is OMP table, then there is routing table, and then there is fib table. That is the table that is used for actual data movement, and that's something ready to go tunnel or ready to go table. So from OMP table, the routing table will get derived, and from routing table, the fib table will get derived, and this fib table is tracked with the BFT. If BFT is complaining, that means fib will go down, but still you have the OMP and routing entries. All right. Question number 23. This is also very important. That what is the key difference between the control policy and the data policy? Can a control policy be a data policy and vice versa? This is very tricky. So control policy, we know that we have two type of policy. Let me write here. So we have control policy, and then we have data policy. Now control policy is, say, first of all, unidirectional. This is bidirectional. Control policy will reside. So CAE, configure, apply, and execution will happen at the level of VSmart. But for data policy, CA will happen at the level of VSmart, while the execution will happen at the level of VH. The third difference is that these data policy will be downloaded by VH devices, and they will be residing at the level of VSmart. So these are the basic three difference between the control policy and data policy. Now the next tricky question we have is that can a control policy be a data policy or vice versa? So the answer is no, it can't be. Control policy cannot become data policy and vice versa, but the same type of problem can be answered from the control policy and from the data policy. So what does it mean? So for example, one of the policy, service chaining, I can go and create with respect to control policy and with respect to data policy as well. Now, service chaining is that you are redirecting your traffic towards certain security devices like firewall, etc. If you create the service chaining with respect to control policy, then you have to apply it in two directions, or at least you have to go and create two policy, in to out, out to in. But the good thing about data policy service chaining is that if you go and create data policy with respect to service chaining or service chaining in terms of data policy, then you have to create it once, because data policy is bidirectional, applied in two direction. So the control policy and data policy cannot be exchanged, but the rules that control policy can do can be achieved from data policy. Not all the rules, but few of the rules can be done via data policy and can be done via the control policy as well. So now we move to question number 24, that is scenario based question, which is asking that we have to tell that how many OMP session and control connection with respect to vSmart1 in case that we have two data center, two branches, two ISP, each data center and the branches having two edge devices. We have one vManage, one vBond, and three vSmart, vSmart1, vSmart2, vSmart3. So what I can do, let me open the whiteboard. Let me draw the diagram. So as per the question, we have DC1. So I have DC1, two devices. We have DC2, two devices. We have branch 1 and we have branch 2. We have two ISP, ISP1 and ISP2, but we have one vManage, we have one vBond, but three vSmart. Now for this vSmart, I'll use different colors. So for example, I have vSmart1, vSmart2, vSmart3. For this vSmart, how many OMP connection? We know that OMP pair is forming within the vSmart. So he has two OMP pair within the controller or within the control plane. Then how many devices we have? First of all, how many sites we have? 4 sites. So 4 into 2 means we have total 8 devices. That means 8 here. So total number of OMP session that the vSmart1 having is actually 8. Then how many control connection? Question number 2. So control connection means that DTLS or TLS connection, that is purely based, we know that is based upon the number of ISP. So for example, for vSmart1, obviously he has the control connection over VS1 and VS2 and VS3, and if these vSmarts are separated across the controller, then that number will increase. So let's try to figure out that how many DTLS and the TLS connections we have. Let me quickly clean a few of the things. So OMP we are done, 10. Now let's try to do the calculation with respect to the TLS or the TLS connection with respect to one of the VS1. So VS1 can go and reach to this and can reach to this over this direction as well, because you have ISP1 and ISP2. So that means that with one device he has two control connection. So you have total 8 devices into 2. The total number of control connection that he has with the edge devices are 16. Again, if we have VS1, VS2, VS3 and vManage1 and vBond1, then we should go and add the number of control connection with these devices as well. And suppose if they are separated across, although the question here is that they are in the same area. Okay, so in that case you can count at least one control connection here, one here, one here, one here. So depending upon number of ISPs if in between, otherwise 16 plus 4. So minimum they have, with this arrangement they have 20 control connection. Okay, so that will be the answer for this particular question. Let's stop. Having same scenario in the mind, now we have other question. We have discussed the question related to vSmart. Now the question is related to the same setup in terms of branch 1 VH1, how many OMP pair, how many control connection, how many data connection or data plane tunnel, that is the IPsec tunnel. In case if the site ID of the branches are different, plus in case if both the branch they have same site ID. Okay, so let's try to figure out this also. We can go back and delete our old diagram, at least few portions. So we have this type of topology, and then let me clean this. So this we have to answer with respect to branch 1. Let me try to draw one circle here for branch 2 VH. So this we have to answer with branch 1. Say this is VH1 and this is VH2. Alright, so VH1 and VH2. And likewise, this is branch 2, VH1 and VH2. Now here the site ID is 300, here the site ID is 400. Focus on this. How many OMP connection? We know this fact that OMP they will form, the edge devices will form only with vSmart. So that means 1, 2, 3. He has 3 OMP pair. Now the second question is how many control connection? Control connection is over 2 transports. So let me delete few of the lines here. When we are talking about control connection, to reach to vSmart 1, he can go like this and then he can go like this. So that means that 3 vSmart into 2 ISP, 6 control connection with vSmart, and then any of the link will be go and preferred for vManage. So 6 plus 1 means 7 control connection with the control plane devices. Now we don't have direct tunnel with vBond1, that is the transient tunnel. That means if anything will happen, then only the devices will go and contact with vBond. So that's why we don't have any tunnel, at least the active tunnel with vBond. So we have the tunnel 2 plus 2 plus 2 plus 1 means 7 control connections we have. Now the follow-up question here is that if we have different type of site IDs, yes, we have different type of site ID. We have site ID 300 and 400. So in that case, how many IPsec tunnel? So the answer is that if you have different site ID, obviously he will go and form IPsec tunnel here and then like this. Again, it depends that the mode of color is restrict or without restrict. If it is without restrict, then we know that the combination is MPLS, 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 internet, internet, MPLS, and then the internet. So assuming that the mode is restrict, so in that case, they will go and form tunnel like this. So how many? Let's answer that also. How many tunnels they will form? Let me draw here. So number of tunnels will be for this VH for this device is 2. So if the site IDs are different, your total number of devices are 8 into 2. So number of IPsec tunnel for this device will be 16. How? You just check one of the data center, DC1. So DC1, how many tunnels we have? 1, 2, 3, and 4. So 4 plus 4 plus 4. Since in these devices we haven't allow command like same tunnel within same site ID. So here you don't have tunnel because they are in the same site ID. So this calculation should be little bit corrected. Actually, the actual number of tunnels should be 12. If you have 3 different sites with 2 devices and 2 ISP. Now the next follow-up question here is, so let me answer this. Answer for number of IPsec tunnel will be 12, not 16. Okay. Now the next follow-up question here is that in case that the site IDs are same. So suppose here also I have site ID 300 and here also I have site ID 300. Then what will happen? Out of 12 you have to subtract 4 because same site ID will assume that they are in the same location and hence they will not form the IPsec connection. So that means your number of IPsec tunnels will become 8 in this case, and that will be the answer. Thanks everyone for enrolling this course. In this course, you will learn all the technologies related to CCI Enterprise. But in case you are looking and you are preparing for your lab exam, please feel free to contact. We are running some sort of 100% guarantee program to make you pass. I will provide you the lab, resources, everything. If you want to know more about this offer, you can go and email to this particular address. Anyways, in this course, you are going to learn all the technologies. This will be very useful course to you. But in case you are planning to write your lab exam, just feel free to contact us. We'll provide you all the guidance, all lab related tips, techniques, all the passing techniques, etc. So please do not hesitate. Feel free to contact us and we will provide you and we will assure you that you pass your lab exam in first attempt. Thank you.